All right, cool. Thanks. Sorry. All right. It's good to be here. Yet another Zcon. Okay. I guess the point of view that I'm Zashi. I'm on the board of Bootstrap. I've been a participant in the ecosystem for basically a decade. And I'm gonna sort of lay out an argument here that I have made for across many different ecosystems that I contribute to, that I would say equally applies to the Zcash ecosystem. All right, so here's basically the sort of core of the argument. Okay, so I just like picked this image kind of at random, but for like probably the last 10 years, this kind of ecosystem page has been the sort of indicator of, hey, like my blockchain project is doing well. Lots of different logos, lots of different teams. Just pick this thing at random. And basically this is like how, you indicated to the market that you were building a system that the blockchain protocol that you built had an ecosystem around it, was being adopted by the market, etc. I think it's become pretty clear that basically blockchains fall into two categories. So there's blockchains that compete as technology platforms, and there's blockchains that compete as like cult assets. So you have this, and you sort of have to pick which of these things that you are as an ecosystem, what space you're competing in. And if you are competing as a technology platform, which, currently it's not like Zcash is neither succeeding as a technology platform nor as a cult asset. There's sort of two different roadmaps. I'm sort of assuming for the purposes of this discussion that like the direction that people want to go is building a technology platform. But there are arguments in favor of going the other direction. Certainly, based on market caps today, assets like Cardano and XRP, which are primarily cult assets and not technology platforms, are outperforming like all the technology platform assets. So there's an argument for going the other way, but let's leave that aside. So like my basic experience has been, or like the challenge with when you're building a technology platform and you're like, hey, our goal is we like have all of these different logos and all of this stuff. The technology platform concept basically has basically a two-sided marketplace between asset issuers and asset users. So what we've seen, and like this is an example from Cosmos about why this sort of many builder, multiple ecosystems builds a thing, construction ecosystem that like doesn't meet the needs of asset users and asset issuers. So Cosmos. So we built this thing. Or a company in the Cosmos ecosystem built this thing, go.skip.build. So Cosmos's like main contribution is we built a framework for building blockchains, which allowed people to issue assets. We built an interoperability framework called IBC that allowed those assets to interoperate with each other. And then, we had this like, you can make another ecosystem app with like thousands of logos on it of different projects, ecosystems, team members in this like network of systems. But then, basically it was a thing that was like extremely hard to use. So we built this thing that was like, or Skip built this thing that was, go from like any asset on any chain, sort of coordinated around the Cosmos ecosystem, integrating many building protocols. But then you have Jason, who is co-founder of Blockworks. You may have seen like he seems to put out roughly 1,000 podcasts a week. Uh, Jason puts out this tweet over the weekend. What's the best way to bridge Ethereum to Cosmos? It doesn't look like. So you have this like incredibly high context person who doesn't, who's like, the system isn't legible enough for him to like discover the core, like the like user flow that will get him what he wants, which is, he wants to interact with an asset in Cosmos, and he's having a terrible experience. And the product exists. Like if you look down here, like I tweeted go.skip.build at him, and it like immediately solved this problem. But you can't onboard users. We aren't like the user flow on sort of both sides of this technology platform buildings. It's like completely illegible because, and like I will argue that the problem with this is the lack of vertical integration. So traditionally, we built the system as like we built blockchains as like a set of puzzle pieces. So you have like some foundation, some entity, some core team, and they do a bunch of protocol R&D. The protocol R&D gets represented as a full node, as a piece of open source software, but there's in general like no user interface to this system. There's no solutions engineering team. There's no, hey, like how do we actually go out and solve a problem for like a specific partner? Generally, all those things are missing. But we have this like core protocol, and then the idea is that like a bunch of independent businesses get spun up, and I would basically argue that like if across all of blockchain for the last decade, none of this has ever actually worked. We've not really been able to like deliver complete solutions that users want. The primary motivation, though, for doing this was regulatory. So the thesis of like, what was decentralization, what was adequate in a world where like no rules were being written in the United States, was that like, okay, well, if you do this sort of subtractive, fragmented, non-integrative approach, you have a strong argument for having a decentralized ecosystem. But the regulatory landscape is changing. The election of the Trump administration, the beginning of the Trump administration, the work that Hester Pierce is doing at the SEC to actually write some rules for the United States. We will get to, hopefully within this year, an actual definition of what aspects of decentralization are important, and what aspects of decentralization should be delayed, ignored, in the favor of product market fit. So it kind of gets to this. So Jill has this tweet. This is the pinned tweet on the top of Jill's Twitter, which is the state of interop, which is really the state of Ethereum. We're all building the same product. So I think in ecosystems that have lots and lots of teams, you are fine, like Ethereum, Solana, etc. You find yourself in this situation where the product, which I would define as what a user actually experiences, like what the user journey actually interacts with, like I want to do something in your ecosystem, requires touching many different teams, which have each have their own tokens, and this gets you to this like sort of place where it's really hard to sort of finally integrate all these pieces into a single product. There's lots of group chats and calls and coordination exercises, but each one is also trying to accrue value to their own token across this process. And it is an incredibly challenging environment to build in, and it's an incredibly challenging environment. And I think like one of the biggest things that I would take away from ETH Denver, from where blockchains are in 2025, is that we frankly all need to be building a much more compelling product that seems much more relevant to the user. We're competing in a very noisy environment. The attention space is being really occupied in the minds of ordinary consumers by AI, and we have to respond to that. So basically, the user journey is all one product. It's wallets, it's block explorers, it's core protocol features, it's the programming interfaces that people consume, especially asset issuers consume. It's on and off ramps, it's DeFi. This is all one product. Now, it's pretty clear that in today's blockchain world, this is an interaction between many different infrastructure providers to provide this product. But unification between the teams that are building significant portions of the stack makes everything else easier. You may, so like if you were to sort of take kind of where we are with Zcash as a protocol, you have the team at Electric Coin Company builds a lot of the core protocol features. They also have a team that's building a wallet. The programming interfaces are sort of split between Zcash Foundation and ECC. On and off ramps, we've seen some progress with integrating those into Zashi. And then Near has, through Near Intense, has brought DeFi at some significant scale to the Zcash ecosystem, probably like for the first time. But like all of these things are the product. Currently, the way the product is presented to the users, there's like significant frictions at various levels. And if any blockchain ecosystem is to survive, we have to like massively reduce these frictions. One of the problems that seems to like recur over and over again in the blockchain space is the perils of shallow exploration of the product space. One of the things that you see, you see this in Cosmos, you see this in Ethereum, you see this in Near, you see this in Solana as challenges. Though I would argue probably Solana is doing the best job of having avoided this, is the tendency of you spin up a bunch of teams through like a grant process with the idea of, hey, just like more is better and more will enable more parallel experiments. The challenge with the parallel experiment approach is that it actually tends to incentivize, especially if there's just sort of like a finite short-lived funding stream, there's a tendency to want to do a little bit of everything, kind of explore lots of things in like a fairly shallow way, without like really committing to like a single product vision, a single solution, a single thing that like makes that solves like a specific user problem, and instead kind of dabble in everything. And you sort of see thank you for the questions to start coming in, but I'm going to just do a couple more slides and then we'll get to sort of discussing the questions. So the benefits of deeper integration are integrating products to create deeper, more complete user experiences. These experiences drive network effects and growth, decentralization. So the basic thesis is I'm really not advocating for like closing blockchains and turning them into Web2 platforms. What I'm more advocating for is investing in like pointed deep in a pointed deep integration into like deep exploration, deep solutions, like deeply solving a single problem. And to the extent that that extracts users, that sort of encourages a world in which someone was like, okay, someone has like deeply built a sustainable business around like one thing using protocol features. I'm going to then start a new thing that deeply solves something that's like in a sufficiently distinct products cache stage. So like, trading versus payments or something like that. So that's sort of like the core argument for why deeper integration is warranted. Okay, so just gonna sort of read off a question and maybe discuss it. Okay, so would having a more vertically integrated stack in Zcash help the speed of development or slow it down? I think the answer is having clear integration between telling protocol engineers like, here is who I'm solving, like here is a distinct user journey that I'm solving a problem for. This is why we need XYZ protocol features. This is why we should prioritize this aspect of protocol development. I think the biggest thing that slows down development is a lack of clear prioritization. And, given that like, extremely finite resources, but like basically every ecosystem at every scale is cannot prioritize everything. And the ability to like sort of relentlessly prioritize things is a sort of huge edge when it comes to speeding up development. So it looks like this approach, the next question is, it looks like this approach needs a central consensus to coordinate it. How do you see that happening with Zcash at the current state? Right now, Zcash, really doesn't have that many different actors in the ecosystem. It's a relatively small ecosystem, sort of coordinating between like Shielded Labs, ECC, Zcash Foundation. There's a relatively small number of wallets. There's just like it's a relatively small ecosystem. I think that the biggest opportunities are in like really in like sort of but I think that there has been a tendency in the Zcash ecosystem to want to have like side pocket bets. The like side bet, and this like sort of emerges out of like the like Zcash community grants, etc. I think we've like done a lot of improvement in the governance of ECC. We've done a lot of improvement in the governance of the Zcash Foundation. I think that there's a lot more opportunities for tighter coordinations. Cool. Okay, taking your argument, Zcash deeply solves on-chain privacy. What should it do instead? So on-chain privacy is, so, there's sort of been this argument, hey, like privacy is a feature, not a product. I wouldn't necessarily kind of go that far. But The biggest challenge of Zcash right now is been that it solves privacy for a single asset. It solves privacy for Zec. Um, and it's become pretty clear that the strongest use case um, for blockchains is asset creation, asset issuance, assets trading, asset transfer. Um, and so ZSAs and multi-asset shielded pools seem like the natural evolution of the on-chain privacy product to sort of meet the needs of the market. Um, but I think that there has been sort of um, you know a lot of missing questions like what is the asset creation story? Um, how do people create assets? Um, how do people manage those assets in wallets? How do you leverage things like the DeFi ecosystem to enable like liquidity and trading for those assets? Um, and so I think that like the question has been like really comes down to, you know, asset issuance is like a huge and relevant piece. It's probably the most important piece of the puzzle. And uh but it needs like a unified product experience. Any more questions? I think that's the same question again. I think this approach has so the question is this something that is better to think about before launching, or does it still have benefits as it's implemented now? Um, I think that like taking a more unified product oriented experience basically can uh 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 can be implemented at any point in time in blockchain life cycles. Um, my general sense of the world is that basically no blockchains have product market fit today. Um, uh, we are in that sense. Well, yeah, I would only the only blockchain that has product market fit today is Bitcoin. And it's not really product market fit as a blockchain; it's product market fit as an asset. Um, and then every other blockchain is in this like tech is either in this cult asset or tech platform war that is still emerging as a in terms of product market fit. Um, I think that the biggest argument is that I'm making here is to kind of have Zcash like really sort of start saying we're not as interested in taking our finite resources and allocating them towards like a portfolio of bets approach. Um, the portfolio of bets approach like really seems to work well for is like an approach that like works well for like individual asset allocator or a fund. But products are not that. um, Products um, are user journeys and about creating like a compelling reason for a user to use a product and return and keep returning. um, and it's a challenge to do all of this in blockchains. Like, I mean, it's just like an enormous struggle. And none of this is easy. But like the portfolio of bets approach um, probably is not something I would continue to advocate for in the ecosystem. Cool. Was that the last question? Ooh, one more. What do you think the ecosystem should work on that is not being worked on now? I think that the core, I don't think that the question, I don't know that the question is what isn't being worked on now. I think the question is, I would say that the current, that the challenge with every community, with communities just in general, right, is, you have a bunch of typically traumatized token holders because of the price action. You have a community that is dissatisfied with progress so far. And I think that the question is to sort of understand people's desire and support the desire, not naively. So, okay, cool. So support the desire for like a more unified product experience. Like it's on the builders to sort of define what those experiences are going to be. Okay, and so then the question is dominant asset is asset issuance and trading. And the question is that forward looking or backward looking? So I think like one of the like honest answers is, as I've said, in my sense of the world is that very few like nothing in blockchain has product market fit truly today. But it's probably worth, well, okay, I'll take that. Stable coins have product market fit. Stable coins have product market fit in blockchain. I also said Bitcoin. So those two things I will probably say have product market fit. And the problem with searching through this design space is like you need feedback from the market. And so I think that, my expectation is that we're going to see, or I'm broadly hopeful that we're going to see, the embrace of things like social coordination, on-chain governance, credible commitments, all of these things. But it seems like those things need to branch off of the core asset issuance, stablecoin, et cetera, use cases. I mean, I think this is very general, not really applicable, not just mostly a conversation about Zcash. But this is like the reality is we kind of have to start where there is a market and engagement and users and sort of linearly iterate off of that. I think like if you kind of compare it to like other technology cycles, like what building web pages was and social media was, asset issuances to blockchains. Thanks. Thank you. Goodbye.
There were 6 original members of the ceremony. One of them, whose pseudonym was John Darberton. And he's a world famous household name, but I don't know if anyone will ever know who he was.
One of the things that really took me down the crypto rabbit hole was the ceremony.
The ceremony.
The ceremony.
Ceremony.
No cryptocurrency has ever launched with a more detailed process than Zcash's ceremony. Zcash is a privacy-preserving cryptocurrency that allows users to create end-to-end encrypted transactions. But to start Zcash, the inventors encountered a few challenges.
There's this critical problem or stumbling block, which is somebody has to generate the parameters. They have to generate this cryptographic structure. And if the person who generates that cryptographic structure secretly keeps the key that they use to generate it, then they will be able to counterfeit money.
When launching Zcash, developers create a special key that is used to lock the code that runs the currency. With the code locked, no one can generate any counterfeit transactions. But there's a catch. Users would have to trust that the developer who locked the code also destroyed their copy of the key, and that no one else duplicated the key. This issue became known as the trusted setup problem. In order to launch Zcash, the team devised a way to pull off the trusted setup as safely as possible.
One way to mitigate having to trust one person to do this computation correctly is to trust that at least one of many people did the computation correctly.
By involving multiple people, they divided the control. Now, instead of just one key locking the code, there would need to be 6. And as long as just one of those 6 people destroyed their key after the setup, Zcash would be launched successfully. So in 2016, they carried out this process in the ceremony.
There were 6 original members of the ceremony, and I recruited a few people who knew about Zcash. One of them was a hacker who was a Bitcoin hacker. One of them was this information security consulting company that we had hired and paid to both do the ceremony honestly in one room and also to attempt to hack the ceremony as best they could in the other room. And then there was me and my friends that were part of Denver Station. Then there was Andrew Miller and Peter Van Valkenburg in their separate locations. And there was a 6th person whose pseudonym was John Dobbertin. We kind of hinted that John Dobbertin was a pseudonym, but nobody knew who John Dobbertin was or anything about him.
After the original 6 members successfully completed the ceremony, Zcash launched in October 2016, but it underwent significant improvements in the years that followed. To upgrade the currency, they would have to conduct the entire ceremony process again.
We did the 2nd version, and that version had some science upgrades that enabled us to have a large number of participants.
That's what we did 2 years after that when we launched an upgrade to Zcash. We involved multiple people, at first 6 and then hundreds of people.
But despite the success of both ceremonies, a problem remained.
People don't necessarily trust the trusted setup, even if there's 1 million people. How am I supposed to believe that they were honest, and how am I supposed to believe the ceremony even took place, and so on?
It doesn't matter how good the trusted setup is. It's not good enough for trillions of dollars, billions of users, hundreds of years. We gotta do better.
Getting rid of trusted setups is ideal.
At the time, the science needed to make highly scalable zero-knowledge proofs for systems like Zcash didn't exist until 2019, when Sean Bowe made an unexpected discovery.
So I spent a long time trying to come up with a way to make it more efficient. I just stumbled upon a technique to do this zero-knowledge proof construction on completely ordinary elliptic curves. And so over the course of maybe 24 hours, it went from, ooh, that's really exciting, that'll be neat if we can do that, to, holy crap, now we don't have trusted setups or anything. It's all really simple. It was a series of steps that turned from a nice insight into a complete paradigm shift.
Sean Bowe had solved the trusted setup problem, and with it, he'd solved a long-standing issue in cryptography. His discovery is already being deployed and built on by researchers and businesses.
There's really nothing that compares to that feeling of being a high school dropout that contributes something significant to cryptography and the history of cryptography. That's really cool. I think that's, I'm really lucky to be able to do that.
Getting rid of the trusted setup meant that the greatest risk of counterfeiting had been removed. Sean's discovery had made Zcash significantly safer for the future. They called this new upgrade Halo.
That is what we're about to activate in Zcash mainnet. Zcash will be, for the first time, a completely private money system in which there's no questions anymore about how you set it up, because there is no setup. It's just pure math. Trusted setup is a thing of the past.
The discoveries in the Halo system unlock the potential for Zcash's future.
The new Halo-based payment system, it could be really powerful for both interoperation and also for scalability.
It's just about making sure that the protocol can support all 8 billion people on the planet.
Halo offers new avenues to increase Zcash's usability, and by eliminating the need for trusted setups, it offers a chance to let go of the last secret from the ceremony.
Oh, I've got to look at something. Oh, awesome! I'm so glad I looked at this. Last night, I sent a letter that meant a lot to me. Are you recording this? You should record this. Last night, I sent a note to John Dobberton. Sir, I said, long ago, about 5 years ago, I told you I would keep the secret of your participation in the ceremony until you told me it was okay to share it. And just now as we started recording, I got a message back from John Dobberton. He said, as long as it's clear that I was never paid and had no stake, it was just a public interest thing, I think you can tell people. And today, I can finally let go of the last secret. Are you ready?
So, who are you? Can you confirm that you are John Dobberton and that you participated in the Zcash ceremony? And can you tell us why you participated?
Okay, there's a lot there. But, my name is Edward Snowden. I participated in the Zcash original ceremony under the pseudonym John Dobberton. The reason that I did that was I saw it being worked on by a number of trusted academic cryptographers. And I thought it was a very interesting project because when we look at cryptocurrencies in general, we generally see the cryptographic properties of it being used to make sure it's a fair ledger, but not that it's been used to ensure that it's a private ledger. Bitcoin, quite famously, is an open ledger. The problem with that is you can't have truly free trade unless you have private trade, and you can't have a free society without free trade. And so, you know, I didn't design algorithms or anything like that. I left that to the people who actually knew what they were doing. But when it came to this concept that they needed many people in many places, all cooperating, in the hopes that just one of them might not be compromised, might not work sort of against the public interest, and that was necessary for the ceremony to succeed, I was happy to say, sure, I'll help. But the best step forward beyond the ceremony is to remove the need for it entirely. And I'm just really happy to see that the Zcash project, which, you know, I've never really worked intimately with, has managed to keep moving beyond, you know, the initial steps, to keep improving and sort of move us closer and closer towards that ideal of a free currency, which is also a private currency.
A couple of years ago, I would have been more firmly in the kind of, you know, like Tezos, EOS, whatever camp that says there should be explicit on-chain governance. And now I'm like absolutely against that, and I think that stuff is crazy. So if you look at EOS, EOS has these 21 delegate slots. And to get into one of these delegate slots, you have to basically vote or you have to have people with enough coins vote for you, right? Now, in total, about 17% of the EOS holders have voted at all, and out of those, the delegate that has the largest number of votes is Bitfinex, and Bitfinex only has about 3.5% or so of all the ETH voting for it. Out of that 3.5%, 1.8% is coins that are owned by Bitfinex themselves. And the other 1.7% is just random people. So with that 1.8%, Bitfinex was basically able to single-handedly get themselves into this list of 21 delegates when they otherwise would not have been able to get in there. And what this privilege gives them is it basically gives them the ability to take a share of the 1% a year annual interest that's allocated to Bitfinex, or that's allocated to EOS delegates. So basically, what this voting mechanism has created is it creates this kind of superlinear pro-plutocratic effect where if you're big enough, then, and specifically if you're big enough to have more than 1.8% of all the coins, you have enough votes that you can use to basically buy up a delegate slot and then use that delegate slot to earn even more money and get access to this crazy special 2.64% extra premium interest rate that no one else has access to. So that's one example of how I think like coin voting governance really manages to fail in the case of allocating capital. And I actually do think that allocating capital really is the kind of killer app of on-chain governance, basically because like ultimately in terms of quality of decision making, right? Like, I mean, I obviously have the public opinion that Bitcoin's governance has been like fairly bad because it's like overly conservative and values very specific things to much more extreme extents than most actual users of the technology. But aside from that, I think like Ethereum has been fairly capable of just delivering on feature improvements that people want. Zcash governance has been very capable of delivering on a roadmap that I think Zcash constituents are really happy about. Like Bitcoin Cash is starting to push out changes. Like all these other blockchains are starting to launch, and like Monero is doing like community hard forks every 6 months. And I do think that like on the protocol level decision making side, there just isn't really a case to say that this off-chain governance really has serious problems that need to be solved. Now, the one big argument that on-chain governance has in its favor is this idea that, oh, now you can have these big treasury pools that inflate the currency by 5% every year and then use that to pay out, big bounties and donations. So from a kind of raw and economic power perspective, it has clear advantages. But just the fact that in all of the existing examples of on-chain governance that we've seen, they it creates this mechanism that just can be too easily captured, and even can also be too easily kind of partially captured in such a way that it doesn't fail completely, but at the same time it does create this kind of massive rich gets richer effect where people like at the top of the peak get access to these premium, like 2%, 3%, 4% extra whatever interest rates that no one else has access to, and then 25 years later, the crypto leader by another factor of 2x richer than everyone else. So and then on top of that, there's these issues around bribing attacks. There's these issues around just the facts that if you have 4% of all the coins, you can elect to just outbid everyone else and get delegates. There's the fact that just regular voters don't really have much incentive to actually serve as kind of effective, quote, policemen. So like, I really am just pessimistic about the ability of on-chain governance to kind of really properly deliver on all of those things. And I do actually think that, first of all, like current levels of funding for, at least for Ethereum, are definitely just enough, and I don't think that you can really get that much further by increasing that by a factor of 5 or whatever. I don't necessarily think it's even the right approach to try to kind of have bigger economic guns than everyone else. And then on the Zcash side, like obviously Zcash's pool is smaller because Zcash is a smaller cryptocurrency, but like even still, I feel like like between Zcash, between Ethereum, between different academic groups, between all the open source communities. It just is possible to get enough funding and enough resources to do all of the like hard technological and software development that we want to do.
Next. Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David Duchovny.
Duchovny. Sometimes I think I know too much.
Are the chupacabras real?
Huh?
Have you touched an alien?
Oh, God.
Has an alien touched you?
Why is that line moving so fast?
They're paying using digital currency. Not only is it super secure, it's super fast, and you can buy just about anything.
Imagine what I could do with all that free time. I will save the whales. Behold, I've done it.
Mr. Duchovny? Mr. Duchovny?
Yeah.
Can I get your zip code?
Come on.
I started on this road back in 2010 when I was at MIT working on side-channel attacks on cloud computing and how to steal information from those computers that you're not supposed to trust. And that got me thinking, how can we trust a computer that we don't own, that is somewhere out there, controlled by someone we've never seen, and is running our code and producing output that's sent back to us? And I realized that zero-knowledge proofs, which were back then a theoretical curiosity and fascinating technique, but not on anyone's radar for practicality, I realized that this could, in principle, solve the problem if someone could prove to you that they have run the correct code for you. And moreover, if you actually change them, then you can reason about an ongoing computation consisting of multiple steps, maybe from different parties, that preserves some ongoing property. So with this in mind, I applied to the National Science Foundation for some funding to pursue this direction. And the answer we got was basically, this will probably never be practical, but if it ever were practical, then it could change the world. So here are a few bucks. So with that, we set out, my then student Alessandro Chiesa and me, to explore this notion and We had a series of papers defining this notion of ZK snarks, which distill the requisite properties of zero-knowledge proofs that you would need in these kind of applications, and proof-carrying data, which is the idea of chaining them together. And we started the collaboration with Eli Ben-Sasson and subsequently with Madars at MIT, Madars Virza, to actually implement these ZK snarks. Along the way, a new generation of techniques based on QAPs came along, which provided another approach complementing the PCP-based approach that Eli was leading. And we used these to build a series of prototypes that show that these abstract ideas are actually practical. We actually were able to have a generic compiler that can take any C program and compile it into a new one that can verify itself and produce a succinct proof, a few hundred bytes, checkable in a few milliseconds, that would convince you that the program ran correctly, even if it was on the cloud or on hardware provided by the cheapest bidder. So we were very happy about that, and then we started thinking, what kind of C programs would we actually plug into this machinery? And that was around 2013. And these were just the days when Bitcoin became popular. People realized that, hey, blockchains are cool. And they were also starting to realize that actually blockchains are not private. They are revealing all of their transactions. We heard of that group over in Johns Hopkins that was also looking at that and actually had an approach for solving that, the Zcon protocol, that sort of provides a private version of Bitcoin, but not with all the functionality that you would want, and wasn't fast enough, proofs were too large. And it turns out that the machinery that we had, and we were just so eager to find some nice use cases for, was exactly the missing ingredient in the protocol. So we got together in 2013, and we started scheming and finding out how to compose the ingredients and how to build a new protocol that uses those snarks in a way that is tailored for that application. And that actually worked out. Within a few months, we had the first draft. And in 2014, we presented this at an important security conference, but important for academia. And it turns out that that is not quite enough to make an impact in the real world, because we thought we had solved Bitcoin's privacy problem, and we were waiting for the world to beat a path to our door and use it. And after waiting for a while, we realized that we may need to be more proactive, and that the extra effort required to take academic code and making something that you would trust your mother to put her life savings in. That's not something that can be justified within academic research, and it's not something that was on anyone else's radar. So we reached out to Zcon and to List Authority because of their excellent reputation designing cryptographic protocols for the real world. And together with the Johns Hopkins team, consisting of Matt Green, Ian Mears, and Christina Garman, we set up the Zcash company as the vehicle to create what would become Zcash on top of that zero-cash protocol that we have published academically. That took nearly 2 years of additional engineering effort, a lot of review, finding and fixing bugs, learning about all the extra challenges needed to make things usable and trustworthy. And in October 2016, we actually shipped the code, and that was, I'm proud and happy to say, the most boring launch of my life, because it actually worked. It keeps working to this day, and here we are, finding ways to make people use it.
We're for freedom. Freedom from ads. Freedom from borders. Freedom from the past. From constraints. From scrutiny. From expectations. Freedom to express ourselves. Freedom to choose. Freedom to share. To create. To connect. To flourish. Be free.
I'm Peter Van Valkenburg. I'm the Director of Research at Coin Center, which is a Washington, D.C.-based nonprofit focused on cryptocurrency policy, but I'm also a member of the Zcash Foundation Board of Directors. Coin Center has been around for 4 years now, and our mission is to defend the freedom to innovate using open blockchain technologies, and that means Bitcoin, Ethereum, Zcash, and the like. And really we do three things. We do education, policy research, and advocacy. There are three main branches of regulatory policy that touch cryptocurrency: investor protection, consumer protection, and anti-money laundering, or counterterrorism financing, which you could also call financial surveillance because it's about the government collecting information that could lead to the arrest of those laundering money or financing terrorism. There's also tax, but I hate talking about tax. On the investor protection front, what we've seen over the last year, 2018, has been increased interest of the SEC in people who are creating brand new cryptocurrencies, making promises about them, and fundraising in order to develop that software in advance of releasing the open network. That pre-funding or pre-sale or pre-mine activity in some ways could fit the US definition of what is securities issuance. And if that's true, to the extent that that's true, then there are a lot of people who need to comply with securities laws in order to do that fundraising compliantly. And most people haven't. The ICO boom has largely been a story of people not complying with those laws. So that's been a hot spot. What's heartening about that progress has been that recently the SEC, which has had a steep learning curve and has actually done quite well getting up to speed on the fundamentals of the technology, has come out and said, look, for the truly decentralized cryptocurrencies, and we've heard this from Chairman Clayton and from Director Hinman at the SEC, for the decentralized cryptocurrencies where there is no longer an issuer upon whom people really are relying, people are relying on open source software and an open network of people participating in a consensus mechanism, those things, those tokens and coins are not securities according to our read of the relevant law. And so that's great because frankly, if all cryptocurrencies, especially the decentralized ones, were to be treated as securities, it would be horrible for the progress and innovation of this technology in this country because it would put up so many roadblocks and it simply wouldn't make sense. Who's the issuer of this thing that is now actually part of a decentralized network where we rely on everyone instead of one person? On the consumer protection front, it's always been a focus on the exchanges, really. So the exchanges are the companies out there that you can regulate for consumer protection purposes. They're where most people go and they buy the thing, and they're where a lot of people go and store cryptocurrency. So there the story's been about money transmission licensing in the US, which is basically a consumer protection approach that says only certain people should be allowed to do this activity because it has this risk where you could lose the customer's funds. And so we're going to ask that people get a license in order to perform that activity. And every state in the US regulates money transmission licensing differently. So some states, those laws apply to an exchange, and in some states they don't, and in most states it's unclear whether they do. And then a few states like New York have created new licenses, like the BIT license, as a way of creating a separate licensing regime specifically for virtual currency companies or cryptocurrency companies. So that's
iOS and Android, and we would love your feedback. We'd love for you to use it. Thank you for everybody that have been using it and sending us feedback and giving us ideas. We've built this product for you, so please try it if you haven't tried it. Okay, so the next slide. I'll start by providing an overview of the vision, and then Andrea is going to take you on a journey through what we did last year, the things that we've learned, and then share where we're headed. Let's hit the next one. So let's start from the beginning. We don't have time to go all the way back through the history of money, but let's just say that it's gone through some changes over the centuries. If you hit the next slide. So we'll go back just a few years. So when I was a kid, and maybe it's still true for some of you, we had these things called paper notes that we could exchange. And we were able to put them in little leather pouches and put them into our pockets. And we could buy stuff with it. And if we had these notes, if we had more notes than we were comfortable carrying around in our pocket at any given time, we deposited into a thing called a bank, and the bank would secure them and make use of them for lending. They'd take some profit, and maybe we might generate a little bit of yield on our savings in the bank. Hit the next one. So with the advent of digital currencies, as we kind of humans do, we tried to build digital analogs for the same things. So we created a new kind of leather pouch that was digitized, and we called it a wallet. And likewise in crypto, we needed the analog for a bank. And so we created that as well, and we called that a central exchange. Now that is our centralized exchange. So with the wallets, now we have thousands or tens of thousands or hundreds of thousands, I don't know how many tokens out in the world, and they all have different properties. They do different things, whether they're smart contracting tokens, or you can stake them, or they're meme coins, or prediction market, used in prediction markets or whatever. And then we created these wallets to try to encapsulate all of these use cases, and we created a mess. With a bank, it's basically like a bank. It started as like an exchange, just a centralized exchange for exchanging one token for another. But it's turned into a custodial service. You can stake and earn some yield at centralized exchanges. You can do a lot of the same things that you could do at a traditional bank with a centralized exchange. And it's gotten so much, the wallet kind of experience has gotten so bad, and the bank experience has gotten so good in terms of the user experience, that many people actually don't even remove their cryptocurrencies from the exchange. They just speculate on them and keep them locked there. The next slide. So we fell into this trap. When we invented Zcash, we worked hard first to get them, into some wallets, but only transparently, because shielded Zcash, if you weren't around before 2018 or so, shielded Zcash couldn't be used on a mobile device. Just wasn't possible. So the only thing these messy wallets could use was transparent Zcash. And then we worked with exchanges to get it listed. And really the only thing they could use at that point was also transparent Zcash, because it didn't scale, wasn't performant. But even as it became performant, we went back to these exchanges. We went back to the wallet providers and pushed for them to add shielded Zcash, to use the privacy preserving properties of Zcash. And quite frankly, most of them couldn't be bothered. There were some that did, like Edge and Unstoppable, but most did not. And most of the major ones, most of the ones with the highest amount of adoption did not. Likewise with exchanges, they refused to do it. They couldn't be bothered. In some cases, they want to be able to trace their users, and they didn't want the ability to, or a user's ability to have their funds shielded. Some of that now is, I mean, it's gotten like it's gotten even worse, right? Where governments and it's not just regulatory, but there's been actual overreach at some of these banks where banks have been these centralized exchanges have been asked to provide, you know, additional information beyond even maybe what's legal. They want to be able to surveil, they want to be able to control. And so this adoption of this supposed unstoppable private money has been slowed. So we could continue to weather this storm. We could continue to try to push against these winds and work to comply with these exchanges and work to comply with these wallets, or we can choose a different path. The next slide, please. So I say we opt out, not by giving them the middle finger, but by building something better. Next slide, please. That's why this last year we launched Zashi. So yes, Zashi is a wallet, but Zashi is really intended to be a new integrated financial system to store, to spend, to swap Zec privately, freely, securely. Next slide, please. We envision it being made up of three parts. The one that we've launched this last year is Zashi, the wallet. So the wallet is used for everyday payments. You carry it around in your pocket, just like you would carry around a leather pouch. It's optimized to help you do day-to-day things that you want to do with your Zec, like buy a cup of coffee or pay for your burrito. We envision Zashi Vault to be a digital safe for storage and advanced features. It's intended to be your own private bank. You own it. There's no intrusive KYC. There's no centralized authority to shut you down. There's no authority needed because you are the authority. And of course, all of these are enabled by the Zcash protocol that protects your privacy and provides all the decentralized rails that you need to be able to support this. The next, please. So here's some things that we're building for the Zashi wallet. Andre is going to spend some more time on some of these things that are coming in the near term, but I want to focus on a few of them. So if you've used it, you know that it's a simple, low friction mechanism for payments with Zec. So we actually want to build the capability to be able to send and receive shielded Zec in 2 seconds or less. And so there's a question about how is that even possible? How is that even possible given 75-second block times and the number of confirmations that you need? Sean is working on some interesting research. Our team will be working on some interesting research to allow these kinds of fast payments, instant payments, what we call. We want to support multiple accounts. We've integrated with Flexa for payments, and we'll continue to look at more options related to payments. So Flexa is presenting here today as well, and so hopefully you'll catch Trev's presentation. We want to enable payments through a DEX, and this for some people I think is maybe a little bit counterintuitive. So most people think of a DEX as a swap between yourself. Like I'm going to swap my Bitcoin for Zcash, and I'm going to keep both in my wallet. But DEXs unlock a pretty cool kind of capability to allow for a sender and a receiver to transact without agreeing on which coin that they want to hold. So if I have shielded ZEC and the person that I'm sending money to wants to receive USDC, then I can use a DEX, and I can send a payment through that DEX to that end user. So that's something that we'll be exploring. We'll be adding auto shielding. Today in Zashi, you have to make a decision to shield the funds that are received transparently. We want to give people the option just to turn that on so that it would just auto shield. We're looking at cross-chain payments. So, with the recent integration with Near, but other chains as well. We're looking at liberated payments. I know the Zingo team is looking at the the same capabilities. So the ability to send a payment via a message that someone can claim, and if they don't claim it, you can get the money back. We're looking at social key recovery, looking at mechanisms to allow you to roam and minimize your risk when roaming. So if you're crossing borders or you're traveling, somebody gets a hold of your phone, somebody forces you to open your wallet, how do we make that less risky for our users? And then people want the ability to send, receive, and swap Zcash shielded assets, which is something that we'll look at when that's available. For Zashi Vault, again, it's intended to be your own private bank, so it doesn't exist yet, but we plan to build it for you. And so some of the capabilities that we see as important are these that are listed, and we're learning though, and we need your feedback, and we've been doing user surveys, and so thanks for participating in those and the user interviews that Tatiana's been running. But these are some of the things that we think should be in there, and some of the things that you told us should be in there. So we want to make this a secure place to store your ZEC and your ZSAs, to include the hardware wallet support here, Keystone and maybe others, to be able to support multiple vaults, to do things like time locks, so that I could send a transaction that has that's kind of time bound. So money it's sent, but it's not delivered for some period of time, and then I have the potentially to either redirect those funds or revoke those funds, should I want to do that. But to be able to do that for security. Address whitelisting, looking at multi-sig with Frost, advanced key recovery and management, duress lockouts, legacy transfer, so inheritance, and we'll touch on that in a upcoming screen. Being able to generate yield through staking and delegation based on the work that Shielded Labs is doing to incorporate that in. Lending and borrowing cross-chain, so access to DeFi through these other chains like Near. Agentic automation, if I have like scheduled things that I want to use my shielded ZEC for, maybe micropayments or something else. And then coin holder voting is something that we'll add to Zashi Vault. So again, we haven't built the software yet. We intend to build it with a great user experience, the kind of user experience you've come to know in Zashi, but it's still built for normies. It's more complicated, but it's still built for normies, and it provides more tools to help assist users with a kind of a deeper understanding of advanced features and how to protect the privacy. We're currently working on design concepts, and so some of these is what we're sharing today. Next one. So while we envision this being packed full of features, we envision actually the user experience to be adaptable with capabilities that can be turned on or off based on user preferences. So we also want to make it intuitive to set up multiple vaults protected by multiple keys for your ZEC and your Zcash shielded assets. As I mentioned, Tatiana has run some initial surveys, and one of the kind of interesting insights that came out is that while most Zcashers that participate in the surveys feel confident about their ability to store and manage their shield ZEC, most are not confident in their ability to for their loved ones to be able to access the ZEC should something happen to them. So something like inheritance becomes really important. If I were to die, would my family be able to get access my assets? And so that's why many people will use a centralized exchange. It's like, if I use a centralized exchange, then perhaps it will be easier to recover those assets. So in this case, we plan to designate beneficiaries to users' vaults so that funds are easily recoverable by loved ones if needed. So we're still in research and planning, and we're going to look for the funding needed to build out the project. If we can get it funded, then we'll get to work right away. Again, please let us know what you think. And with that, I'll hand the keys over to Andrea, who's going to lead us through the rest of the presentation.
Thank you, Josh. Hello, friends of Zcash. My name is Andrea, as you probably understood. I'm with ECC for a year now, and I'm the person who is product and project managing Zashi development. Thank you so much for joining us and for being curious about Zashi. My plan today is to take you on a journey, report on what we have delivered, how we made it happen, what impact it really made, and what are our next steps and plans when it comes to Zashi. A lot to cover, so let's jump right in. And I will start by saying that I think that we have a lot to celebrate and be proud of when it comes to Zashi development and growth as a product in 2024. And I would just love to demonstrate to you why I think so. So Zashi release timeline was set at Zboot in February, and we made it to production within 2 months on iOS and 3 months on Android. But we also shipped many more releases after that. Majority of the features and integrations we built were to facilitate payments and storage of Zcash. Some were to comply with bigger community requirements like support of text addresses or ZIP 320. I will talk in greater detail about the integration, but I should also mention that we delivered some pretty major features this year, like request ZEC, so ZIP 321 support in cooperation with Paku, privacy-preserving currency conversion feature, which fetches exchange rate over Tor, address book feature, initial implementation of node management, which now allows Zashi's users to send more transactions one after another. We also introduced Spanish localization, and on top of that, we progressed through a massive UX and UI redesign. One thing that you have to understand first is that at the time of Zboot, the ECC team was really undergoing a massive transition, and it opened the doors to the community for the first time in a very long time. I joined ECC right about that time, and I could follow how Josh, as the new CEO, brought in the essential transparency for the community, and he also introduced a strong vision for Zashi as a product, with which united the team around this common mission. By the way, if you haven't seen it, Josh had a State of ECC presentation earlier, and he talked about this in greater detail. So if you missed it, make sure to check it out. Zboot, as you can see in the photo, was a literal new dawn for the ECC team. As captured by our iOS developer, Lukáš, in the early morning hours in Palm Springs, what started at Zboot was a transformational rebirth of the team's direction and ways of working. Our number one Zashi goal was set, and that was that we need to ship, and fast. And ship we did, right? Zashi 1.0 on iOS went live at the end of March. Android followed a month later, and we shipped on Android about 15 more releases that year and about 18 more on iOS. This, what you have just seen in the short a clip is a list of product issues that we have completed and delivered in the subsequent releases. And it doesn't include bug fixes, needs to be said. Our number 2 Zashi goal was to deliver products that drive adoption of Zcash. And all the decisions we made last year, we try to make with this principal mission in mind. From Tatiana's research, we learned that ZEC payments are good for Zcash. She was able to identify a general pattern that users who transact in Zcash are more likely to recommend Zcash than users who hold it. And so we realized that focusing on facilitating payments in Zcash could be the ultimate driver for its adoption. And so we did what we do best, and we shipped some solutions. In September, while redesigning the app and adding other useful features to Zashi, we released the Coinbase on-ramp integration, which allows Zashi users to top up their wallet directly inside Zashi. Users who are based in the US can do so with just a phone number and a debit card. Users who are based elsewhere can do so by authenticating with their existing Coinbase account. No hassle, no frills. Your Zcash is going directly to your Zashi wallet, and you can right away start using it and transact. The next feature or integration that was a massive accomplishment was a payment with Flexa. In November, we rolled out this integration that was highly expected, highly desired, and right now, Zashi users can pay at supported merchants in Zcash without the need to exchange it first. So far, only users in the US, Canada, and El Salvador can benefit from it, but Flexa is working diligently on expanding their availability as well as the merchant pool. You will hear from Trev later today, so make sure not to miss his talk, because that's the future of payments, friends. I hope that you have already got a burrito and paid for it in Zag. If not, you gotta try it. It feels amazing. The launch of Flexa was embraced and followed by a huge wave of support, not only from the Zcash community, but also from the AMP community, whose cross-promotional efforts had direct impact on Zashi downloads and kept this information trending on Twitter for days to come. You can observe the spike in Zashi iOS downloads on the launch day, or right after the launch day on November 26th, which is the biggest spike in downloads since Zashi's launch at the end of March. And similarly, you can also see an apparent spike on the very same date. And again, it's the biggest one that we have seen since launch of Zashi Android. So undeniably making impact. Number 3 goal that Josh kept reiterating at ZBoot and the subsequent summits was to have user-friendly access to private storage. And so the whole team united again around another mission right at the end of the year. And that mission was to deliver shielded hardware support for Zcash. Thanks to their incredible effort and expertise, and also thanks to the Keystone team, who I have to say were nothing short of amazing, we fulfilled another Zcash's dream, and we released Keystone hardware wallet integration right before Christmas. Not many people know, but imagine that the integration with Zashi took us only 5 weeks to deliver. It's an incredible milestone for the Zcash community and also for the ECC team. And I also have to mention the revolutionary work that Strat has done on the PCZT implementation or partially constructed Zcash transaction, which made it all possible. The reactions from the community were, again, overwhelmingly positive, and I think both the ECC team and the Keystone team should feel rightfully extremely proud for making this happen so fast. Another reason why the team should feel proud is the movement in the shielded Zec supply and in the orchard pool in particular. As Josh mentioned in his previous talk, the Zashi release and Keystone release have undeniably impacted the rise of the shielded Zec pool. Before Zashi, the shielded supply was right here at about 200,000 Zec, and at the beginning of this month, we surpassed 1,200,000 Zec. So, talking of driving adoption, right? From the recent user research surveys that Tatiana has conducted, we also can see that the Net Promoter Score has significantly improved for Zcash in particular, and also it's looking very promising for Zashi. If you're not familiar, the Net Promoter Score is a market research metric that reflects how likely a user is to recommend a product or service. It ranges from negative 100 points up to the positive 100 points. Obviously, the negative ones being the absolute hell and the positive ones being absolute heaven. As you can observe, the NPS score for holding Zcash and transacting in Zcash in general has progressed from -60 to getting to positive numbers in the year 2024. And right now, the NPS score for holding Zec is 21, and for transacting in Zec is 33. You can also probably observe that Zashi's NPS scores are even higher than Zcash's, which in translation means that users are more likely to Zashi than Zcash, and also that they are more likely to recommend it for transacting in Zec rather than holding it. Speaking of Zashi Vault. When we set out on the Zashi mission, I heard Zcashers say, why can't we ever have nice things? And so we say that Zcashers can have nice things. And in the spirit of that, we redesigned Zashi into what it is today, a slick, user-friendly platform for private payments. You can observe all the differences when taking a closer look at the redesigned home screen. We try to build on top of the existing brand, but also focused on improving the UX and UI experience and elevating the designs. This is our redesigned Send screen. Right now, you can also sign transactions with Keystone, not just send from Zashi. We also redesigned our Receive screen with plenty of very useful user feedback. We got rid of all the confusing terms, and we created a design that kind of softly nudges the user to lean towards using the shielded Zcash, which is the goal. You can also see how our settings screen grew with the introduction of other powerful features like the integrations I was describing before, or address book, request Zec feature, and others. I think it looks like we are moving onward, right? So allow me to spend a little moment reflecting on some of the major changes that happened in the ECC team this year. We had quite a few impactful hires, including me. I have joined the team as a product and project manager in February, and I try to do my best to manage our product development process and support cross-team collaboration inside the ECC team. We hired another Android developer, Milan, who helped us bring the platforms and releases into sync. So right now we are coordinated on both iOS and Android. Tatiana has come back to the ECC team to support our roadmap planning with her user research efforts and lead Zashi product marketing. Pablo joined the team, and with his help, we took the Zashi design entirely in-house, and he is actually the person standing behind the updated Zashi look. Lastly, Dan also joined the Zashi team, and he's doing a fantastic job helping us with QA, user support, and community management. But I have to say that it wasn't just the new hires who made this happen. It was the culture of discipline and high standards that Josh has set for the team, which is keeping us focused, productive, and agile. The incredible dedication and professionalism that this team is bringing to the table is something to be envied by any high-performing startup. And I have to say that I know I'm biased, you guys, but I have, this is not my first rodeo, and I have to admit that these are some of the smartest people I have ever had the pleasure of working with. And we continue to ship, and that's what matters, right? Releasing things and iterating with you, our users. Don't forget, in 2024, we made 16 Android releases and 19 iOS releases. We also started doing all-hands quarterly roadmap planning. Twice a year, we meet in person, and we also include selected community representatives. We adjust our roadmap quarterly, and we do it for a very good reason. It allows us to stay agile, to plan in real time, and prioritize developing things that our users and community need, and also things that we believe are going to ultimately help drive the adoption of Zashi and Zcash. A few more thoughts about the process, which is based on iterating with our users. Welcome to our feature backlog. This is a place where we collect all the incoming user feedback, regardless of the source. And every quarter, when we do our quarterly planning, we review all the user requests in the feature backlog, and we pull ideas we would like to prioritize into our planning sessions, and then together with the team, we figure out how to make them happen and shape them up so that the users can be excited about their feedback being reflected in what we built and how. One could say we basically redesigned Zashi with our users, because we reviewed and implemented a lot of user feedback as we progressed through the app redesign. Because our process is driven by user feedback, users' problems, and users' needs, we are in a unique position right now to make user-driven protocol changes and build for real-world utility of Zcash, not just for the purpose of R&D discovery. Let me share some exciting Zashi stats with you. Let's start with Android first. Before even reaching its first birthday, which is going to be on April 28th, Zashi Android has already collected more than 15.5 thousand users. Keep in mind that all of these are organic installs we have collected with minimum marketing effort. The trending countries with the most installs on Android right now are Nigeria, USA, India, Russia, and Kenya on the 5th place. Let's have a brief look at Zashi iOS as well. Zashi iOS will celebrate its first birthday at the end of this month, and until today it has been downloaded by more than 8,000 people. All are again just organic downloads. The distribution of countries is slightly different here because it's iOS. Most likely we can see that the US is the top trending country with downloads. Number 2 is Russia. After that, UK and Nigeria, and Ukraine is taking the 5th spot. And so what is left to say? What comes next for Zashi, right? So let's have a look at that together. Recently, we managed to release Zashi Android on GitHub and F-Droid. We wanted to make sure that Zashi is going to be available to users who opted out of the Google ecosystem. So that was something that we owed from the Q4 roadmap. And right now we're working on transparent address rescue to help people recover their funds from transparent only wallets like Ledger. We are also doing research and kind of thinking through the implementation for seed phrase backup. And at the same time, we are proceeding through another batch of redesign. This time, we are starting to focus on home screen and onboarding. While our core team is busy with Zcash deprecation work, we try to focus heavily on mobile-heavy features and try to utilize any intersections with features that are getting currently built for the CLI wallet Zale, like auto shielding, address rotation, or send controls. We have other big priorities for 2025. The major one is, of course, making Zashi the best-in-class shielded wallet. But we will keep updating our roadmap every quarter to reflect any progress that we make, any other potential circumstances, or promising partnerships. Maya DEX integration, Maya payments, and swaps are a big one that we want to deliver support for this year. We actually had some representatives from the Maya team over at the ZEC Summit, where we tested initial Maya swaps design prototypes, and we really can't wait to start building things with them. They are fantastic and also very dedicated bunch. Among other things, we also want to look into on-ramp and off-ramp integrations and solutions that could be more widely accessible to users globally. We want to do more research, as has been mentioned by Josh, into instant payments and liberated payments. And we also want to make sure that we support the Zcash shielded assets whenever they become available. We are also exploring other opportunities for partnerships, like working with Brave on the extended memo support, or seeing what we could potentially build for Zashi with near intents, which is another exciting news for the ecosystem. Our other priorities are Zashi Vault, as has been mentioned as well. The plan is to continue the design and exploration phase at this point, and we also included a possible mixnet integration as one of our potential focus areas. Sounds like we are busy enough, right? And time for announcement. You ready, guys? Freshest piece of news is that we have just released Zashi 1.4. And this release includes a massive transaction history design with new transaction filters, with search, with adding notes, private notes, I dare say, to help you remember payment details and other practical improvements. You can also test a new export text file feature, which allows you to download your transaction history for the last year. So please update your Zashi, give us feedback. We would really love to hear it. So one could assume, in conclusion, that based on the data that I have presented, by sharing Zashi, you actually drive Zcash adoption. So don't forget to do it, please. Like Zcash Brazil, who have done a tremendous job very recently with their Zcash booth at Modular Carnival. Real big shout out to you guys. Thank you so much for promoting Zashi. I hope I have managed to demonstrate that ECC has a reason to celebrate. What do you think? Let us know. We would love to hear from you. Thank you to ECC team for making all of this possible. Be proud, you rock. Thanks for your attention, Z crowd. We appreciate the time you spent watching, and nothing else remains to be said than onward. And I think we can have a look at the questions coming in and see if we can get to answer a few. Josh, would you like to start?
Sure. So the first question that came in is, when will we see Zashi desktop? It's a great question. It's come up a few times. So the part of our, we need that feedback as part of the user research. So it's not that we would have, like, Zashi itself wouldn't be ever, Zashi is intended to be a mobile wallet, but Zashi Vault potentially is would have a desktop version if we can get there and if there's enough demand. So will Zashi Vault have premium paid options or features? It's another thing we're exploring. And so there's a question of like what somebody's willing to pay for and like how do we monetize it? So like, is it something that the community pays for and it's completely free? Is it something that users pay for? Is there certain features that people would be willing to pay for? That's been a question in some of the Tatiana surveys. I think one of them came back that, you know, stuff like multi-sig, people don't want to pay for, right? They want that capability. They just expect that capability for free. But inheritance planning, maybe, or white glove service kind of, or, you know, support services, a call desk, a place that you can call and get support, maybe. So the short answer is we don't know yet, but tell us. And we'd love to make as much free as possible. But we also have to like maintain the software. So, and that costs some money. So we just need to figure that out. The other is like the other option potentially is with swaps. So like if we're doing swaps through the wallet, like can we take a few basis points on a swap, and then that funds our work? Again, maybe, but that's part of our research. Next question you can answer, Andrea. Is it a priority to ensure Zashi is the go-to wallet to mint and or hold ZSAs?
Absolutely. I think I made it clear in the presentation as well. It's definitely our priority because we can see the community asking for it. And one thing that we want to make sure about is that we hear the community's voices. So this is one of the principal huge innovations that is going to be introduced with the next network upgrade. And we want to make sure that Zashi is going to be part of it. So 100%.
Okay, this next, with multiple organizations and individuals contributing to the evolution of Zcash, it seems that we all might be in dire need of a clubhouse to relax. I know this is going, and I know who posted this question. Clubhouse to relax, collaborate, and even disagree together. Will any members of the team be in France this summer to join us for the inaugural Shielded Sandbox event at the Zebra Lounge? So it sounds like we need to get more information on what's going on at the Zebra Lounge and the Shielded Sandbox, and I don't have those details. So please post that stuff out so maybe the community can join. All right, this next one is, will Zashi support Orchard only unified addresses? Having the option to turn off transparent support is powerful and useful. Right now, we don't have the intention to turn off transparent address. Now, Zashi is a shielded by default wallet, which means like you can't, if you receive transparent funds, you have to shield them in order to use them. So we don't support like transparent to transparent. So, but the goal is then to have an option to turn on auto shielded. You can see even in the design, like the designs that Andrea showed, and if you've used the wallet, like transparent addresses are kind of like a second-class citizen. So you're prompted through the user experience to use shielded addresses and driving towards, shielded transactions. Any plans to move to a multi-platform framework like Flutter? I'm not familiar with that. Andrea, do you know?
Not at the moment. And I think guys, if they hear this question, they're going to be like, when? We are running in full speed, and so changing the entire infrastructure and building it in a different programming language is, I think, right now out of question. So we do understand that it might have certain benefits because of streamlining the development on the mobile side, but we don't have any plans like that. And we feel like we find certain benefits in having the native, having the Zashi built inside the native environment with Kotlin and with Swift. So no current plans like that.
Okay, so the next question is, when Zashi 2.0, Andrea?
That's a good one. Ask me after the next quarterly planning. I think we have a clear view of 1.4 just went live. We know what 1.5 is going to be, and we are already working on 2.0. So it all depends on what's going to be the final set of features that we want to include. But you know us, we never like to sit on updates. So whenever we have something that we can ship to you guys, we will do so. I also want to get back to one question and react to it. Zashi development milestones have been slower each time as on roadmaps. Is the new roadmap going to be more accurate? Well, we certainly hope so. You should see how difficult it is to get an estimate out of a core developer. But we have to understand that we are dealing with people's finances, right? Jokes aside, and the cryptography that is, involved is sometimes slowing us down, and we have to make sure that we have rigorous review process, and that nothing that could mess up with people's funds is going to go live into production. So it is correct that sometimes things are getting slower, and sometimes they are getting slower because we prioritize other stuff, like Keystone that we delivered in 5 weeks. So I think the agility with making the roadmap and trying to adhere to everything that we put out there, that's why we make it quarterly, and we want to make sure that we improve in our estimates as much as we can. So going forward, you will see some tendency for improvement, I hope.
Yeah, some things like we can get done very rapidly, and you wouldn't expect it, and some things would take a long time that don't seem like they would be that hard, but they might, again, like you're saying, compromise privacy or security, and some side channel attack or something like that somebody doesn't even necessarily think about. So that's all part of the process, but the team's been cranking. So this next one is, what about time locks without revocation? So since a feature suggestion we had to write down, i.e. for estate planning ZEC, be time locked or trust for errors, or create ZEC denominated bonds. Control of keys could be traded at a discount from underlying value of the wallet as per unexpired time on a bond time. This is a pretty complicated, kind of interesting feature request. As funds couldn't be accessed until time lock expires, secondary markets based on spot price and duration time lock would develop. Okay, so that one I think we'll have to come back to. As it relates to errors, that's one of the things we're looking at, is like, how do you manage like multiple errors, and how do you divide that up appropriately? Kind of the initial thinking is that you can have multiple vaults, and the easy way is to allow an error per vault. It's like, how do we keep this as simple as possible for most amount of users to provide the greatest kind of capability and ensure that they're safe and secure, and the product is working in a way that kind of honors that. So, but keep the suggestions coming in, and we'll look at all that stuff. Is Zashi accepting community contributions? What's the best way to start contributing, Andrea?
I actually had an idea in the back of my mind. Somebody mentioned that before. Signal has this donate feature, and other like incredible pieces of tech have something like that. So maybe we could, get a donate feature inside Zashi.
I think
and you could send us some ZEC.
I think that in this case is my guess. My guess is this one's not about money. It's about how can they contribute capabilities, maybe. So
for builders.
If I'm wrong, but maybe we could answer that question anyway. How can devs contribute in some way?
Absolutely. We are all open source. You can visit our GitHub repos. You can get in touch with us. If you want to start talking about anything that you would like to build, the best place to connect with us is our Discord. And so reach out. We will make sure that Dan or me personally can connect you with the right people and set you up, because we do want to make sure that this is a shared effort, and we appreciate any community contributions that we can get. Absolutely.
Okay, I think we have one more question, and then we have to wrap up because we're running over time. So the question for you, Andrea, is, when will Turkish language support be available? My team and I are ready to translate Zashi into Turkish.
I know, it's incredible. We have already a few people offering to translate, and I know that Turkish is one of the languages that people are reaching out. about. So we want to make sure that we create and set up a process for management of the translation, because whenever we do localize Zashi into another language, everything has to be happening in all the languages. And so it brings a little extra overhead for maintenance, for translating release notes, for translating texts for new features. So we have to have a system set up before we introduce more complexity and more languages. And that's something that I would love to bring to our next roadmap planning for prioritization. We also had offers for Portuguese and other languages, and I would love to see that community effort being utilized. So thank you for mentioning it.
Awesome. So I think we're at time. Andrea, amazing job. You're a star. This is fantastic. Thank you, everybody in the community, for tuning in. And
likewise.
Next sessions.
A lot of engineers and technical people often don't realize that what they're designing involves trade-offs that impact end users in important and fundamental ways. A prime example is privacy. And so far, the general sort of status quo with technology is that there's many ways to gather information from multiple angles to build really deep profiles of people that I think violate most people's expectations about the privacy that they have. Like, people don't easily understand what is happening to their privacy in our world with these technological changes. So one of the most important ways I feel to empower users is to give them technology that respects their autonomy and decision making and provides strong privacy and security and safety in general.
Shining like a star. Happy birthday, Zcon. So the emergence of cryptocurrencies, I think, was a wake-up call to regulators. Regulators have been used to operating in a world where they've had a fair degree of control and oversight over financial networks and the transfer of money, whether it's within their jurisdiction or internationally. The emergence of a decentralized peer-to-peer mechanism for transferring value that bypasses all of those traditional financial networks, I think is deeply concerning to them. And they have, been working to understand it and to get comfortable with it and understand how they can ensure that, they can continue to have oversight and regulate this new economic activity. I think they just about gotten comfortable with Bitcoin, and then something like Zcash comes along, which has got, is portrayed in the media as being anonymous and secret, and they've had to then start up that process again of learning about it. But we talk to regulators, we talk to policymakers to help them understand this technology, to help them understand the implications that it has for policymaking, for law enforcement, for regulation, for preventing money laundering and terrorist financing. And once they learn about it, they start to understand that it's not all that different from, say, something like cash. We already have mechanisms in place to prevent money laundering using cash. And when you have something like Zcash, which is effectively digital cash, a lot of those same principles still apply. This idea that it's anonymous isn't really true. If you are depositing funds into an exchange, then implicitly that exchange has to have already done their know your customer checks on you. So they know who you are. They know that it's you that's depositing those funds. And if they need to query where the source of funds are, then they can do so relatively straightforwardly. So a lot of the principles that already exist, and a lot of the techniques that already exist, are applicable to these new technologies and these new currencies like Zcash. And it's purely a matter of helping the regulators and the policymakers understand that fact. So if you take the New York Department of Financial Services as an example, they worked very hard to understand what Zcash is, what the implications are for regulatory and compliance issues. We helped educate them and help them understand those issues. And the outcome was that they granted Gemini, permission to add Zcash to their exchange. And the reason they did that was because they had gained that understanding. They were comfortable. They understood that Gemini would still be able to fulfill its regulatory obligations, that the fact that it was Zcash instead of Bitcoin had no impact on that whatsoever. And the reason that they were so keen to put the effort into understanding it is because they recognize that they have a key role to play in helping New York maintain its position as a global financial center. And if they overregulate and shut out this new industry sector, this new type of finance, then it's simply going to go somewhere else. So around the world, there are regulations and legislation that recognize the importance of personal financial privacy. In the United States, you have the Gramm-Leach-Bliley Act. In the EU, you have the GDPR. It's a theme in today's world where you have issues like the Experian hack, concerns over how data is being shared on Facebook, that people are growing more and more aware that they need to protect their personal data. And financial data has a need for particular protection because it reveals how much you're getting paid, how much you pay in rent or mortgage, what magazines you've subscribed to, what websites you subscribe to, where you shop, what your hobbies are. There's a huge amount of information that can be gleaned if you can get hold of someone's credit card statements or bank statements. Now, when cryptocurrency go mainstream, if cryptocurrencies don't have technology in place to protect their users' privacy, then all of that information is going to be exposed to the world. So it seems strange that regulators would try to discourage the use of cryptocurrencies that include such privacy protecting technologies and encourage ones which are going to expose users and consumers' information to the world at large. I think there is an argument for saying that actually, if you're going to offer cryptocurrency-based services to users, you at least need to make them aware of the privacy risks that they're incurring if they're not using privacy-protecting currencies. And secondly, to encourage exchanges and payment processors and so on to support currencies like Zcash that protect users' privacy.
Hi, everyone. Thanks so much for having me. Today, we are going to talk about a private shielded path to better payments, or the alternate title, hard forking the payments timeline to better protect our personal data. So I gave this presentation at ZEC Summit back in July and was asked by Josh from the ECC to share it to this broader platform. Really, really excited to be here today. Been a fan of Zcash for a long time, as you'll see. I was asked at the ZEC Summit to give an overview of what we're building at Flexa and why we think it's important to the future of payments. This presentation is going to be a little bit more personal than most presentations that I've given, because privacy is honestly a huge part of why I am doing what I'm doing and why Flexa does what we do. And so I'll start with speaking a little bit about me, then I'll share 3 discoveries we've made over the course of our journey here at Flexa, talk about why payments need privacy, and opine a little bit on what happens next. So about me, my career so far is really this 15-year preoccupation with getting to the bottom of why payments are so broken. A lot of people would probably call this just working from first principles, but to me, it's more like a giant machete-driven journey through this incredibly unforgiving and confounding jungle of pre-internet decisions that have somehow been haunting us and come to undergird our entire global society for the last 75 years. And so, as you'll see, a lot of what we do here at Flexa is organized around trying to make sense of that mess and ultimately helping to rebuild commerce on top of a more solid and sensible foundation. And profession-wise, despite my title, I would consider myself more of a designer. I've always had a preoccupation with how people interact with technology, and specifically how they do so at all different scales. So thinking from city scale and urban planning, all the way to building scale and architecture, down to screen scale for apps and GUIs. During my undergrad career, I thought I wanted to go into academia, and so I started to work at the MIT Media Lab. I found that my research there wasn't really connected to anything that actually shipped. We had all these amazing sponsors, but they cared more really about the marketing blip that they were getting from being associated with the lab than the output and the work we were building itself. So at that point, I moved to New York to join a branding agency. There I worked for a bunch of different large businesses, including American Express. Amex was one of my clients for a few years. They eventually brought me in-house to help design the UI for a big data project. And it was at Amex that I really discovered that credit cards as a business are really just a race to the bottom. And that race to the bottom is engineered to distract shareholders from the fact that everything is truly held together by bubblegum and duct tape. Behind the scenes, everything at every credit card company, most payments companies, is really just a mess of very, very old code and hacks and patches and bubblegum and duct tape covering up bugs. So a few years at Amex, I actually quit to start my own payments company. A few years later, sold that company to another payments company, worked there for a while, and then 7 years ago, started Flexa. And we started Flexa because we had observed this somewhat counterintuitive discovery. And we would call this discovery number 1, which is that most of what we call payments today has very little to do with actually moving money. For example, VisaNet, the network behind Visa, is really just like LinkedIn messages. They represent payments, and a payment is an agreement between a buyer and a seller, but nothing related to actually moving money moves through this VisaNet system when we authorize a payment at a point of sale. That is not known to most people, but a very interesting reason for why we have blockchains. And blockchains are incredible at moving money, but they're pretty lousy for payments. So if you think of things like opaque transaction IDs, or the inability to process refunds, or standardized exchange rates that aren't actually standardized because there are so many different markets or order books backing all of these different digital currency exchanges. We think about the difference between pseudonymity versus identity, and the idea that when we're making a digital currency payment, we're actually pushing funds, whereas when we're making a retail payment with our credit card or even a check, merchants are pulling funds from our accounts. All of these things make blockchains amazing at moving money, but pretty lousy for payments. And we have a nice diagram that we sometimes pull up at Flexa to really illustrate the contrast of this and show where we think things are going, which is to say that when we look at the main difference between credit cards and cryptocurrency, we can arrange them on this 2x2 grid. And credit cards, we would consider, are very good at facilitating payments, but bad at moving money. Cryptocurrency is great at moving money, but horrible at facilitating payments. And so then the questions are, what lives in the other boxes? The bad at moving money and horrible at facilitating payments box, that's very easy. You could think of things like rocks or bunnies. What we're really curious about is what's great at moving money and great at facilitating payments. And one of our big bets is that it has been 75 years of credit cards, but many fewer years of cryptocurrency. And so the likelihood that credit cards move into that box versus cryptocurrency moving into that box seems very, very low. We're putting our money on the idea that credit cards have a 100-year shelf life. We're 75 years in, we have maybe 20 years to go. Let's get cryptocurrency into the spot where it's great at facilitating payments because it's already great at moving money. And so Flexa is really about these three things. It's about building a bridge from the way that payments have worked for 75 years to this new era of payments that's pretty much inevitable at this point. And our mission at Flexa is really about helping sellers to thrive in this new era of commerce, which to us means universal access to commerce and as little personal data as possible. So this is easier said than done. We decided really early on that Flexa could be most helpful as a protocol level piece of infrastructure as opposed to competing for customers with a consumer-focused app or trying to build a new blockchain ourselves. And so Flexa sits at the center of this really nice Venn diagram, kind of the sweet spot of payments infrastructure, but without using cards. And the trouble with this chart, if you can't already tell, is that unless you're a self-custody wallet or a standard or a blockchain, the infrastructure for moving money between buyers and sellers always requires licenses. And licenses always require some degree of centralization, and centralization skews the value chain. And so here was where we made another important and counterintuitive discovery about payments, which is that better payments means centering on sellers. And what I mean by that is that we tend to think of traditional payments, like credit card and debit card payments, as consumer-focused, but in reality, they're more issuer-focused, issuer being a bank, for example. And earlier, we talked about how credit cards don't really move money, and that's because they're not designed to move money. In fact, it's really the opposite. As credit instruments, they're designed to carry a balance, and that balance collects interests. And then that brings about these really perverse incentives around how credit cards get us to spend money we don't actually have. And it's like kind of how in Vegas, the house always wins, except the house is the banking system, and we're all playing a game of cards and points against each other. There's one particularly glaring example of the absolutely bonkers brokenness of payments that I used to spend a lot of time explaining to people before I found this very nice author at Vox who wrote it all down in a very accessible way. Emily Stewart wrote this article about the ugly truth behind your rewards credit card. And the gist of it, and I recommend everyone go and find this article because it's fantastic. The gist of it is that high value credit cards are not evenly distributed. And in fact, because FICO scores were invented in the 1950s, a lot of the classism, sexism, and racism that was prevalent at the time was just directly entrenched into this system of who can access credit card payments via FICO scores. Except that someone has to pay for those airline miles and loyalty points. And so it turns out that these points just get charged directly to the merchants and then baked into the cost of everything that we as consumers buy. Worse still, because low rewards cards cost merchants less than high reward cards, it's the people who can't get approved for these fancy credit cards who end up paying a disproportionate share of the fees. And that effectively creates this tax, as Ms. Stewart argues, that $700 per year moves from individuals who aren't credit worthy, and that eventually forms a bonus of about $1,000 per year to the rich, affluent, mostly male, mostly white people who FICO says are credit worthy. And so we end up with these private companies in Visa and MasterCard who are effectively working against most merchants and against most consumers to entrench this system that is really benefiting the issuing banks who govern Visa and MasterCard. And at Flexa, we don't think that that makes a lot of long-term sense. We actually don't think that there's anyone better placed to make decisions about the costs of payments than the people who are actually selling the things. So we are building modern payments infrastructure with sellers at the center. We really think that payments should be a public good, a public utility, backed by these distributed ledger technologies, and really open to everyone. And we think that starting with merchants is the best way to achieve that. And that leads us to discovery number 3, which is that you can't build better crypto payments by starting from crypto. I've seen this happen enough times, and I think we'll all agree or have examples of this that we can think about as I'm going into this. I'm sure someone's made it into a razor by now, but the idea is that you always have to approach tech adoption from the perspective of what came first. So for example, Amazon led us to ebooks, but they really just started as this online bookseller. Netflix pulled movies into the internet, but they built that incredible infrastructure to deliver DVDs through the mail first. And Stripe's mission has been to increase the GDP of the internet, but they really started by embracing the horrible parts of card processing and then abstracted it into a simple API. I really like the quote from Steve Jobs about this, which is probably the most famous quote in this arena, which is that you've got to start with the customer experience and work backwards to the technology. You can't start with the technology and then try to figure out where you're going to sell it. I think that too much of what we see in crypto is about forcing blockchain paradigms onto people who are accustomed to the old way of moving money, and it just doesn't connect. It doesn't work. As an example, one of the other crypto payment providers out there literally has this slider in their dashboard, and the slider lets you choose between high-risk, high-speed payments and low-risk, low-speed payments. And it's like the Sophie's choice of payments, right? No merchant wants to make the choice between high risk or low speed. By the way, it's totally understandable why they did that. Bitcoin payments are too slow to work, but instead at Flexa, we spent a ton of our time starting from the seller's perspective and trying to approach crypto from that regard. And it's things like, yes, I want fast payments, but I also can't get hit by replace by fee attacks or 51% attacks. Or yes, I want to accept digital assets, but I also need to be paid in US dollars. Oh, and I can't be exposed to price volatility because it will screw up my taxes. It's because of this that we have really nailed the enterprise market for digital currency acceptance. And at last count, of all of the Fortune 500 companies who are accepting digital currencies, all of them use our products except for one, which is Tesla, because of course they built it themselves. But to get there, to do that, we've built all of these incredible and completely cardless, by the way, payments technologies, including our network approval engine, commerce intents, routing as a service. We have some fun work around on-chain collateralization, multiplayer payments coming. This app list, open source database of wallet information and wallet interface content. We have also spent a number of person hours trying to build out a better interface for payments, such as what we call payment clips, which really distill a cryptocurrency transaction down to 3 important aspects. It is the merchant you are paying, not some opaque wallet address. It is the actual amount you see on the point of sale, and it is the currency you're using to pay that. We have spent a lot of time figuring out how to implement things like perpetual acceptance, which is this idea that you can sit on a page for hours and hours and hours, and we don't have to ever show you a 15-second countdown timer because we can roll quotes in the background and we can always surface you with the latest quote when you're ready to make a payment. And we can honor a set of past quotes so that we make sure that you don't end up getting bumped into some kind of a race condition. And on top of all this is the Flexa SDK that we launched and went live with in the Zashi app last fall. Just like how we approach payments from the perspective of the seller, we've met with a bunch of wallet app developers over the last several years, and we found that there were several things related to making payments work that were just a little bit too cumbersome or onerous for wallet developers to implement. So we've built out this series of components, the spend component, the scan component, and more components coming soon to hopefully make wallet developers' lives a lot easier. Okay. So where does Zcash come in? Well, Flexa works really hard to be asset agnostic because we really think sellers should have the freedom to accept whatever asset they like. But we are very long-time fans of Zcash. It was the second asset that we added after our launch. We were early supporters of the crypto community project. We helped throw Zcash's 4th birthday party back in 2020. We've hosted events together at Consensus and other conferences. Zashi was the first wallet to launch the Flexa SDK and enable in-person payments at places like Chipotle, GameStop, Ulta Beauty, Regal for ZEC users in the US. But also, I have this hypothesis that Bitcoin and to a lesser extent Ethereum today are not really fulfilling Satoshi's version or Satoshi's vision, I should say, of electric and electronic cash. And I should say, first of all, that even Vitalik agrees with me. To do payments well, cash needs to do two things. It needs to be really cheap to send, and it needs to be fast. And of course, it needs to be secure and final, and lots of other things that Bitcoin and Ethereum do exceptionally well. But you really can't have cash without cheap and fast. And on the fast front, there's been lots of great progress over the years in the form of scaling solutions and layer 2s, and I think both Bitcoin and EVM have a lot to offer here. But when it comes to cost, there's just no question in my mind that low fees are not an ultimate priority of either of those chains. And here we have a chart of transaction fees demonstrating the difference between Bitcoin's average transaction fees over the years and Ethereum's. The reason that you don't see any other colors on this chart is because all of the other chains are at zero, effectively. And in fact, within our UI, when we present network fees to customers, the only chains that really ever pop up with non-zero, or I should say, greater than 1 penny transaction fees are Bitcoin and Ethereum. And Zcash is one of those chains. We believe that there's already a lot of common ground between what Zcash cares about and what Flexa cares about when it comes to enabling payments for merchants. And that partly explains why we've had such a fun time working together over the years. But there's also the fact that payments today, and this is going to be obvious, are so horrifically invasive when it comes to privacy. I love this meme. Many people, although perhaps not those of us attending Zcon, many people don't really think about this in the course of day-to-day payments. But that's really because we've already handed over all of our personal information in the form of a credit card application or when we were opening up our first bank account. You really can't participate in a cashless society today without everything getting tracked against your identity. And that is still not enough to secure a single payment, especially when payments started to move online. For example, have you ever thought about where billing addresses come from? I don't have this as anything but apocryphal, but my understanding of how billing addresses came about is that a developer or a project team was trying to find a way to fight the onset of fraud that they were seeing when people were starting to use credit cards online. And so they went into the database of information they had about their credit cards, and they found billing addresses. And anyone who has ever tried to design a payments acceptance form knows that those 7 or 8 fields that everyone now has to fill out whenever we're filling out a billing address are not only hard for customers to use, they're also hard to develop. And that is obviously pretty ridiculous. We just picked a billing address, almost like a 2-step form of authentication, and it just doesn't work. The hackers who were using card numbers and expiration dates and CVVs before just started adding billing addresses to their databases and so selling those off instead. And that's led to EMV 2.0 and 3D Secure and whatnot. We don't have to get into that right now. Obviously, this is all ridiculous. So at Flexa, we actually went to the individual laws that govern payments. That includes the Bank Secrecy Act, the Anti-Drug Abuse Act, the Patriot Act. We went to these laws to figure out the minimum information that companies are required to collect in order to process payments, both in the US and around the globe. And we built our entire onboarding flow around that. And we currently enable anyone to spend up to $750 a week just by providing a name and a birth date. We don't require cell phone numbers. We don't require social security numbers. We don't require billing addresses. In the states where we're required to do so, we do aggregate and report transaction volume based on what Cloudflare tells us are requests, probable city, and zip, but we don't store IP addresses. It's not possible for merchants to correlate any of this information from one transaction to any other transaction. Favorite story about that, by the way, is the story of a father whose daughter started receiving mail from Target. And the mail was insinuating that the daughter was pregnant. And the father was very, very upset that Target was trying to sell diapers to his daughter. And so he called up and complained to customer support. And about a week later, he had to call back and apologize for being so loud and obnoxious because his daughter was actually pregnant. And the joke here is that Target found out about his daughter being pregnant before he did. And that's because Target was comparing all the things that she was buying on the family credit card from transaction to transaction because they could track them against the credit card numbers. And we at Flexa absolutely do not allow that to happen because every single transaction that someone makes using Flexa is completely pseudonymous. It's completely unique and random and not possible to be compared to any other transaction. And by the way, we index and publicly post all of the times we've received government information requests or been obligated to provide any personal data in this annual transparency report that we publish. I think, I know I've been kind of waxing about different aspects of this here, but the bottom line is that crypto is not credit. And in fact, crypto makes it impossibly easy to prove that someone is good for a payment. You don't need a credit line. You don't need a credit score. We just don't need to process any personal data in order to help people pay for things. And yet, many of the approaches that we're taking with adopting or encouraging widespread adoption of digital currency have to do with plugging crypto into a credit or a debit card. If I were to jump in a time machine and find out that 25 years from now, we're still sucking up personal information just to help make the credit card networks whole, I would be very, very disappointed. And that is what we are very, very focused on here at Flexa. So at Flexa, we like to say that we have a 25-year roadmap for building a better payment system for sellers. We are trying to hard fork payments before another century goes by and we're still using plastic and metal cards for everything. If that happens, I think then it is very likely that AI will take care of us all, but hopefully it doesn't come to that. In the immediate term, we are just working on building the best acceptance tools for merchants and the best payment tools to help developers interface with those merchant acceptance interfaces. And then we have recently released a Flex SDK that helps wallets interface directly with in-person and online points of sale. Very, very proud that the Zashi app and the Nighthawk wallet app in the Zcash ecosystem have both adopted that SDK. Our vision really, though, in that sense is twofold. One, we want to see broader adoption of digital currencies for payments. And then two, we just want to make sure that we don't repeat the same mistakes of the last 75 years. We think that adoption entails more people using crypto, oftentimes without knowing that they're using crypto. And I think this is inevitable, by the way. The UI is going to obfuscate the fact that it's crypto behind the scenes, just like the UI of our web browsers drops the HTTPS because that's no longer really relevant to the vast majority of customers. In terms of avoiding mistakes, though, this bullet number 2, we think that payments need to shift away from being issuer-centric and toward being seller-centric. We think they need to shift off of cards and into apps. And we think they need to shift from being secured by personal data to being secured by blockchains. And obviously, this is going to require a lot of thoughtful work and patience. But really, in terms of my hopes and dreams for Zcash and Flexa, I would love to see a thriving Zcash wallet and maybe even a shielded assets ecosystem. I'd love to see a significant number of payments taking place on Zcash versus other chains. I'd like to see promotional tie-ins with big merchants offering discounts to people paying with Zec. And I think that with the Zashi wallet and other efforts along these lines, we are all well on the way. So I hope you've learned a little bit about Flexa today and what we're trying to achieve for the Zcash ecosystem and for crypto on the whole. In summary, we are all about helping sellers thrive in the next era of commerce. And that means universal access to commerce, means fast payments and payouts, and as little personal data as possible. Again, I am Trevor. I am one of our co-founders, and I am so grateful for you taking the time to attend this session today. Thank you very much, and have a great rest of your conference.
Next. Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David
Duchovny. Sometimes I think I know too much.
Are the chupacabras real?
Huh?
Have you touched an alien?
Oh, God.
Has an alien touched you?
Why is that line moving so fast?
They're paying using digital currency. Not only is it super secure, it's super fast, and you can buy just about anything.
Imagine what I could do with all that free time. I will save the whales. Behold, I've done it.
Mr. Duchovny? Mr. Duchovny?
Yeah.
Can I get your zip code?
Come on.
We're for freedom. Freedom from ads. Freedom from borders. Freedom from the past. From constraints. From scrutiny. From expectations. Freedom to express ourselves. Freedom to choose. Freedom to share. To create. To connect. To flourish. Be free.
So I think that we're in a dangerous time. Individuals are very willing to give up their privacy, to get a free Facebook account, to get a free pizza, something like that. But when everybody acts as though privacy isn't important, we end up with a society in which nothing is private.
Crypto came out of nowhere, took the world by storm.
This was the fastest moving technology we have ever seen.
The cypherpunk said the internet and cryptography is going to change everything because it changes the fundamental balance of power. You know, it turned out to be right.
As far as my work with cryptocurrency in Washington, D.C., this is the moment that everything came off the rails.
Decentralized systems all have trade-offs. Community consensus comes at a cost.
I don't want to see people adopting a system that can be used to surveil them. I want to see them adopt something that's trying to protect them.
We have to have some kind of optimistic vision of technology, or you just end up getting the thing you fear but a little more slowly.
When we talk about crypto today, a lot of the conversation is around financial rewards, not enough on how we take ownership of our life and our data.
You know, the big thing in the crypto space is when moon, but I think we should ask, when are we creating a better Earth? That's the real question of this space.
What if we could cooperate? What if we could interact? What if we could exchange from anywhere to anywhere at any time?
Cryptocurrency is fundamentally about disintermediation, right? It's the ability to own something directly, just through yourself without a third-party custodian. It's the ability to send money in a peer-to-peer fashion without having to rely on Western unions or banks or so on. And, you know, for us who are lucky enough to live in a world where we do trust our banking system, we do trust the rule of law, we trust the government for the most part, we don't need that. It's nice to have, it's interesting technology, it's perhaps good diversification. It's in many ways perhaps a good hedge against, you know, some geopolitical disaster occurring that does throw these things in question. But it's in the places in this world where people don't have that trust in these institutions and in the rule of law surrounding them that they really do need this kind of technology where they can take ownership of their own funds and where they can make a payment or send a remittance and know that it's going to get to the other side without having to worry about one of these third parties taking control of it in the meantime. And so that's where I think that in emerging markets, and today specifically in Venezuela, it's a totally transformative technology. And that's something that I'd like to emphasize as well, is that it's easy to think that, oh, this is still early days of the tech, we're still working on everything from low-level scaling of the protocols all the way up to user experience and design issues. All of that's true, but there are also opportunities where it does make sense for it to be used today. And I think that as a whole, we can do better in identifying those and pushing those. The important thing to remember as well is that fundamentally what we're talking about, and we'll just take Venezuela as an example here, because that's kind of what we're focused on at the moment. What we're really talking about is a form of aid as well. And that can't get lost in the kind of larger conversation. There's a risk, of course, of becoming these sort of out to space technologists who want to believe that the people of Caracas, what they really need is Bitcoin. No. What they need is food and, basic goods. But to the extent that cryptocurrency can be a means of storing value for them, perhaps even at some point a means of payment directly to merchants, that it can be a force that provides for even an alternate kind of economy there, that is at least one step in the right direction. And so, there are a lot of sensitivities to what we're talking about in terms of bearing in mind what's really going on there, that, people are starving, people are dying. And, we want to be very careful that we are aware of those dynamics and not just approaching this as entrepreneurs or technologists, because that's really not what it's about. Cryptocurrency is fundamentally about disintermediation, right? It's the ability to own something directly.
So JP Morgan had this heavy interest in blockchain technology, and they had built an internal group to explore and experiment with it. And they rapidly identified this need for privacy and confidentiality. They eventually came to us and said, we're interested in exploring the zero knowledge proof-based solution further. So we agreed to enter into a technology partnership with them. And we added the technology that underpins privacy in Zcash to JP Morgan's blockchain distributed ledger solution, which is called Quorum. And we did it as a proof of concept last year to demonstrate A, that it could be done, and B, to then have something that could be used in a experimental, proof of concept type environment to experiment with different use cases and so on. And that, I think, has yielded a lot of learnings, both for us and for them. For us, it's given us some ideas that we can then take back and look at applying to Zcash about different use cases or features and functionality that can enable different use cases. And for JP Morgan and the other members of the Enterprise Ethereum Alliance who also benefit from that work, it's given them some instead of this idea of zero knowledge proofs being this solution but never actually having their hands on it and seeing how it works, it's given them hands-on experience with it, and they appear to like it and to be interested in pursuing it further. So I think blockchain distributed ledger technology solves two problems in the traditional financial markets. The first one is that in order to discover counterparties when you're trading, you currently have to go to a centralized trading environment. The people who operate those centralized environments, whether they're exchanges or multilateral trading facilities or brokers, they inevitably extract economic rent from their users. If you can disintermediate those centralized parties, those trusted third parties effectively, then you can save money. when you get rid of centralization and when you get rid of those middlemen, then costs go down. The second aspect that I think is attractive is the idea that there is a single record that is shared amongst the parties to a transaction or a trade. Currently in financial markets, what we call trade breaks are a big source of cost. Somebody decides that the trade happened using 6-month LIBOR, somebody else records it as being 3-month LIBOR. And there's then the cost of having to figure out what was actually said on the phone or what was actually written in the email or the message, and then correcting whichever system happens to be wrong. If you have a single ledger that everybody uses, then you get rid of those trade breaks and you have a single source of truth. I think the technology is still relatively immature, but we're operating on a timescale that's similar to what the internet timescale was back during the dot-com boom, where things are accelerated. And I think that it's evolving and it's maturing very, very quickly. And I wouldn't be surprised if we start seeing it being deployed in real, production environments within the next 12 to 18 months. There's no doubt that it is a young technology and it is evolving, and it's going to look very, very different in a few years' time to what it looks like today. Some of the problems that we think are insurmountable today, like scalability and efficiency, I think will get solved. I'm not sure how they're going to get solved, but my experience of dealing with technology over the past 25 years tells me that it advances quicker often than you would expect.
Privacy just it's an important human right to me. It's what allows me to feel comfortable as a human being. It's what allows many other people to feel comfortable and safe and secure, and to feel like they have an opportunity to help influence and change the world and improve people's lives, which is interesting because it's kind of a selfish right. It's something you preserve to yourself, but it really is necessary for a society to function properly, in my opinion. I'm most optimistic about the fact that governments, especially regulators, are beginning to understand that privacy is necessary for finance, and that decentralized models of financial activity, such as Bitcoin and cryptocurrencies and so on, are important, and that privacy is incredibly important for those models to function correctly, and that just because some criminals use privacy-preserving technology doesn't mean that no one should have privacy, or that we should ban Zcash or ban Monero or ban anything. It's really, I'm really optimistic about the fact that regulators are seeing, at least in the United States, are seeing that privacy is important. I'm a little pessimistic about kind of the risk of privacy, at least inferred risk from regulators overseas is kind of concerning. Hopefully they'll realize that with time, I'm sure they'll realize that privacy is very important. Hopefully. Privacy just is
a lot of engineers and technical people often don't realize that what they're designing involves trade-offs that impact end users in important and fundamental ways. A prime example is privacy. And so far, the general sort of status quo with technology is that there's many ways to gather information from multiple angles to build really deep profiles of people that I think violate most people's expectations about the privacy that they have. Like, people don't easily understand what is happening to their privacy in our world with these technological changes. So one of the most important ways I feel to empower users is to give them technology that respects their autonomy and decision making and provides strong privacy and security and safety in general.
Hey, Chica.
Hey, what's up?
Who button?
Zcash.
Zcash?
Yeah, it's a cryptocurrency. It's kind of like Bitcoin, but it doesn't expose your whole financial history every time you use it. And this guy Zcon.
Zcon?
Yeah, Zcon. He comes in here all the time and buys his coffee with Zcash. And he started the whole Zcash thing with a team of scientists and someone named Margaret, I think.
Okay, Zcash is like an app for buying secret coffees?
Speaking of...
Good morning, y'all.
Hey, Zuko, I was just trying to explain Zcash to Danny here.
Hi.
Okay, so a necessary part, in my mind, for freeing humanity from the centralized power structures holding them down was decentralized transaction processing and privacy, so that everyone has their own decentralized choice and consent over what they reveal to whom, and a fixed money supply so that some centralized entity can't undermine everyone else's plans for their future to benefit some at the expense of others.
It
requires something called the ZSnark parameters to be baked into the protocol.
Oh my God. I asked hours of questions.
technologically achieved pretty much all of that. There's a ton of more work that will always be necessary to sort of keep up and to put it into everyone's hands and make it something they even know about and know how to use and works for them.
Here's your coffee, Zuko.
Yeah, it was super great. Thanks. Hi everybody. Welcome to a very interesting session about the future of Zcash. Where should Zcash go with its use cases? How to go beyond Zec. We have today a panel of specialists in the space coming from many different projects, doing many different interesting things in the space. And I hope we can all together have a conversation that dives into what Zcash can become and bring to the world. I'm Jonathan Rouache. I'm CEO of Kedit, Executive Director at zkproof.org. And we are contributing to Zcash with Zcash shielded assets. And with me today, I will go in the order that they appear for me. We have Christopher, Kit, Brian, James, Henry, and Alex. And we will go first. You will learn what projects they work on and what they're doing in privacy. Many of you guys with me in the panel have several projects that you work on in parallel. All these slashes on your roles. This is very common. So please present what you do, and then we will have questions about where we see Zcash going. Let's start with Christopher Goes.
Yes, hello everyone. I can't see you, but thank you for joining wherever you're joining from. My name is Christopher. I work on the Anoma and Namada projects, both of which Anoma is a distributed operating system. Namada is a sort of shielded asset hub for assets in Cosmos and other IBC connected chains in the multi-chain. Both of those projects, of course, draw upon and build upon Zcash, even back to ZeroCash, Zcash's pioneering research and development in applied cryptography. My other random Zcash claim to fame is that I once wrote a Zcash block explorer called Zchain. And then the thing I wanted to do was write the block explorer, not operate a block explorer. So I handed it off to someone else. I think it still existed for a while, but I haven't tried it recently. Maybe someone in the chat knows.
So right before we continue, to demonstrate the level of detail, Anoma, Namada, give us just a tiny bit more juice. What's the the particularity of each of those projects for those who don't know?
Yes, so Anoma is a distributed operating system, meaning that it takes a bunch of computers and tries to make them look like a single abstract computer that brings two key notions into play. The first is information flow control. Information flow control is a way to declaratively specify what kind of information you want to be revealed to different participants on the network as your, as in our case, intents. Anoma applications are written with intents. Are processed. I would describe information flow control as kind of like the declarative counterpart to privacy or programmable privacy. So information flow control is a way for you as a user and an application developer to specify at a policy level what kinds of, what you want to be revealed to whom and under which conditions, and then different cryptographic mechanisms or privacy mechanisms, such as zero knowledge proofs and things as simple as regular cryptographic signatures can be used to implement that. And the other part which Anoma brings is heterogeneous trust, meaning that different participants in the network can make different choices as to who they want to trust, what they want to trust them to do, what kinds of assumptions they want to make about the behaviors of other participants. And the network can sort of compute over these trust assumptions and figure out which users can interact with one another. So imagine if you had a blockchain wallet and you selected, like, I trust these 15 chains, like you can treat US, certain assets on each of these chains as fungible or something like this. Anoma allows you to express that and thus sort of admits a greater deal of interoperability and user interactions with knowledge of these kinds of trust preferences. Namada is a shielded asset hub. What do we mean by that? We mean that it's designed to allow you to shield your assets at rest, keep them on Namada, earn some shielded set rewards potentially, and use them in shielded actions on lots of other Cosmos chains, ranging from Osmosis to the Cosmos hub to potentially penumbra even in the future, I hope. Our thesis there is trying to make it easy for users to get privacy at rest, which is also how they provide privacy to other users in the shielded set while taking the actions that they want to take when they want to take them with as minimal UX friction as possible.
Amazing. Thank you. Kit Sturgeon, tell us about you and your projects at a similar level of detail.
Sure. Okay. So my name's Kit Sturgeon, and I've been a Zcasher since near the beginning when I bought some Zec without KYC from Binance when they were a young company, and I actually knew about Zcon before that because we were building a distributed file system and looking at Tahoe Laughs, and that's how I first encountered that. Not Zcon personally, but that part of, and I was like, oh, the same guy's building this blockchain. That's awesome. So we are building so I have slid into the Avalanche world, and I've been there since just before launch, and very interested in that the Avalanche platform because it's got worldwide scalability and very fast time to transaction finality built into the platform. And at the same time, they're sadly lacking in privacy and selective disclosure features that are necessary if they want to fulfill their mission of tokenizing the world's assets. And because in every business transaction that I can think of, those are two elements: privacy and selective disclosure. So that's how the project came to mind, and then I had that opportunity to pitch it. So I started on the forum. I had a team assembled, and eventually got funded by Zcash community grants to start building. And it's a distributed permissionless system with its own token. I don't know, well, probably people don't know too much about Avalanche, so it's I'm doing a presentation tomorrow, a short presentation just to run through it. But basically, it's like Cosmos, it's L1s that can talk to each other, and a very fast protocol between them, lightweight protocol. And we're using one of those L1s where you can have your own token and make it permissionless as the bridge. So that L1 will not, and that bridge is called Red Bridge. We started calling it Zavex, and then some people were like, we like the name Red Bridge better. And I was like, well, that sounds good to me. So, and we're Red Dev. So so we did this name switch. And so we're in the middle of building it, and I have really exciting news today because I can announce that we just received funding from the Avalanche Foundation. So now we have funding from both sides of the bridge, which if you're going to build a bridge, that's what you need. So I am really super happy about that. And we just announced that at noon Eastern time today. And
I hope your bridge doesn't collapse under all this funding.
yeah. Trust me. Both organizations are, they don't overfund you.
No, they don't fund easily. So it means that
we have enough to build.
You have promises to both communities.
Yeah, I know. Well, and I had that from the beginning before any money was on the table. I mean, that was why I'm strongly committed to both communities. I mean, to put a serious spin on that joke, but in all seriousness, a builder, not a number go up guy, and it's a beautiful thing to connect different two ecosystems that have complementary use cases. So that's what we're building, and there's a thread on the forum, and there's a test UX I'd love feedback from, and I think that's probably enough, right?
That's good. Now. Congrats.
Okay, thanks.
Brian, you're next. Brian Gillespie, tell us about your project, yourself, but first unmute yourself.
Absolutely. Hi, it's Brian Gillespie. Not a problem. That's the common mispronunciation. So Brian Gillespie, I do applied cryptography at Inversed Tech. It's a relatively new cryptography consulting group in the privacy tech sphere. I come from an academic math background. I started studying cryptography probably about 5 years ago. That's my first foray into the Zcash ecosystem. I was really interested in the Snark technology that they were using, and I just loved reading through the blog posts that were going through the details of how all that fit together. And it's really the gateway drug, I think, of many theoreticians into this space. Like, it's just a fantastic technology. And I still think that Zcash is like the proper use case, like the baseline of these applications. And I like to see where it branches off from there. So about 2 years ago, I got into the space professionally, started working at Inverse Tech. And one of my first projects actually at Inverse was a research grant from the Zcash Foundation to study programmability and privacy in the space, in particular.
Shout out to Inverse Tech founder. That's a very special person there.
Yes, absolutely.
Who is that?
Daniel Benarock is one of the co-founders of Inverse, along with Aurel. And he has obviously been involved in various parts of the ecosystem. Was formerly at Kedit. Jonathan is a member.
But most importantly, he's very prominent in the Zcash ecosystem as the person that brought to the table the idea of launching ZSAs, and also one of the people that created ZK Proof.
Yes, absolutely. So he's been
great organization.
Extensively involved in the community. One of the co-authors on this paper that we put together, systematization of knowledge on this programmable privacy. And this project in particular really pushed me in the direction of thinking about what programmability is useful for, and like how it could fit into Zcash as a protocol. My feeling broadly about all of it is that there's really good technology out there. I think everybody can agree that Zk has just continued to compound in quality and tooling and usability. Like enough great proof systems that you can really extend a blockchain protocol's functionalities if that's what you want the blockchain to be. And I feel like that's a question that's worth exploring at some point. Is for a protocol like Zcash, is programmability something that is useful and a priority? And like consensus on this question is a really big question that's of interest to me. So that's my background.
We'll put this one in the stack and try to get to it. Thank you, Brian. Next on, James from Brave.
How are you doing, everyone? James Mudgett, I'm the Vice President of Web3 at Brave. This relationship really started 3 years ago over barbecue with Josh in Austin. And so, over the last year and a half, we've been working on shipping Zcash in our wallet. And next month, we'll be launching the shielded support. But if you're not familiar with Brave, we're roughly 80 million monthly active user, privacy-focused browser, privacy-focused search engine. We'll soon be hitting 100 million. And really, my goal has been to build the multi-chain crypto wallet natively in the browser, both for web compatibility, but I think the more important thing here is the privacy alignment between Brave and private payments. I think that's important for getting mass crypto adoption for commerce on the internet. So looking forward to what we end up doing in future iterations of it. And thank you for having me on.
Amazing. Thanks for joining and immediately bringing this announcement number 2 to this panel. So it's a big one, right? That the listing, yes, quote unquote, of Zec on Brave. It's huge.
Yeah, it's privacy crypto, built into this widely distributed product, and we think more people will find benefit in that, both for transacting privately between individuals, or even expanding to payments on the web for commerce.
So, do you mind if I assign you a sort of role on this panel, which is when we talk about anything that's like forward-looking, please give us the perspective of what it would look like for the user when they click on it in Brave, or is it like we're dreaming and it's and you guys are talking about stuff that's never going to land mainstream browsers? Just have that question always in mind, and if you have like an insight on that, please feel free to.
Yeah, I'll try not to like speculate too much on future stuff, but you know, I'll
speculate.
make it clear if it's
speculate.
Like, if it's something near term or it's more of a long term vision.
James, this is crypto. You have to speculate. All right, Henry. Thank you, Henry de Valence.
Hey, great to be here. So a little bit about me. I am a cypherpunk. Started off doing cryptography research and engineering post Snowden, and then worked on a sort of sequence of sort of progressively sort of moved up the stack from low-level crypto primitives. A few years ago, I worked on Zcash, actually at the Zcash Foundation, which was really rewarding. And we built the first part of Zebra at that time. And then after I was working at the Zcash Foundation, I left, did my sort of time in the wilderness, thought about privacy, blockchain privacy, and at the time it was sort of right after the DeFi summer. So I was kind of looking out at the space and seeing like, hey, there's this like Venn diagram of a bunch of like really interesting projects that are getting like real traction with users. And then there's sort of like all of the privacy projects, and it's like currently it's just like two circles. And so how would we fix that? And that led to thinking about how could you integrate privacy and DeFi? And how could you use that to build a situation where privacy could outcompete transparency, right? Rather than just saying like, hey, you know, everybody should use these private things because they're private and that's good. And, you know, maybe in 10 years, we'll have some kind of like horrible, you know, authoritarian dictatorship or something. And similarly far-fetched and remote outcomes, and instead have people get concrete value out of privacy at the moment that they're choosing to use the tool. So that ended up being this whole rabbit hole. It led to the creation of Penumbra, which is a multi-asset privacy chain with an integrated DEX. So Penumbra is the first place that you can do on-chain trading with private strategies. The market state overall is public. So it's like, you know, thinking about a centralized exchange where you can see all of the different trades, you can see what's the state of the liquidity. But unlike a centralized exchange, it's trustless and verifiable. But unlike other DEXs that exist, you get the privacy benefit of people can't see your specific trades. So Penumbra is also in the Cosmos ecosystem. We natively connect to other chains with IBC, and the IBC integration in Penumbra is integrated into the design of the shielded pool. So Penumbra doesn't have transparent accounts the same way that, say, Zcash has the transparent part and the shielded part. For Penumbra, we only have the shielded pool, and the transparent pool effectively is like every other chain that we connect to. So transferring tokens in is actually entering the privacy boundary. And that feels like a really good kind of conceptual platform. But so yeah, you can take whatever asset you want, transfer it into Penumbra, it's recorded privately, and then you can do private trading.
Amazing. Feels like this is already the second or third project where ZSA and Zcash have a lot to learn from. You're kind of already advanced on the path of holding assets in a shielded way, and already the next phase of of trading with them, it's going to be relevant to think to inform where Zcash could be going. Amazing, thank you. Alex, your turn.
Hi guys, hello everyone. Yeah, I'm Alex Smith. I'm Maya Protocol's co-founder. I'm a permissionless maxi, and I come from Latin America, where you know, totalitarian dictatorships are not something that might happen in the future. They just happen. They just pop up any given year in some part of Latin America, affecting friends of ours and loved one of ours. So I think we're more conscious than many other places about the controls we give to governments. So yeah, I set out to build Maya Protocol because I loved what Thorchain was doing. Maya Protocol is a friendly fork of Thorchain. Think Uniswap, which is an AMM, but across chains. So this would mean, you know, native BTC to native ETH to native, you know, AVAX, UKIT that we're mentioning, Avalanche. So there's a lot to do there. And we've been working on for a few months on the Zcash integration that we're very excited for moving forward. That would essentially make it so much easier to get into the Zcash ecosystem and compose it with the rest of the blockchain industry. Jonathan, you were mentioning to James that, you know, what would these things look like on Brave? It would be awesome because you could just like swap BTC to ZEC very easily. And the reason I'm so excited about ZEC and Zcash is that I've come to the realization that humans are very biased to other humans. So the only way to really enforce complete permissionlessness is through privacy. A human and a set of humans, if they have information about people doing transactions, it tends to happen that they start to insert their biases on whether this transaction should be valid or not. Whereas when you cannot tell because it's private, you remove the possibility of bias entirely. So I think privacy is very important if we're to build the permissionless future that blockchain set out to build. So that's why I'm here, and that's why I'm excited for Zcash. Next Z conference is in the agenda, is me explaining Maya in detail. So I'm just here more for the panel discussion.
Amazing, thank you. So thanks all of you for sharing your projects. But of course, you're not here to just because of your projects. You're here because we're in a Zcash conference, and you all have a very strong tie to this community. So I guess the first question would be how you perceive or describe the Zcash mission. What is the role of Zcash in the world? Why does it exist? And is this mission accomplished? Is this mission does it stand a chance to be accomplished? Does it miss big pieces, small pieces? But why does Zcash have a place in this big world of cryptocurrencies? And this is addressed to all of you, but the one with the strongest opinion seems to be Kit. Go ahead.
The hot seat. Okay, I'll give this. I'll start, but I'm not going to do a comprehensive. You know, Zcash can be many things to many people, but at its core, I believe Zcash is the right way to do Bitcoin. I mean, that's the bottom line was that Bitcoin was meant to have privacy, and it just the tech didn't exist at that time, and that's why it was founded, was to fix that problem. And So, but it's also the OG privacy coin, and has carries with it that gravitas and also weight, and is shedding some of that technical debt as we go with Zebra, and so that means that it's so I believe at its heart, the Zcash, in talking to Tatiana, who's done research about where the use cases are at Electric Coin Company for Zcash is peer-to-peer private payments is like the core use case for Zcash. So at the same time, we're building a bridge which I think expands some of the use cases, but it doesn't get in the way of the core mission, and in fact may help it scale. In Jack's opening talk, he mentioned side chains for to accelerate things, and this is across a bridge is a side chain, or many side chains that can be running the Zcash virtual machine and keep and with value transfer, and then operating at much faster speeds. So in one way, Zcash is Bitcoin with the right way, and another way, there's a modernization of it that can. That's my 2 cents. I'd love to hear what other people think. So.
Interesting. Who else has a? Okay, Alex.
I can chime in. I'd say also Zcash is normalizing privacy, and I think it's achieving that. In that, when you think about other privacy chains, they usually seem a bit more daunting, and I think Zcash has treaded that line very well of being easy to approach, easy to onboard, easy to get started, but also offers complete privacy in an also very easy to use way. And with all of the work going on with Zashi and making things more approachable, like if you compare to Monero, for a more normal person, for instance, I'm not a cryptographer like Brian or a cyberpunk like Henry. Monero is daunting to me, and I've definitely went into it a little bit because I think it's an important project. But Zcash is just so much familiar. Like it says, it's Bitcoin, but doing what it should have done in the first place, and it's familiar. So I would say normalizing privacy is something that it's setting out to do. It's accomplished a lot already. There's much yet to be accomplished, but I think the team, I was in January there in Cancun for the talks with Josh, and I think they have the right vision to accomplish it. So I'm just very excited to see what else.
I think yesterday in the roadmap talk, Strad was saying that if he had a magic wand, he would remove transparent tools and just keep the shielded part. So the path is progressing towards normalizing privacy even inside Zcash. Certainly, the move to Orchard allowed for the Zec to pop in shielded, and this is a big property of this ecosystem. Anyone else has a view on what is the mission of Zcash, and is it succeeding in this mission? Brian, and then Henry.
Yeah. So one aspect that I would also bring before as a cryptographer is that Zcash really sets a gold standard for the certainty and kind of mathematical assurance of the cryptography being used. One of my first projects at Inverse was doing an audit for a code base that was forking the Zcash sapling protocol. So as part of that, I had to dive into the protocol specification documents for Zcash to some extent.
That's Ironfish, right?
Ironfish, that's right. That's what we were auditing. It's a good protocol. They were doing some interesting stuff similar to ZSA, supporting multi-assets. So good ideas there. But diving into that protocol specification doc was just eye-opening from the level of care and caution in designing a spec that just covers every single detail with security arguments. Like it's just a level of detail you don't see elsewhere in the ecosystem, and I think it's like something that really reflects well on the community and is a role that Zcash plays more broadly in the privacy ecosystem.
Henry.
Yeah, just to echo or add on to Brian's point there, I'll share an anecdote of a few months ago. I was catching up with some cryptographer who I'll leave nameless, who's sort of more from the academic side, and was sharing this anecdote of, I thought like I could go and like learn about ZK and see if we could do some stuff there. And I have to admit, I was kind of arrogant about it. Like I thought, oh, well, I'm the academic and I'll go and like, see all this stuff. And then I went and looked at like the Zcash specs, and I was like, wow, this is really good stuff. So I think that, the work really sort of shines this beacon. And I think that's kind of part of the mission of Zcash, and also of like the broader sort of privacy community, is to demonstrate that it is possible to build permissionless systems for economic coordination that respect privacy and human rights. And I think a useful analogy here is with end-to-end encryption. In some theoretical sense, like we had the ability to do end-to-end encryption for a very, very long time, until finally in the 2010s, we saw actual wide-scale adoption, and now it's just the default, right? Signal stowed away, but we also have WhatsApp, iMessage, all these systems have end-to-end encryption just built in, and it's accepted that that's the default. There's a really amazing time capsule documentary that Andrew Miller shared on YouTube from 1997 of it's an NHK documentary about the first financial crypto conference. And in it, there's this section where there's some law professor from Georgetown saying about how like, we can't have encryption because like businesses might like lose access to their data, and that would be bad. So the only thing to do is to have like a government backdoor in every computer. And when you say that today, it sounds insane. And I think we're going to see the same thing happen with financial privacy. This is obviously not like, every transaction is sort of completely unauditable and untraceable. There's obviously going to need to be like disclosure requirements and all this stuff. But I think that in the future, we are going to look back on encryption for economic coordination the same way that we now view encryption for messaging, where all the old arguments of like, you can't have that in a society and all this stuff are just seem completely out of touch now. And I think that part of the role of Zcash and the Zcash community is actually showing with a technical demonstration, yes, you can build systems that respect user privacy, that respect rights, and they actually work. And it's going to be a long road to making those systems be as easy to use as a transparent alternative. We also saw that with encrypted messaging, but we're going to get there.
So I have a follow-up question on that. I apologize for turning green every 10 minutes. I sit in the Bitcoin embassy, and the pace of Bitcoin is 10 minutes. So every time there's a block, I turn green. It's just the way it is. I would like to follow what you just said, Henry, with a question to James. Do people really care about privacy? When companies are forming in the space, very quickly they reach the point where they ask themselves if their own thesis was biased, that privacy is such a fundamental thing that, of course, the moment you put out a product that makes it easy or makes it useful, people will just hold on to it and use it immediately. You talked about numbers that are in the browser world not that large, but in the privacy world they're very large. But actually, it's beginning to $100 million is already quite big. I'm wondering, how do you sell privacy to people that just don't care, and how do you go on to normalize it as something that is happening today?
Yeah. So I would say everyone cares about privacy, really to the degree that they've been impacted by something that invaded that privacy. And it could be, on any sort of different fronts in all of our daily lives, right? But it's always been a tough one to nail down. And you've got, societal sort of sentiment shifts towards, one tech or another. But really in talking about tech, privacy in tech, name one banking or payment system that allows people to inspect some other stranger's purchases, toiletries, whatever. So when do you see mass adoption on crypto? Is it going to be with Bitcoin and sort of this public ledger, or are people going to sort of still apply the same their same beliefs of privacy to crypto? And so maybe that's why it hasn't quite taken on the masses as it should be. And that's sort of a reverse question here to you and others is what is the missing piece here? And I like some of the points that Henry made about privacy defaults. I do think you do have an advantage in being able to stay nimble by still having some mechanisms where you do need to meet with regulators and be able to satisfy subpoena on handling AML and other things like that. So I do think that there's power in the way that Zcash has structured itself initially. But I do think it is going to become a question for more and more people as more and more systems start to move to crypto, and really I think having that be sort of more of a standard versus I'll just pull out my credit card. Well, you may end up doing it with crypto. More people are going to start to demand these things because they will be more impacted.
Did we already see in the world the first time where a disclosure that shouldn't have happened was the source of some really bad things? What I mean by that is, are there examples out there where that we can talk about here where some movement in crypto generated an outcome that if it happened, if it was on Zcash, that wouldn't happen? Do you have like examples like this?
Well, I mean,
Henry?
nothing specific, but I could just say that like you definitely bring in a lot of new design paradigms into crypto, which can make it really challenging for your new users that are just getting into the space. Disclosures are super important because I think you do need to sort of manage expectations. You're sort of trying to meet in the middle between what is a complex user interface built around the tech, but how do you sort of continue to nudge it into something that's easy for everyone to understand? So I do think there are times where people don't realize that they should have saved their seed or not screen shared, or shared it on YouTube. And then they've lost all their funds. So I do think there'll continue to be sort of ways to mitigate problems like that, whether it's pushing seed phrases out of wallets and with other mechanics, or using getting more people adopting hardware wallets. But disclosures are important. It's definitely happened. I don't know of a specific case that I could point to right now. But
Thanks. Henry, you raised your hand.
Yeah, so the example that I would point to is the case of Constitution DAO. So for people who sort of weren't tracking it at the time, this was a sudden sort of flash mob effort. There was at the time an original copy of the US Constitution that was going up for auction. And so some crypto people said like, hey, wouldn't it be, funny and also cool if we pooled the crypto community to like collectively buy a copy of the Constitution for like the people and all this. And
you could say that they ended up buying the Constitution in another way, but that's a different conversation.
So what happened though with Constitution DAO is they were running an on-chain fundraiser to then place bids in an auction at Sotheby's. And like the thing about auctions is if your counterparty in the auction knows exactly how much you are able to bid in real time because they can watch the inflows into your wallet, you will not win the auction. Like you just will not win. And so that's exactly what happened. It ended up getting bought by Ken Griffith, the Citadel CEO. And so the Constitution did not end up in the hands of the people because there was information disclosure. And that I think is like a really great example to me because it's not just about this sort of peer-to-peer payment, right? Like I could already do a payment using my bank and it's like not entirely private, but it's like private to the world, right? So like the marginal benefit is already kind of, lower. What that example shows that I think is really interesting is a transformative use case that's only possible with crypto, right? You can't just like have some sudden flash mob crowdfund thing with TradFi rails. It doesn't work. And so that's an example that I like because it's showing like, okay, we have this transformative use case and it's almost there. It's on the brink. And we can see that it just falls flat because privacy is not there.
So take me a few years forward, 5 years from now, collectively. How does the world look when Zcash has even progressed on its mission? Hopefully, NU7 in Zcash has enabled ZSAs and even maybe asset swaps. And bridges are in place to attract assets to the Zcash ecosystem. If that was in place, do you think that these almost cases would mature into no, this is how things are done now. We got this solved. So try paint that picture, if you will.
Yeah, I think that if we could have, sorry, go.
Oh, I just want to add on to what Henry. I love that example of the Constitution DAO.
It's amazing, yes,
and it's a beautiful example of individuals coming together, and coming from this Avalanche world, which is very different from the Zcash world. It's very business focused. Very, how do we bring blockchain? How do we bring crypto? How do we move the rails from Wall Street to crypto? That's a lot of what the thinking that's going on in the Avalanche world is focused on. And so it brings a different perspective because in Zcash, I've been deep in the Zcash world for a couple years, and the theme is individual rights, individual privacies, what individuals can do together, and that's true and good. And on the Avalanche side, I see all these business use cases, and for me, I think you almost can protect the individual rights by bringing in the business use cases, and I think that's what's happened with the internet and with just needing HTTPS, TLS for protection of company websites, and not so that they don't get man in the middle attacked, and customers have a good customer experience. Banking can happen, and I think I see an opportunity with connecting these on the Avalanche side that maybe people in the Zcash community aren't focused on. So let me just I think one of the most important messages I can bring, and I tell you what, I didn't think when I thought of this my first Zcon 4, so a couple of Zcons of 4, and I was just like, I can't say this now because I'm the new guy, as far as, but now that I've been here a bit, I see this really strongly, and this is the thing, is that every single business use case of money transferring involves elements of privacy, every single one, and also the other side of that coin is selective disclosure. And in Zcash, I believe we focus on privacy, and sometimes selective disclosure is like, well, yeah, but we don't want to talk about that. But it's in the core of Zcash with not just with viewing keys, but with deeper levels of possibilities of disclosing that this transaction is at least this amount. So, for instance, a crypto exchange could, do a verification of funds that we have at least $10 billion in this wallet, but they really have 100 billion, and no one needs to know that. So they can disclose just part of that with Zcash, and you could have huge amounts of usage on the Zcash chain with this kind of gradated security, and then along with that comes the strength of the, like you're saying, Henry, the inevitable. Like, this is just where we're headed, and no one's going to think twice about it because everyone's doing it. And of course, you need these features. You have these, at the beginning, I think when cryptography, when somebody had to export cryptography on paper, to make it legal to export in those days, I think the powers that be were really concerned about edge cases, and as you bring in, and the edge cases sort of dominated mind share, and so what we need to do, I believe, to bring Zcash mainstream is to sort of, and I think Zcash is well on the way to doing this, is push those edge cases aside and say, hey, these are the mainstream uses for this. This can be used. You have to use this. If you're going to do this, you need privacy and you need selective disclosure. So, and here's a great stack that does that, or stacks in the case of these two smart contracts, also privacy chains that are represented here by Christopher and Henry. So, so that's and then, okay, so into the future, I don't know. I think that sort of answers the into the future question, where that's just normal, but that's important. I think just that business perspective is so important. Yeah.
Thank you, Kit. So maybe we can try to pull some of that future from the projects that we have represented here. So maybe Alex, when I think there's elements in the Maya system that might inform what could Zcash be used for. You have the underlying layer that is strongly demonstrated as private, and the level of engineering for Zcash is, like people described, I think Brian described it, very meticulous, and we have very strong basis. But what does it look like once you add use cases that we can see in other blockchains?
So I think the great thing about decentralized building is the part about composability. But when you see any centralized party build something, they typically are very protectionist. They want to cut off, they want to make everything in-house, and they want to have as much isolation as they can to compete. And the reason why I believe over the long run, I'm not sure if this is 5 years, 10 years, or 20 years, what we're building in blockchain will ultimately succeed over TradeFi, is that in the building of open source decentralized projects, the opposite is true. You want to be as easily accessible, as transparent, as open as possible, to build together with the rest. So where the the TradeFi space is competitive, the DeFi space is cooperative. Now, it doesn't mean that there is exclusively collaboration. There's also competition. That's why I like the word cooperative, because it still has some competitive characteristics, because people do ultimately have feet and can move to one chain or another depending on what they like about one or another, or what they need from one or another. But in facilitating this movement, a chain is more successful. So all of this is to say that Maya brings this possibility for people to vote with their feet where they previously couldn't. And I believe Zcash is building something very valuable. Again, like I said, very approachable, but very useful as well. You guys are building so many use cases, and having the possibility of any one person that's perhaps stuck in Bitcoin, perhaps stuck in ETH, they have no possibility in their local jurisdiction to move because they're in an underserved area of the world. The fact that they will be able to permissionlessly move to Zcash and enjoy the benefits that Zec provides, I think is powerful. Ultimately, I think Zcash is doing the right thing in inviting this big panel of different builders, of different teams. This is not just Zcash core doing what they believe is best. You're being open about, okay, what do other projects need that we can build to be better. And the thing is, any one TradeFi or central exchange needs to compete against the whole system, not one. And it's like a whack-a-mole game where they can focus on competing with one thing, but there's just so many projects, so many things building together in this cooperative environment that it's very hard that they will be able to outcompete us. Now, I do believe like the central exchange experience peaked last cycle. I think right now we come to expect what a central exchange can offer, and it's the best it will ever be in my view. Whereas the decentralized experience keeps getting better and better and better. And you see this with Zashi, you see this with all the wallets that support Maya today. You see with how things are just getting simpler. Like my dad can now use crypto. He's almost 70 years old. My goal is that my mom can use it. We're not there yet. But the decentralized experience is getting better and better and better because we're all building together. And Maya, hopefully, is that glue where we stop being maxis and we start understanding that the only core value we need to also subscribe to is permissionless. And then decentralized privacy and other core values of crypto serve permissionlessness. And that's how we get to decentralized money.
Thanks. So in this vision, you can pick another blockchain if you need something from that blockchain, as long as the composability is there. In preparing for this conversation, we asked ourselves, do you need the programmability piece in Zcash? Is this something that is core to better connect to the rest, or is Zcash as it is right now, or let's say with ZSA, but no programmability? Is that sufficient to have most of the benefits of Zcash being this large pool of privacy and just do bridges to other blockchains? So how do you guys see this big functionality that's not there, programmability? Is this something that has to be added, or I guess Brian, you had, or maybe let's start with Christopher, but then Brian, give us your angle.
Sorry, I didn't mean to front run you there. I'll keep it quick. I think this kind of ties back to the central question of mission. Kit, you started describing a mission of Zcash as Bitcoin but private, and boy, it would kind of be cool if we lived in the alternative timeline where there literally was Bitcoin, but private, like where the ZK snarks developed by Zcash just got merged into the Bitcoin protocol. Of course, that didn't happen. We don't live in that timeline. And I think
they tried to cram it. They tried to cram it with BitVM, but that's really, really difficult.
Right. Where perhaps, maybe Zcash could become, I don't know, some Bitcoin sidechain, or Bitcoin could become a Zcash sidechain and therefore allow Bitcoin, the asset, to be used with Zcash, the technology stack, which I think would be interesting. But I also think that the Zcash community faces a kind of question of what the identity in the project should be beyond just Bitcoin but private. Bitcoin but private is a mission and a pitch and a narrative, and really a unified product concept oriented around coupling an asset with privacy technology, right? That is what Zcash built. Zcash built an asset Zec and built a blockchain for that asset, a community around that asset, which provides this world-class privacy technology, which has inspired so many projects, including the ones which I work on. But the world is different in 2025, and if Zcash wants to become some other thing, like a node in this network of composable blockchains, which provide different kinds of services, I think there's a pretty central product question of not just what can Zcash be used for, but also what value can Zcash provide to the rest of this composable network, right? That's a question that benefits from focus, benefits from unity, just in the same way that the mission of Bitcoin but private, I think, united Zcash for a long time and provided a clear set of both technical and product directions and existing metaphors that people were familiar with from the project Bitcoin, which was, of course, known, like Zcash's whole supply schedule, many aspects. Really, it's like Bitcoin, but add the ZK snarks on top, right? But now, at least it seems to me that Zcash is moving into a new era, but that we haven't yet developed, or at least I haven't yet heard, a really clear concept, product concept, mission concept of what Zcash seeks to be and become and provide in this future composable world.
Yeah, there was a moment in Bitcoin, the OGs remember, where there was the idea of colored coins. Do you remember those? Taking Satoshis and painting them in a color and saying, if you bring me back that Satoshi, I think that it's actually $1. And so you would follow those Satoshis around these little UTXOs that are special, and that was, and in a way you could say that assets on Zcash is this incremental jump of being able to issue assets on the Bitcoin but private, but it doesn't have the full-fledged power of an EVM or all those next level innovations that in 2025 everybody is already expecting. But Brian, what do you think about it?
There we are. Yeah, it's a really interesting question to me, because I see a dichotomy between Zcash is super cryptographically secure money, and that is what it is, and that is proven with these documents and this careful study that's been done on the implementation. On the other hand, I feel that there is a place where support for developer community side extensions to the way that the protocol works is valuable, both for flexibility and for pace of improvements. Like, for instance, Kit brought up this question of more flexible selective disclosure, right? Where you want to say something more complicated about the state of a node on the Zcash blockchain, right? And right now, in order to support that, you have to have some external infrastructure, or you need a full-blown update to the protocol. And for a protocol that is so focused on very careful, rigid security, it's slow, it's hard. And it's difficult for teams to engage with that process and get what they need within the protocol and within the community without stepping out to other sides of things. So that's like my like big question in my head, like is that worth it at the cost of like extra complexity in the protocol and a slightly less focused goal? My personal feeling, and this I feel is it's something that the community needs to come to decisions on and get buy-in on, right? My personal opinion is that there is a place for programmability. In particular, there's a really nice protocol specification that's called ZEXE, Z-E-X-E, that I like a lot, which is a theoretical setting, but it's been implemented, I think, in the LEO blockchain and various places, Mina protocol, at least in part. There's like different parts of this that have been implemented, but it is really compatible with the Zcash architecture in a lot of ways. It is still based on the basic idea of a commitment tree, which are used for note commitments in the case of Zcash, but in this protocol, it's kind of generic commitments to data associated with operations on the chain. And nullifiers are used for updates, and there's various things that you can do. And then it uses a generic programmable snark infrastructure so that the proofs are not just proof of proper transactions occurring on Zcash in the ways that are expected, but it's a proof of a snark circuit that an application can provide. And so it provides general logic capabilities without changing the basic underlying infrastructure of commitments, nullifiers, and snarks. And it fits really well with just the way that Zcash already works and doesn't require large updates. There are lots of details involved in getting this together. So I would not pose this as an incremental change to the protocol. There's a lot. You need some way of providing a domain-specific language to provide generic snark programmability. You need to study the infrastructure and provide the rigor that's expected from Zcash. It's a really significant project, and it requires consistent effort over a significant time by a team that is focused on it. So this is why I say that really community buy-in is essential if something like this were to be incorporated into the protocol. But I really think that the possibility is fascinating to me. It fits really well with what Zcash is right now, and I think that it would help to accelerate application development and adoption in some contexts by incorporating these capabilities. So.
Go ahead, Alex.
Yeah, if I may add to that, I really think that any singular blockchain needs to focus on doing one thing pretty well, better than anyone. And then you can also do some other things now that you have a captive audience, some other lower hanging fruit that most people would like to use and have that hardware within the blockchain itself. I would caution against trying to do everything. And I think that this is a sentiment that has proven that is not right. In any engineering decision, there are trade-offs, right? Let's say you're making a chair. If you want to make it strong, you make it heavy. If you want to make it nice, you make it expensive. If you might want to make it comfortable, you make it easy to stain. I think it's the word. Sorry about my bad English. But we're always constantly looking at these trade-offs, and those trade-offs inherently yield diversity in design. You have a huge design space that blockchain is addressing, and that means that there will be more chains, because previously people thought there would be the one chain to rule them all, and empirically we can see that hasn't been the case over the now what is it 17 years of crypto. We've seen the design space open up instead of coalesce around one or two designs. What that tells me is that there will be always a drastic diversity of chain designs, and how you stand out is by specializing in one thing, and then doing a few other things well, and then choosing the battles that you're not going to fight. And I think that's kind of rather than what should Zcash do, I would focus more on what is Zcash committing not to do, and why, because it's not compatible with the type of audience and use cases and
I have an anecdote on that actually. So ZSA is a Zk shielded asset is a place is a big leap forward in capability in Zcash, And as the team that is building it was considering ZSA as a place of potential experimentation further down. So, if you experiment on an asset that is not ZEC, you limit the potential bad outcomes if the experimentation doesn't succeed. So ZSA itself is very, very solid and reviewed and audited, etc. But at some point, we presented to the Zcash ecosystem the idea of bringing stablecoins to Zcash. And one of the things that stablecoins want is the ability to figure out what happened with the stablecoin when the user wants to redeem the stablecoin for fiat in a bank. And we proposed to research the direction of verifiable encryption to the issuer. Basically, if I put it bluntly, Zcash taking a sharp turn for this particular feature for ZSAs, with the ability for a user to self-snitch, to send the details of all their transactions to the issuer in a way, like encrypt to the issuer. And in that way, an issuer would come and create a stablecoin on Zcash. And we proposed that research, and the results were very, very clear. That's not compatible with the DNA of Zcash. We know what we want to say no to. Now, yes, the way it happened was not the most pleasant on the receiving side. Shout out to all those people on the forums participating in that. But it does show that this community does have a sort of center of gravity where it has a line. It forces actors like Kedit to seek other ways to add these type of compliance features outside of the protocol that don't affect directly the core protocol, but it does show a line that Zcash is fairly committed to. Henry, I just triggered you so strongly.
Not exactly. It's more that I have an observation here that is related, and it's that I think, and also is also a way for me to shoehorn in my answer to the question, which is I think that a big kind of gap for Zcash, and if I was going to point to one thing that is like make or break for Zcash, it is actually interop and interoperability with other chains, with other ecosystems. And this whole saga with the ZSAs and the stablecoins and whatever is kind of a microcosm of some of the issues that come from not having a good interop story, right? Because as I understand the design for ZSAs, the idea is that the sort of mint and redeem feature for the custom asset is done by some asset issuer who's issuing the asset on Zcash. And that's kind of unfortunate from a product perspective because it basically permissions the Zcash shielded pool to only have sort of approved assets. Like you have to go and get buy-in from whatever asset issuer. And on the other hand, if you had permissionless interop, then all of these sort of problems are kind of sidestepped. Like in Penumbra, the way that custom assets are minted is they're minted as a result of an IBC transfer from another chain into Penumbra. And so today, you can use USDC on Penumbra, and that works because USDC is issued on Noble, and you can bridge it over. You can also use USDY, and yes, there's like selective disclosure features that are already built as part of the web wallet that are going to be put into a sort of full sort of disclosure tool. But fundamentally, it solves the problem of having to coordinate each and every individual asset. I think the big unlock for Zcash that needs to happen is some kind of interop capability. And I think the current sort of blocker for that is the difficulty in other chains like reading the state of the Zcash chain. And this is, as a preview, like a thing that I will like harp on endlessly tomorrow on the proof of stake panel. But I think like the single most important consideration for any proof of stake version of Zcash is, are there good economically secure light clients for whatever future consensus protocol there is? Because that's the unlock that enables permissionless interop, and permissionless interop is the unlock that enables permissionless usage. And that, I think, is the big thing that people should focus on. And yeah, I'm totally happy to give opinions about it. Take my opinions or don't, whatever.
This is an informed opinion, because you showed this functioning on another system. I think the original interop was HTLC, right? Just the ability to pour an asset from one side to the other with the pre-image of a hash, just that basic ability to link value between one side of the transfer and the other. There's a proposal that's brewing specifically on finally getting Zcash to have HTLC capability that is on the table somewhere in the pipeline. It's like level 1 of the interop. But what you're describing, which is the issuance of assets as the result of something happening elsewhere, provably, and the other way around, which is reading what happened on Zcash in other blockchains, that's really the holy grail of connecting Zcash elsewhere. I think a step in that direction happened when we moved to Zebra and started working on Rust. That makes it even possible to dream the Zcash node verification happening in kind of like a ZKVM or something similar to that. Okay, so we explored a little bit what could be added to Zcash. I think let's start to close in on the big picture. And I think I want to get back to you, James. This will all succeed if users don't need to think about any of the details and have what they expect just work. Can you describe a little bit what are we about to get with this integration to Brave?
Well, I may pull a little bit of this from the previous question. Interoperability, I think, is absolutely important. And if you were to ask someone who's like maximally invested in Bitcoin, they would say like, don't do anything else. And if anything else is getting any spotlight, then it's taking away from this global central currency. But going back to my first mention of, you really need privacy, I think, at the core, or you're going to have this massive cultural shift and privacy norms. Interoperability is key for growth here, and this is like speculation. I told you it might have some. This is way out on a limb, but I think you're going to be seeing and this goes to what Alex said as well. You're going to see blockchains really focus in on what is our core strength. And trying to appeal to a specific solution, right? These are all kind of, you sort of abstract one level above primitives, and you've got blockchains kind of, what could you see being that main value? I think what'll happen is you may have the browser using AI, composing a user-tailored smart wallet that takes tokens on a schedule, bridges them over, through some sort of bridge or Alex's bridge, whatever it is, into Zcash. You might have the browser scheduling, on the 15th of the month, you've got a notification saying mortgage due, you're paying it with Zcash. It's just shielding it. No one sees that. But you could have all these other layers. You could have the AI layer on Near. You could have other stuff happening on EVM, you're going to have all these blockchains more or less fulfilling a different need and being a tool in all of these solutions. But you really need something to pull it all together. And it's going to start with wallets. I think as a browser, we would start exploring how do we become key management? How do we sort of like create new protocols, communication protocols, so that we allow access to the device enclave, and like open it up, right? Being a singular wallet, it's not going to also solve the problem. I think as a whole industry, you're really relying on other people to build really, really great tools, not necessarily try to do everything.
Yeah, I think it's a great place to plug something happening at the end of this month. So Sophia is coming to Sophia. There's Sophia, the main cryptographer at Brave, is coming to Sophia, the city where we have ZK Proof 7 happening. And right before that, there's the Zcash developer conference. Right after that, there's Real World Crypto. And what Sophia is going to be talking about is adding another gesture to the browser, which is TLS notarization, using zero-knowledge proofs to demonstrate things from your session, your HTTPS session, a fact about yourself that you can then use to interact with blockchain contracts and show them that, I don't know, your balance in the bank account, or your age, or your number of stars on Uber or whatever. This place that most of us live in the browser. So the fact that Brave is blessing gestures that have a core cryptography in them is phenomenal. It's outstanding. I wish there was more Brave browsers out there, like small Brave, trying to take an example from that. And I think it will arrive once these capabilities are used and demonstrated. This will create a competition level that others will need to catch up. So we might end up with privacy, payment, and demonstration of facts using TLS notarization in all the browsers, thanks to the Brave movement of Brave. And if you don't know what I'm talking about, ZK Proof 7, check it out on zkproof.org, because it's really interesting. Does anyone want to add anything to this part? My last question is really, let's say, a very open one, which is a question of responsibility. We all are practitioners of a very, very strong set of tools. These privacy techniques are almost give us asymmetric power. We give the users the ability to do things without having to answer anyone. Just the math is allowing our users to do a lot. It comes with responsibility, but also we are as a community of builders, we are the ones that are capable of bringing these tools to the users. And if those users need the tools because, let's say, their governments are becoming difficult to work with, then it's on us to try to figure out how to bring those tools the best we can, and as adequate to the situation as possible. So this broad question is, do you feel that that this destiny requires more privacy? And if so, why? What I'm aiming at is just understanding why privacy is important, and are we are we doing it the right way? Go ahead.
So the first thing to kind of understand why we're on the right side, I think, is freedom is a bedrock to prosperity. As we've seen societies be more and more free, they become also more and more prosperous. And you can compare the levels of freedoms or lack of freedoms in any given country, and you can then derive from it their level of prosperity. You look at Switzerland, which is one of the freest countries in the world, and you'll see that it has derived prosperity. Now, the thing about freedom, though, is that it's long-term prosperity, not short-term. And short-term, we can be tempted to trade freedom for security. But as soon as we start making those compromises, the problem with security is that it's usually a honeycomb. It's something that's controlled by someone or policed by someone, and that can be conquered and abused later on. So the thing about not having that trade-off happen, with freedom, you actually make societies be more equal, and not through equal outcomes, but through equal opportunity. So the problem with freedom, though, is that privacy and permissionlessness are two key ingredients to have freedom happen. Because what freedom does is give power to the many. The more free a society is, the better they can shield themselves from the few bullies in the neighborhood. And if you take that privacy away, you actually give an edge to those who seek to abuse power. So that's why I believe privacy is so important. If you believe the majority of people are good, which is an assumption that you have to agree or not with, I believe it to be so. If you go, to a party, you don't need someone to police the party to have a good time, and most people will behave. Most people are good, and I see that happen when you go to the mall, when you go and travel. Most people are good. So if you believe most people to be good, giving them all privacy actually yields a prosperous result over the long run. So that's why I believe, yes, there will be people that abuse the street, but that doesn't mean the people building the street are bad. It just means that some people will give it bad use, but you empowered movement, freedom of movement, to also the 99% of people that are good. So even in an utilitarian argument, you're objectively doing good. But even if you start looking more at the morality of it, just empowering those 99% of people against that 1% of people that will abuse things is a net good. So that's why I believe privacy to be important.
Thank you. Kit.
Yeah, I just add to that. I think in my mind there is, as I'm explaining to people why I do this, and I think of these bits of privacy as little droplets of power, and we, sure, they're powerful tools, but we only get a little droplet to go with what we have. And when I send a signal message to somebody and I then don't get an advertisement on my browser about that message I just sent, I'm just like, that's a little drop of power against, Google advertising to me, or a political statement that I don't want tracked back to me. And these are little drops of power that we all have, and we can exchange. And I think what we're doing is we're making those tools for people where everyone can just have that, and yeah, there can be abuse, just like what Alex is saying, but by and large, people are just trying to live their lives, and also it's very democratic in that, or it disperses power, right? So if everybody had these little drops of power, then somebody doesn't have the whole reservoir, who can and how to just say, I think with the, I don't know, this just jumping into a little controversy here with what happened with ZSAs and the stable coins is that I think the problem was that stable coin issuer got to put in the setting that says, okay, everybody who uses this stable coin, your stuff can be read, but you don't have to use this stable coin. And if instead, I think the Zcash way, and maybe other people would disagree, but I think the Zcash way would be we have the stable coin, and each user gets that drop of power to say it is that, and maybe there's a law that says to all the users in this country, they need to disclose this, and just like I disclosed things to the IRS in the United States of America, I do, but it's this, I am the discloser. The power is with me to do that. And that's, and, you know, so often with, you know, these sneak and peek, what do you call them? Searches, you know, where the feds just want to look in and take a look without anyone knowing. I have a problem with that. I don't have a problem with search warrants, you know, where there's a judge involved and we have a system to do this personally. You know, maybe some people do, but there's this element of personal power, and I believe that's the important thing. So,
Christopher, thank you.
Yeah, I would just add to what has been already said that I think it's easy to kind of back ourselves into the implicit rhetorical frame of looking at the world in the past, you know, decade or two, which consists of large-scale surveillance systems, and trying to justify why we need to add privacy to that, because like your rights are being violated, and you know, we, the cypherpunks, are here to add some privacy and protect you. And that's not wrong, but I also think in some ways it's not necessary. Privacy is not, you know, the metaphor of privacy, I find, at least in talking to, I don't know, regular people, can create a lot of confusion, because a lot of people associate privacy with an act of hiding. And an act of hiding makes sense in a world where, frankly, light rays are bouncing around. When, you know, you want privacy about what you're doing in your kitchen, you need to pull the blind shut, right? You need to engage in some kind of action to create privacy, right? But that metaphor doesn't apply to digital technology. By default, your information is on your computer. It's wherever you created it until you choose to send it elsewhere. So what the kind of large-scale surveillance systems and other services that eventually ended up being bundled with surveillance-based business models have done is couple these choices. They've made it the case that either you can use Google or use Facebook or use the Ethereum blockchain and disclose, well, in the case of your Ethereum, all of your data to everyone. In the case of Google or Facebook, you know, all of your data to Google or Facebook or whoever they might sell it to, or, you know, sub-agencies of the US government acting without court orders or whatever. But there's nothing natural about this arrangement. Like it's not some natural outcome of what technology does. Technology can do lots of other things. It has little precedent in human social affairs. You know, most human social systems, including financial systems, including like credit money, including all kinds of money, have had basically privacy by default up to and including the present, including the modern banking system, right? And how the modern banking system still grants a degree of centralized surveillance power to state apparatus and state apparatus, you know, to corporations that is new in human history, but it's still much less than transparent blockchains. So I think another way to approach this question that at least I have found helpful is not to even attempt to try to justify why we should add privacy to the weird, wonky, you know, surveillance-oriented system that is currently popular, but rather talk about how humans have used money and credit and finance and messaging for millions of years, and in social groups and patterns that people intuitively understand. You know, you don't tell everything to everyone you talk to. That would create a lot of chaos. And talk about how building the ability to selectively disclose information into digital technology is just making that technology work for people in the way that people have expected to be able to use it, frankly, quite reasonably forever.
Excellent point. I would frame that and post that directly on the as a good summary. Okay, I think we reached our time. I want to thank each and every one of you for a really interesting conversation, and for people that are watching us and have questions. I think that the Whova allows to send questions to each of our participants, so you're free to follow up there. We're listening. Thank you very much.
Thank you, everyone.
There were 6 original members of the ceremony. One of them, whose pseudonym was John Dobbertin. And he's a world-famous household name, but I don't know if anyone will ever know who he was.
One of the things that really took me down the crypto rabbit hole was the ceremony.
The ceremony.
The ceremony. Ceremony.
No cryptocurrency has ever launched with a more detailed process than Zcash's ceremony. Zcash is a privacy-preserving cryptocurrency that allows users to create end-to-end encrypted transactions. But to start Zcash, the inventors encountered a few challenges.
There's this critical, problem or stumbling block, which is somebody has to generate the parameters. They have to generate this cryptographic structure. And if the person who generates that cryptographic structure secretly keeps the key that they use to generate it, then they will be able to counterfeit money.
When launching Zcash, developers create a special key that is used to lock the code that runs the currency. With the code locked, no one can generate any counterfeit transactions. But there's a catch. Users would have to trust that the developer who locked the code also destroyed their copy of the key, and that no one else duplicated the key. This issue became known as the trusted setup problem. In order to launch Zcash, the team devised a way to pull off the trusted setup as safely as possible.
One way to mitigate having to trust one person to do this computation correctly is to trust that at least one of many people did the computation correctly.
By involving multiple people, they divided the control. Now, instead of just one key locking the code, there would need to be 6. And as long as just one of those 6 people destroyed their key after the setup, Zcash would be launched successfully. So in 2016, they carried out this process in the ceremony.
There were 6 original members of the ceremony, and I recruited a few people who knew about Zcash. One of them was a hacker who was a Bitcoin hacker. One of them was this information security consulting company that we had hired and paid to both do the ceremony honestly in one room and also to attempt to hack the ceremony as best they could in the other room. And then there was me and my friends that were part of Denver Station. Then there was Andrew Miller and Peter Van Valkenburg in their separate locations. And there was the 6th person whose pseudonym was John Dobbertin. We kind of hinted that John Dobbertin was a pseudonym, but nobody knew who John Dobbertin was or anything about him.
After the original 6 members successfully completed the ceremony, Zcash launched in October 2016, but it underwent significant improvements in the years that followed. To upgrade the currency, they would have to conduct the entire ceremony process again.
We did the 2nd version, and that version had some science upgrades that enabled us to have a large number of participants.
That's what we did 2 years after that when we launched an upgrade to Zcash. We involved multiple people, at first 6 and then hundreds of people.
But despite the success of both ceremonies, a problem remained.
People don't necessarily trust the trusted setup, even if there's 1 million people. How am I supposed to believe that they were honest, and how am I supposed to believe the ceremony even took place, and so on?
It doesn't matter how good the trusted setup is. It's not good enough for trillions of dollars, billions of users, hundreds of years. We gotta do better.
Getting rid of trusted setups is ideal.
At the time, the science needed to make highly scalable zero-knowledge proofs for systems like Zcash didn't exist until 2019, when Sean Bowe made an unexpected discovery.
So I spent a long time trying to come up with a way to make it more efficient. I just stumbled upon a technique to do this zero-knowledge proof construction on completely ordinary elliptic curves. And so over the course of maybe 24 hours, it went from, ooh, that's really exciting, that'll be neat if we can do that, to, holy crap, now we don't have trusted setups or anything. It's all really simple. It was a series of steps that turned from a nice insight into a complete paradigm shift.
Sean Bowe had solved the trusted setup problem, and with it, he'd solved a long-standing issue in cryptography. His discovery is already being deployed and built on by researchers and businesses.
There's really nothing that compares to that feeling of being a high school dropout that contributes something significant to cryptography and the history of cryptography. That's really cool. I think that's, wow, I'm really lucky to be able to do that.
Getting rid of the trusted setup meant that the greatest risk of counterfeiting had been removed. Sean's discovery had made Zcash significantly safer for the future. They called this new upgrade Halo.
That is what we're about to activate in Zcash mainnet. Zcash will be, for the first time, a completely private money system in which there's no questions anymore about how you set it up, because there is no setup. It's just pure math. Trusted setup is a thing of the past.
The discoveries in the Halo system unlock the potential for Zcash's future.
The new Halo-based payment system, it could be really powerful for both interoperation and also for scalability.
It's just about making sure that the protocol can support all 8 billion people on the planet.
Halo offers new avenues to increase Zcash's usability, and by eliminating the need for trusted setups, it offers a chance to let go of the last secret from the ceremony.
Oh, I've got to look at something. Oh, awesome! I'm so glad I looked at this. Last night, I sent a letter that meant a lot to me. Are you recording this? You should record this. Last night, I sent a note to John Dobberton. Sir, I said, long ago, about 5 years ago, I told you I would keep the secret of your participation in the ceremony until you told me it was okay to share it. And just now, as we started recording, I got a message back from John Dobberton. He said, as long as it's clear that I was never paid and had no stake, it was just a public interest thing, I think you can tell people. And today, I can finally let go of the last secret. Are you ready?
So, who are you? Can you confirm that you are John Dobberton and that you participated in the Zcash ceremony? And can you tell us why you participated?
Okay, there's a lot there. But, my name is Edward Snowden. I participated in the Zcash original ceremony under the pseudonym John Dobberton. The reason that I did that was I saw it being worked on by a number of trusted academic cryptographers. And I thought it was a very interesting project because when we look at cryptocurrencies in general, we generally see the cryptographic properties of it being used to make sure it's a fair ledger, but not that it's been used to ensure that it's a private ledger. Bitcoin, quite famously, is an open ledger. The problem with that is you can't have truly free trade unless you have private trade, and you can't have a free society without free trade. And so, you know, I didn't design algorithms or anything like that. I left that to the people who actually knew what they were doing. But when it came to this concept that they needed many people in many places, all cooperating, in the hopes that just one of them might not be compromised, might not work sort of against the public interest, and that was necessary for the ceremony to succeed, I was happy to say, sure, I'll help. But the best step forward beyond the ceremony is to remove the need for it entirely. And I'm just really happy to see that the Zcash project, which, you know, I've never really worked intimately with, has managed to keep moving beyond, you know, the initial steps, to keep improving and sort of move us closer and closer towards that ideal of a free currency, which is also a private currency.
How does the Zashi Flexa integration protect consumer privacy?
Great question. So wallet developers today have a number of options when it comes to enabling payments for their customers. They can enable payments at merchant locations that would natively accept a particular chain like Zcash. They can enable payments by setting up a credit card or debit card partner, or they could use something like Flexa. Of those, the native payments are probably the most onerous and the most precarious. It makes for a number of different compliance and regulatory questions that I think are still unanswered, both on the merchant and the consumer side. The credit card and debit card approach is the most privacy invasive. All of us who have signed up for a debit or credit card know all the information that we have to put on that credit card application form or the debit card bank account opening form. And it is onerous. Who's your spouse? What's your social security number? Where do you live? What's your full legal name? All of this information gets collected and then gets stored and used against all of our future payments. What a lot of people don't realize as well is some of it is actually encoded in the card itself. And if you were to get a magstripe reader off of eBay or Amazon and swipe your card, you'll see your name in the card, which means your name is actually traveling with you every time you make a payment. Online, it gets worse, where other types of data fields are sent across, and certainly billing addresses are a problem because they're an ill-conceived solution to trying to secure payments that came about many, many decades back as the internet was first evolving. How do we secure online payments when we don't have more information or more pins to secure it with? We have the name and address at the top of a bank statement. Okay, great. So now you're sending someone's home address along with every single transaction to every single merchant that someone pays. This is ludicrous. So in terms of protecting consumer privacy, I think what the Flexa SDK does and what this integration that we've built with Zashi does is it eliminates all of that. There is some information that Flexa is legally required to collect, and we have gone to literally the laws themselves to parse out exactly what is the minimal amount of information we can collect on behalf of a customer. We collect that, we keep it, we don't do anything with it other than what we're legally obligated to do, and we certainly don't share it with Zashi or with ECC or with any of the merchants you pay. And so what's cool about that is it solves the question of, when I'm making a payment at this store, am I going to be able to be tracked across to this other store or tracked over to this other brand that might be owned by the same company? And the answer is no. Every single payment that a merchant processes via Flexa looks exactly like every single other payment that a merchant's processed, unless you share things like your email address or your loyalty account with the merchant. And we think that's the way it should be. We've been working on a lot of ways to even further obfuscate those transactions, but to give you an example of how much we care about privacy and personal data, we don't even store IP addresses. We don't do anything more than what we have to do with the information we collect, and we're very transparent about when that information gets shared. We post an annual transparency report that shares publicly what information requests we've received from various government agencies. We care a lot about trying to fix this problem of private personal data getting shared. And I think it does go back to the Cypherpunk manifesto and this idea of electronic money and the storekeeper not needing to know anything about me if I want to buy a magazine, for example. So that's how we are working to really, really protect the privacy of anyone who's making payments.
those of you who were in the last conference, the panel with the folks over at Brave and people from Zcash and Penumbra, we were discussing a lot about how there is this phenomenon today on blockchain that essentially blockchains are getting to specialize into doing one use case very good, maybe some other use cases somewhat good, and then choosing what not to do. And we noticed early on that because of this phenomenon, there was always going to be chain diversity. And the problem of chain diversity is that all of the permissionless attributes chains usually have do not translate well to moving between them. They do not cover you moving between two chains, and that's why we've seen the development of these centralized exchanges. Now, my problem with that, when we ended up founding Maya Protocol, is that this totally breaks the core tenet of blockchain that started with Bitcoin's white paper of peer-to-peer cash, which is permissionlessness. You should be able to move freely, not only within a blockchain, but between blockchains. And that's essentially what we set out to do. Well, what we did already 3 years ago was started to fork ThorChain's code. ThorChain, like Maya, is a cross-chain AMM DEX. And essentially, what we're trying to do is reach as many blockchains as we can and as many use cases as we can, so that we can permit people move freely between chains as well in the same permissionless setting as they would usually do when they're moving within a chain. So yeah, it's based on Cosmos SDK as well. And what we have essentially is a network of nodes who bond collateral to then be able to protect assets from liquidity providers that then permit users like you to just swap across. What would this look like? Well, simply like a Bitcoin to ETH swap or an ETH to ZEC swap in the future. Think Uniswap, but cross-chain. And today we support Arbitrum, Bitcoin, Dash, Ethereum, Kujira, ThorChain itself, so we can aggregate with other assets supported on ThorChain, and Radix. And what we are looking to launch in 2025 is Zcash, Cardano, and Caspa. And of course, more with many years to come. So essentially all the time what Maya is doing, and I'll have a very didactic video to show in a second, but all the time there's swaps coming through, like this USDT to Bitcoin swap, and they're happening all the time. You can check it out on mayascan.org. And I took this transaction as an example. And the interesting thing is that you don't really need to have Maya or Kaka, which is our native coin, to use these DEX. You don't need anything except your money in the source chain and the address you want to send it to in the target chain. So in this case, someone had some Bitcoin and wanted to receive some ETH to this address. So what they did was just use Edge Wallet to send some Bitcoin, and Maya will observe this. From the memo, this communicates to Maya what to do with it, and we know they want Ethereum sent to this address. So we do that swap logic internally and send the user the ETH. Now, the very beautiful thing is that Edge Wallet also included what we call an affiliate fee. Edge Wallet said, look, and I'm sending this user, please pay me 75 basis points on the swap. So the user in Edge Wallet is paying Edge for the service of providing this functionality within his wallet. So Maya is not only this way for permissionless movement between protocols, but also a way to monetize wallets, and this incentivizes wallets to bring this functionality to your favorite wallet out there. So we're talking about, we'll see some wallets that already currently support Maya. There's more coming in the future, but also for you guys, Zashi users out there, Zashi could have, they're working on being able to swap ZEC to BTC, and this will be a very brand new private way for Zashi to monetize the wallet and fund its continuous development into more privacy features for you guys. Essentially you can also here see some stats before I go to the video. We are able to process millions of dollars of transaction volume per day. And this is all enabled by our validator set, which is right now around 35 nodes that are over collateralized. The code allows today to have up to 120, and over the long run, we'd like to have 250 or more. And these are all anonymous nodes that, again, are over collateralized, protecting liquidity provider assets to facilitate these swaps. So with that all out of the way, I'm going to show you a short video that we created. I actually presented this in January in Cancun with the Zcash team. They're at the developers summit, and our team made a video out of it, and I think it's appropriate for today's setting. So hope you enjoy.
Have you ever wondered how Maya works? Let's take a look at the life cycle of a transaction. Imagine we have 3 blockchains. Zcash over here creating blocks, Maya also creating blocks, and finally Bitcoin. Maya constantly monitors what's happening on Zcash through Bifrost, a bridge that connects chains and where validators monitor the vaults, which are Maya's addresses on external chains where funds are kept. Now, here's what happens when a user sends a transaction to Maya. They send SEC along with transaction fees. When a transaction is observed, validators begin reporting it from Bifrost to Maya. They wait until 67% consensus is reached among themselves and ensure all chain-specific requirements, such as confirmations on the observing chain, are met. How does Maya know what to do next? The answer lies in the OP return data embedded in the transaction. This data tells Maya, swap to Bitcoin and send it to this address. Here's what happens behind the scenes. Maya uses a SEC cacao pool and a Bitcoin cacao pool to facilitate a double swap. It calculates the required slippage fee and the final output for the user. The user doesn't even need to know Maya exists. From their perspective, it's just a SEC to Bitcoin transaction. Once the outbound is calculated, another key component enters the picture: threshold signature scheme. This ensures no single entity has full control. Instead, Maya uses distributed key signing to securely and systematically broadcast transactions to destination chains. With the required 67% consensus, completes the process by sending Bitcoin to the user through Bifrost. The outbound fee is subtracted, which is determined based on an internal record of fees paid over the past few minutes. This fee is then adjusted with a multiplier to provide some extra margin for variability. So let's recap. First, the user sends SEC plus a transaction fee. Second, Maya processes the transaction, swapping SEC for Bitcoin. And third, the Bitcoin is sent to the user minus the fees, all handled automatically by Maya. You don't need to support Maya as a chain, run a full node, or even hold Cacao to use it. Through Maya's API, you can get real-time quotes for transactions, showing how much the user will receive, also taking care of subtracting all fees. Ready to integrate us? Welcome to cross-chain technology. Welcome to Maya.
Yeah, so as you can see there, Maya protocol has a very clear way of how it works. And for those integrators out there or people with wallets, it's actually pretty simple to integrate. You can do a direct integration directly to the Maya node API that you can run yourself if you run a full node. But there's also 2 services that you can, actually now 3 services you can today use, which is one is Exchange.js. It's a library that abstracts a lot of this logic, and you can use, it's open source, it's free. Or you can use SwapKit or DKit, which are APIs that are even more powerful. They have a cost, so you can reach out to them and they'll facilitate even more the process of integrating Maya. They make everything seamless and easy to just plug in. And you could have literally Bitcoin to ETH swaps tomorrow. And as soon as we integrate Zcash, Zcash to whatever we support. So it's pretty exciting. We're very, very excited to launch Zcash soon, as we really believe on what Zec is building. And this will truly enable easy onboarding of so many more users that today are stuck in Ethereum or Bitcoin and cannot easily move to Zec or back. So looking forward to launching. Yeah, Maya protocol is entirely open source. You can look at a repo on GitLab. You can see what we are working on. There's, of course, many internal features along with the integration of new chains. And in our mayaprotocol.com website, you can go to ecosystem and see all of the user interfaces that today support Maya, and this list, of course, is growing, and you'll soon see Zashi here as well as soon as we integrate Zec. So you can here go and click, and it will take you to the appropriate application. Asgardex, for all of you guys that love open source, Asgardex is fully open source, along with also Mocha, and the rest are varying degrees of open and transparent. Multisig is also open source, and if you are a fan of hardware wallets, KeepKey as well is open source, and they support Maya protocol, Cacao, and swaps. Edge Wallet is also a very good option, and I think it's very compatible with the Zcash ecosystem. So you guys can take a look here, and hopefully you give it a try. Swapping is really, really easy in these interfaces. It literally just, you connect your wallet through some means. It can be a key store, again, it can be KeepKey, multisig, which uses, essentially it's like a abstracted multisig control wallet, which is an extension. And it will literally just give you the balance of the assets you have in different chains, and you will swap just as you would, say, on MetaMask or Uniswap, but this time it will happen across the chain. Of course, this will enable many, many more use cases for you guys. There is, for instance, the case of Desert Leaks, which is a guy that's been living in crypto for several years now. And a problem he usually has is, he'll get paid in Dash, and now what to do? And maybe he wants to be able to spend privately in some store to buy a cup of coffee, and he cannot. Now, with these swaps, that will, of course, enable many more use cases and accessibility to him, and just options. And of course, options is important for freedom. So yeah, that's pretty much what we do. You can take a look at Maya Academy to see some more resources on what we're doing. Today, we're working with Han from Y Wallet, people from Zcash Core, and from the Zcash Foundation to finalize a few details of the Maya integration of Zec, and hopefully it will be done and launched in the next few weeks. We really wanted to have it ready for this event, but some things have been delaying it. Specifically, we're looking to reduce dependencies of external code and make sure that it's as synchronized as possible, so that the user experience is on point and hopefully pleasant for all of you guys. Essentially the rest of the time, I'm very open to answer questions. We answered quite a few of them in Cancun with the developers. So yeah, first question we have is, with Maya, will it be possible to also earn fees by adding liquidity, and what are the risks of the user? That's a great question. We have pools here. Per asset, you're always adding liquidity of your chosen asset and Cacao, and you earn some APR on that. Now, importantly, APR here are backwards looking. Maya does not make a statement about future performance. It will entirely depend on swap volume. Maya doesn't have emissions, subsidies, hidden ways to pop up the APR. It's just literally from swap fees from users. So these will go up or down according to chain usage. Also, a risk you have is you have Cacao exposure. Thankfully, Cacao was fairly launched. Again, it's all fully diluted, and it's generally just a very healthy asset in a sense, but it can still go up and down according to market, user sentiment, as a ZSA on Zcash, now they will have privacy characteristics that perhaps ETH didn't have when it was in its native chain. So this is where bridge becomes useful. But when you just want to move across a chain, having the shortest time horizon of transfer options is the best, and that's what essentially Maya achieves. Now, over on our website, you can scroll down and get involved in our Discord, X, or Telegram communities. On Discord is definitely where you'll find the most detailed and the most active members of the community. You can get involved as a developer and get bounties for contributing different things. And you can, of course, if you like what we're doing, go to X and share our work. And yeah, the reason we're building this is because we truly believe that permissionless is the most powerful thing that Bitcoin brought to the world, and Zcash continues, and we have to bring this also to move in between. Has there been any consideration of CSA support? Yes, and at least in the current design, they're not able to be implemented, although in the future maybe they could. The reason for this is that our vaults are transparent. So as I mentioned earlier, we control vaults on Bitcoin, we control vaults on ETH, we control vaults on every chain we support, and we will be controlling vaults on Zcash, as the note said, with this distributed key. And a very important characteristic of these vaults is that they're transparent, so that any user, integrator, liquidity provider, wallet can verify that the assets that Maya claims they have is really what is in the vault. And also, because we're permissionless, any node can then join the network and can verify the history that everything has been working appropriately from the past to the present. So for this to be conserved, we do need to have either transparent vaults or have a way to fully open private vaults. Now, although there is a way that these keys could be published, it does add a lot of complexity, and it's still unclear whether we would be able to have all of these function. Where we have the biggest Achilles heel in all of this is that Maya today does not support Frost signatures. We just support a direct ECDSA, and very soon we will support EDDSA, but not Frost. So Maya would have to support Frost and then make this added complexity of having these private vaults where we share the keys to the public so that the vaults retain these transparent characteristics, and that wouldn't be possible to launch this year. So to launch this year, we are going with T addresses for the vaults, and in the future, 1-2 years from now, if it seems that T addresses will be retired, we can jointly with Zcash put in the work to support private vaults, and supporting private vaults would yield supporting CSAs automatically. Yes, supporting having a full viewing key for the vault would be useful, is what I mentioned earlier. Again, it adds some complexity, but even if we wanted to go that way, since Maya doesn't yet support Frost signatures, it would not work. These private pools use strictly Frost, and the transparent addresses use just plain ECDSA. And since we use ECDSA, that's what we are forced to use at this time. But again, putting in the work for Frost and then doing all this system for having nodes when they broadcast the vault address, also broadcasting the viewing keys, such that we retain those transparent characteristics, would do the trick, but it would require a second phase of this work. Great question, by the way. I'll be waiting for a few more questions since we have 10 more minutes, and then we can move on, I hope. you guys have enjoyed what we've been working on. It's been 3 heavy years. To be clear, everything about the protocol is permissionless. So you don't need permission to become a validator. You just have to create your node address, run your own node infrastructure, and LP, and post that liquidity as bond. Once the bond is provided, if you're the highest out of the standby validators with the highest bond, like these guys here, you will be able to churn in every 8 days. Alongside it, adding liquidity is permissionless, swapping is permissionless, and also contributing to the protocol is permissionless. What does the integration process look like? That's a great question. Essentially, you have to first support the source chain you want. So if you want to swap from Zcash to something, then you need to support Zcash, wallet balances, sending, signing, all of that. You don't need to necessarily support anything on the destination chain, since Maya will just take care of that logic, send the money to the user, and then the user can view it later when they open another wallet, for instance. But you at least need to support the source chain. So that's why Zashi would support swapping from Zcash, but not swapping to Zcash, unless they actually then support, for instance, Bitcoin, if they want to support Bitcoin to Zec swaps. Now, as for the side of Maya, in the end, really, if you want to just go very bare, you just need to be able to know what the vault address is and how the memo looks like. And the vault address, you can query it on the Maya Node API. That, there's 2 endpoints for that in our documentation, or you can run your validator yourself, or just a full node, so that you can query it internally. So that vault tells you what today is the vault that Maya is observing for inputs of the swap, and essentially be able to sign a transaction in the source address, where you send Maya the transaction with the appropriate memo. And the memos for that are, again, also in our documentation. Now, if you want to abstract this process or add more things, like something we call streaming swaps, which I can explain in a second, then you can just use Exchange.js or SwapKit, again, to make this process easier, as in those, Exchange.js is a library, SwapKit is a library and a framework and API. Essentially, they serve you as a wallet integrator much more tools and information in a much easier way to integrate, so that you can put all of these functionalities in your integration easily and securely. So you can reach out to those teams, or you can reach out to me and I can put you in contact with them, such that you use that in your wallet. Now, I mentioned streaming swaps, and it's actually a very interesting thing, because you might go to MayaScan pools and see that not all pools are very deep, and be preoccupied about the price settlement that Maya can achieve for a swap. The great thing, though, is Maya has this thing called streaming swap, which essentially breaks down a swap into several smaller swaps and streams each over time into several blocks, achieving very small slippage for very large swaps. So we've even seen swaps that are twice the size of the pool depth be settled with less than 50 basis points of slippage. Essentially, we ideally would like to see the Zec cacao pool be at least $500,000 to $1 million deep at launch, and it's something that is achievable between the different parties involved in this integration, and the talks we've had with some people interested in providing liquidity, and that should suffice to have very effective $500 to $1 million swaps across the pool. Of course, deeper is better, and would support having faster swaps in a sense. But we're doing a lot of things on our side to make things more capital efficient and keep working on that price settlement and time settlement dimension. So again, these are Xchain.js and SwapKit. Or you can reach out to me. I'm Alux Smith, just like you saw it probably in the event, on X. Or you can just reach out to the Maya_protocol profile, and they'll relay that message to me. We will be very happy to have you integrate us. We've got 4 minutes left, so probably just one more question. We get it published, and then we can wrap up. I know this is a lot of information, so feel free to also just post questions on X addressed to my protocol or to myself, and we'll be happy to answer them. I also highly encourage you to just try one of the wallets out and test a swap, $10, $20 of Arbitrum to Dash or whatever, so you get a feel of what it's like and what it will be possible to do over on Zcash. Earlier, as we were speaking also with the people from Brave, Brave integration of Maya would allow not only holding Zec, but also onboarding their users that use the Brave wallet functions to move freely to and from Zec directly on Brave. So definitely that and many more use cases will be enabled once this Maya protocol integration is out. Well, it looks like there aren't any more questions, so I'll just wrap up here. First off, thank you to Zcash Core, Zcash Foundation, Han, and Josh for getting so involved in our work. It's been a pleasure working with each of you, and we've had nothing but great experiences. We're very, very excited about Zcash roadmap and to be involved with this great community and what you guys are building, hoping that we can bring something useful to you and bring value to you guys, as I really believe that not only is privacy normal, but privacy is a very important ingredient to freedom, and freedom is the most important ingredient for a prosperous society. So we're really looking forward for this to be rolled out, and welcome to Maya for those who are new here. I hope you have and enjoy a great experience using us, and hope that if you like it, you'll get involved. We need as many hands as we can get, either as users, contributors, providers of liquidity, of participating in the network, or any other way. As we really need this tool to make blockchain as a whole industry be permissionless, not only a movement within a chain. So really looking forward to having you on board, guys. Thank you for your time, and I hope you enjoyed today. Have a great one.
We're for freedom. Freedom from ads. Freedom from borders. Freedom from the past. From constraints. From scrutiny. From expectations. Freedom to express ourselves. Freedom to choose. Freedom to share. To create. To connect. To flourish. Be free. We're for freedom. Freedom from ads. Freedom from borders. Freedom from the past. From constraints. From scrutiny. From expectations.
Cryptocurrency is fundamentally about disintermediation, right? It's the ability to own something directly just through yourself without a third-party custodian. It's the ability to send money in a peer-to-peer fashion without having to rely on Western unions or banks or so on. And, you know, for us who are lucky enough to live in a world where we do trust our banking system, we do trust the rule of law, we trust the government for the most part, we don't need that. It's nice to have, it's interesting technology, it's perhaps good diversification. It's in many ways perhaps a good hedge against, you know, some geopolitical disaster occurring that does throw these things in question. But it's in the places in this world where people don't have that trust in these institutions and in the rule of law surrounding them that they really do need this kind of technology where they can take ownership of their own funds and where they can make a payment or send a remittance and know that it's going to get to the other side without having to worry about one of these third parties taking control of it in the meantime. And so that's where I think that in emerging markets, and today specifically in Venezuela, it's a totally transformative technology. And that's something that I'd like to emphasize as well, is that it's easy to think that, oh, this is still early days of the tech. You know, we're still working on everything from low-level scaling of the protocols all the way up to user experience and design issues. All of that's true, but there are also opportunities where it does make sense for it to be used today. And I think that as a whole, we can do better in identifying those and pushing those. The important thing to remember as well is that fundamentally what we're talking about, and we'll just take Venezuela as an example here, because that's kind of, you know, what we're focused on at the moment. What we're really talking about is a form of aid as well. And that can't get lost in the kind of larger conversation. You know, there's a risk, of course, of becoming these sort of out to space technologists who want to believe that the people of Caracas, what they really need is Bitcoin. No. What they need is food and, you know, basic goods. But to the extent that cryptocurrency can be a means of storing value for them, perhaps even at some point a means of payment directly to merchants, that it can be a force that provides for even an alternate kind of economy there, that is at least one step in the right direction. And so, you know, there are a lot of sensitivities to what we're talking about in terms of bearing in mind what's really going on there, that, you know, people are starving, people are dying. And, you know, we want to be very careful that we are aware of those dynamics and not just approaching this as entrepreneurs or technologists, because that's really not what it's about.
A couple of years ago, I would have been more firmly in the kind of, like Tezos, EOS, whatever camp that says there should be explicit on-chain governance. And now I'm like absolutely against that, and I think that stuff is crazy. So if you look at EOS, EOS has these 21 delegate slots. And to get into one of these delegate slots, you have to basically vote, or you have to have people with enough coins vote for you, right? Now, in total, about 17% of the EOS holders have voted at all. And out of those, the delegate that has the largest number of votes is Bitfinex. And Bitfinex only has about 3.5% or so of all the ETH voting for it. Out of that 3.5%, 1.8% is coins that are owned by Bitfinex themselves. And the other 1.7% is just random people. So with that 1.8%, Bitfinex was basically able to single-handedly get themselves into this list of 21 delegates when they otherwise would not have been able to get in there. And what this privilege gives them is it basically gives them the ability to take a share of the 1% a year annual interest that's allocated to Bitfinex, or that's allocated to EOS delegates. So basically, what this voting mechanism has created is it creates this kind of superlinear pro-plutocratic effect where if you're big enough, then, and specifically if you're big enough to have more than 1.8% of all the coins, you have enough votes that you can use to basically buy up a delegate slot and then use that delegate slot to earn even more money and get access to this crazy special 2.64% extra premium interest rate that no one else has access to. So that's one example of how I think like coin voting governance really manages to fail in the case of allocating capital. And I actually do think that allocating capital really is the kind of killer app of on-chain governance, basically because like ultimately in terms of quality of decision making, right? Like, I mean, I obviously have the public opinion that like Bitcoin's governance has been like fairly bad because it's like overly conservative and values very specific things to much more extreme extents than most actual users of the technology. But aside from that, I think like Ethereum has been fairly capable of just delivering on feature improvements that people want. Zcash governance has been very capable of delivering on a roadmap that I think Zcash constituents are really happy about. Like Bitcoin Cash is starting to push out changes. Like all these other blockchains are starting to launch, and like Monero is doing like community hard forks every 6 months. And I do think that like on the protocol level decision making side, there just isn't really a case to say that this off-chain governance really has serious problems that need to be solved. Now, the one big argument that on-chain governance has in its favor is this idea that, oh, now you can have these big treasury pools that inflate the currency by 5% every year and then use that to pay out, big bounties and donations. So from a kind of raw and economic power perspective, it has clear advantages. But just the fact that in all of the existing examples of on-chain governance that we've seen, they it creates this mechanism that just can be too easily captured, and even can also be too easily kind of partially captured in such a way that it doesn't fail completely, but at the same time it does create this kind of massive rich gets richer effect where people like at the top of the peak get access to these premium, like 2%, 3%, 4% extra whatever interest rates that no one else has access to, and then 25 years later, the crypto elite are by another factor of 2x richer than everyone else. So and then on top of that, there's these issues around bribing attacks. There's these issues around just the facts that if you have 4% of all the coins, you can elect to just outbid everyone else and get delegates. There's the fact that just regular voters don't really have much incentive to actually serve as kind of effective, quote, policemen. So like, I really am just pessimistic about the ability of on-chain governance to kind of really properly deliver on all of those things. And I do actually think that, first of all, like current levels of funding for, at least for Ethereum, are definitely just enough, and I don't think that you can really get that much further by increasing that by a factor of 5 or whatever. Like, I don't necessarily think it's even the right approach to try to kind of have bigger economic guns than everyone else. And then on the Zcash side, like obviously Zcash's pool is smaller because Zcash is a smaller cryptocurrency, but like even still, I feel like like between Zcash, between Ethereum, between different academic groups, between all the open source communities, it just is possible to get enough funding and enough resources to do all of the like hard technological and software development that we want to do.
Like if you get paid your salary in Bitcoin and then you go to the coffee shop and you buy a coffee, not only does the coffee shop owner get to find out what your salary is, not only does your boss get to find out where you go and how you spend your money, which is not what people expect and not what should happen. Random third parties get to find out. Like criminal hackers who are looking for people to hack into their phones and steal their money, they get to find out your salary and where you go for coffee and when. Everyone in the world gets to find out. So it can't really be used for money by normal people at scale with that kind of disclosure and vulnerability.
Privacy is normal, I think, is something that not everyone understands about why it is so important. But that's not the case. Why should it be normal to be private and it not mean that you're doing something nefarious?
If you think about it, our world made privacy suddenly taboo. By making it taboo and saying, well, do you have anything to hide? It's given a lot of the superpowers in our world the ability to just simply dive into our private lives, whether digitally, physically, or whatnot, because they'll simply beg that question, well, are you doing anything poor? Well, ask yourself, if you don't need privacy, why don't you have glass on every wall in your house? Why don't you just run down the street naked whenever you feel like it? There's things that you simply want as your own. You want to have your own thoughts and emotions private when you choose. If anything, I know personally that what I express usually goes through a filter process, right? All of us have a filter. Do we want everything that we say to get out there before we've kind of thought about it carefully, right? Before we can express it? Not necessarily. And that's a level of privacy. And sometimes the thoughts that we have are what we put on our computer, what we put on our phone, what we scribble in a blog, not a blog post, but even like a diary. They're just thoughts. And then we refine that to be able to share that with the public. That's one aspect of hey, these are just simply unrefined thoughts, ideas, in some cases actions that I don't feel are ready for me to share with the people I want to share them with. From another viewpoint, a key piece of privacy that we've expected is in the world of corporate privacy, right? Companies don't necessarily want other companies to know exactly what's going on within their company from a competitive standpoint, right? It's just raw competitive landscape. Don't countries also want privacy from other countries? So entities in general want some level of privacy from other entities, whether it's country to country, company to company, and what are people other than mini companies?
We're for freedom. Freedom from ads. Freedom from borders. Freedom from the past. From constraints. From scrutiny. From expectations. Freedom to express ourselves. Freedom to choose. Freedom to share. To create. To connect. To flourish. Be free.
next? Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David Duchovny.
Duchovny. Sometimes I think I know too much.
Are the chupacabras real?
Huh?
Have you touched an alien?
Oh, God.
Has an alien touched you?
Why is that line moving so fast?
They're paying using digital currency. Not only is it super secure, it's super fast, and you can buy just about anything.
Imagine what I could do with all that free time. I will save the whales. Behold, I've done it!
Mr. Duchovny? Mr. Duchovny?
Yeah.
Can I get your zip code?
Come on!
So I think that we're in a dangerous time. Individuals are very willing to give up their privacy, to get a free Facebook account, to get a free pizza, something like that. But when everybody acts as though privacy isn't important, we end up with a society in which nothing is private.
Crypto came out of nowhere, took the world by storm.
This was the fastest moving technology we have ever seen.
The cypherpunk said the internet and cryptography is going to change everything because it changes the fundamental balance of power. You know, it turned out to be right.
As far as my work with cryptocurrency in Washington, D.C., this is the moment that everything came off the rails.
Decentralized systems all have trade-offs. Community consensus comes at a cost.
I don't want to see people adopting a system that can be used to surveil them. I want to see them adopt something that's trying to protect them.
We have to have some kind of optimistic vision of technology, or you just end up getting the thing you fear but a little more slowly.
When we talk about crypto today, a lot of the conversation is around financial rewards, not enough on how we take ownership of our life and our data.
You know, the big thing in the crypto space is when moon, but I think we should ask, when are we creating a better Earth? That's the real question of this space.
What if we could cooperate? What if we could interact? What if we could exchange from anywhere to anywhere at any time?
name's Derek Emma. Okay, I'm going to be talking about post-quantum Zcash. If I was focused on the right window, there we go. So yes, the trans community is under attack in the US and other countries, and yeah, this talk is for that. So what's a quantum computer? Well, if you ask Google, given how far Google search has gone downhill, it will give you the silly answer that it's true of all computers. All computers depend on quantum mechanics, if they're using silicon chips anyway. But okay, let's try and get a better answer to this question. So there's this thing called the invariance thesis, which is it's about sort of the computational power of computers and how efficient computers can be. So you might know about the Church-Turing thesis, which says that sort of models of computation like the lambda calculus or post systems or Turing machines can all compute the same things. So a strengthening of that is that not only can they compute the same things, but they take fundamentally sort of the same complexity to do it in both time and space, and that can be made more precise. But the sort of the interest in quantum computers is that sort of idea may be wrong. There may be types of computer that can be fundamentally more efficient at some problems. And in particular, we think that there might be an algorithm that can compute discrete logs, say. And so if that were true, if it could compute that in sort of exponential time, then we would have evidence that this invariance thesis was false, which is it's kind of important because that means we're in a whole different set of complexity assumptions than we thought we were. Okay, and despite all that, the hype around quantum computing, this is actually a falsifiable hypothesis, and so it's an interesting scientific question, despite the hype. Okay, so what kinds of problems can we solve potentially with quantum computers? Well, like the slide says, Daniel Simon was actually trying to prove the opposite, that quantum computers could not obtain an exponential speedup. And he couldn't prove that. And so he found even relatively simple circuits could be a counterexample to this. So here we have a function f, and this uf here is computing the function in a quantum circuit. And then there are these other things around here, which I'll explain later. And these are measurements. So we're starting with some state, computing the function on it, doing this other thing, and measuring the result. And it turns out that's enough to demonstrate that the original sort of hypothesis that quantum computers were kind of equivalent to conventional computers, classical computers, was wrong. And this was a huge breakthrough. So he submitted a paper to this theory conference, Symposium on Theory of Computing, and it got rejected because anything that's fundamentally new will get rejected, as we know. Okay, so fortunately, Simon had a really good thesis supervisor, Peter Shaw, and he noticed the similarity of the kind of artificial-looking problem that Simon had come up with to demonstrate the speedup was very similar to some existing number theory problems. And in particular, so this hidden subgroup problem, so particular instances of it could be used to solve factoring in discrete log. So Shaw generalized it, and sort of happily ever after, because both of those papers were published in a competing journal. So that be a lesson to reviewers who are not capable of seeing fundamental advances. Okay, so although Shaw's algorithms are sort of more directly useful for cryptographic problems, we're going to talk about Simon's algorithm, because I think that's the intuition you need for understanding how quantum computers can get speed ups at all. All right, so this is the problem. Says we have a secret value s, which is a bit string. So you have so n bits in the case that Simon originally considered. And we have a function that maps from those n bits to some other space. And that has the property that, well, I'll describe it informally. So the function has sort of copies of itself shifted by some secret bit string s. And the shift operation is just exclusive. Okay, so this looks like a fairly artificial problem, but if you place 0,s here with some subgroup, so G is a group, and you place this with a subgroup, then that is exactly the hidden subgroup problem. And so, we're trying to find S. So if we find a collision on F, then that immediately gives us S. Actually, X and Y are non-equal. So we know that we can solve this classically in square root of the size of the group. And so in general, for a sufficiently well-behaved group, it can be proven that if you don't know anything else about F, then that's the best you can do, basically. Okay. So we need to know a little bit of quantum theory to understand what's going on here. And so like you can model so classical states using probability, you can model quantum states using something called amplitude, sometimes called probability amplitude, but I think that's a bad name. And so the space that so you're trying to, the space of possibilities. So in this case, so possible values of your bit string. Each of those has an amplitude, which is a complex vector, and I'm probably going into too much detail here, but the idea is that you have a particular kind of transformation on these states, and you can measure states, but the probabilities end up being a little bit weird. They're not how you would expect. So when you measure the probability, you get the square of the amplitude, not the amplitude itself. And that really is the key to why quantum theory is weird. And so measuring these states destroys them, which is kind of inconvenient. But what a quantum computer is fundamentally, it's something that operates on these quantum states in ways that depend on this sort of difference from classical probability. Okay. Yeah, I'll skip this. We don't really need to accept that. Yeah. So you'll have heard about qubits. A qubit is basically it's part of the state of a quantum computer that can be in a superposition. Right. So we need some kind of classical mathematics. There's nothing fundamentally dependent on quantum computers about this. So there's this thing called the Walsh-Hadamard transform, which is like a Fourier transform. So it's going between sort of computational basis and a frequency basis, and it's doing that for this group of bit strings, basically, under exclusive for. So exactly the group that Simon's algorithm is operating on. And if we were going to, how this works is sort of apply your function f to every possible bit string. These are the sort of resulting outputs, and then you apply this thing which is like a fast Fourier transform, and you get some output that encodes information about the function. And in particular, it's interesting information to find things like this hidden shift that we're trying to find in this problem. But we can't compute the whole thing because it would take 2 to the n for n bits times n complexity. But you don't need to. So what the quantum algorithm does is very efficiently, it will compute a superposition over sort of all of these output states. Okay, and then the overall algorithm is, so you set up a superposition of n qubits, just uniform here. These are zeros. What I didn't say before is that you can only do reversible computations in a quantum circuit. And so you get out the result of applying the function to that, and then you apply the Walsh-Hadamard transform and you measure it. And so what happens here, and I'm not going to explain in sort of all of the maths, but you get a kind of interference pattern between the outputs. And it turns out that sort of the outputs that can actually be measured here are all of a particular form that gives you 1 bit about the secret value s. And then you just solve this system of equations. So if you've got n bits of information, then you can solve them to find s. So that's basically all it is. And so I think there's a lot of kind of mystique and sort of woo about how people explain quantum physics and quantum computation, and it's really sort of not that mysterious at all. A lot of it is to do with bad explanations of the various interpretations of quantum mechanics. I won't go into detail here. You can look at the slides later. And it's not. We shouldn't be worried that there are philosophical problems sort of with the explanations of quantum mechanics, because there have been for essentially every physical theory, including the examples I've given here of Newton's theory of gravitation and sort of understanding of heat and temperature. So it's not fundamentally different from that. So our CRQCs, so that's cryptographically relevant quantum computers that could actually break stuff that we're using, are they feasible? Well, I don't know, I'm not a physicist, but my sort of opinion is the experiments that have been done suggest that you can put even very big systems in superposition. So you may know about the Schrödinger's cat, the thought experiment. And you could think of that experiment as saying that very big things can't be put in superposition. But that might very well be true for something the size of a cat, but it's not true for the sapphire crystal, which is 16 micrograms. And if you think about how many atoms are in 16 micrograms, it's a lot. So yeah, we can probably build quantum systems and put them into superposition as we need to do for quantum algorithms. And we can make them big enough to solve cryptographic problems, I think. Okay. And so this is a report. It's in English, even though it's by the German government department. And it's calculated basically how many qubits, how many gates, and so on you would need to break these are elliptic curve discrete logarithms over this size of field. So the point here is not the particular numbers but that we have sort of fairly precise estimates of how big a quantum computer would have to be in order to do this. So what are the estimates for when they'll be available, if they're available? So BSI, that same German government institution that I was talking about, believes before 2040. So that is not very useful if so we want an estimate that is pessimistic from the point of view of cryptography. Dan Bernstein is a sort of very famous and outspoken cryptographer who has estimated 2029 for well-funded private attacks. And that's not attacks that would break most deployed systems. It's basically showing that cryptographically relevant quantum computers are feasible and could scale up in principle. So if this estimate is right, and it's 2032 or something like that for a public demo of that, then we really need to get our skates on. So that's only 7 years. Okay, so how does Zcash depend on potentially vulnerable cryptography? It depends on it quite a lot. So we use signatures, we use encryption, and we use proofs, basically. And all of the properties are dependent on those. So this is if, so there's a caveat here, which I'll go into later, which depends on whether the addresses are public or available to an attacker. So there's this thing called harvest now, decrypt later attacks, and they're why so we need to be worried about quantum attacks even before we have we've seen a feasible working quantum computer, because an attacker can just collect ciphertext, collect public keys, and then when they have a quantum computer, they can break those ciphertexts. And the mention of wisdom is that this means that you should focus on fixing encryption. But if this is going to happen in as short a time scale as Bernstein estimates, then we probably want to be thinking about other fixing other properties as well. It's not sufficient just to focus on encryption. And we know that the lead time for deploying protocols is really long. The lead time for analyzing new algorithms is long. And also we don't just need systems to be secure, we need people to have confidence in them. And if it seems likely that quantum computing is going to be feasible, then that's enough to shake people's confidence, regardless of whether of how soon it actually works. Okay, so deploying new cryptography is difficult then, and we might end up making things worse. We might introduce an algorithm that is broken. Okay, so let's look at some of the detail. In Zcash, we need to transfer notes to the recipients secretly. We currently do that by broadcast encryption, so just putting the ciphertext on the chain, having recipients trial decrypt them. And so that only works if the ciphertext doesn't reveal any information about which key it was encrypted to. So it happens that MLChem, which is sort of an algorithm encryption algorithm that's recently been standardized by NEST, that has been proven to be key private. So that's nice. And yeah, there's a difficulty with that, which I'll go into later. So the other issue we need to consider is whether we might be introducing vulnerability if we move to quantum algorithms. So something that focused minds on this is that Cyc, which is a isogeny-based encryption scheme, is now completely broken. And so that was representative of a whole class of algorithms that are now looking shaky. There's still some of them that might be secure. Monkey 3 had a soundness bug. That's a post-quantum proof system. Rainbow signatures were broken completely. So part of the problem here is that these post-quantum schemes, because they're having to defend against sort of attacks that previous schemes weren't, they're more complicated. And they can have side channel attacks as well as direct attacks. So what we could do is combine the post-quantum algorithms and pre-quantum ones that we already have some confidence in. So an example of this is X-Wing. If you're deploying post-quantum encryption, then I thoroughly recommend X-Wing. It happens that there's some issues with using it for Zcash. So it has pretty good properties. It's the public key size is just the sum of the individual algorithms, same for the ciphertext. But there's this issue with key privacy. So if both of the component algorithms are key private, then X-Wing is key private. I'm just asserting that, it needs proving. But there's a problem here, which is that if only one of them is key private, then the resulting hybrid scheme will not be key private. So let's say scheme A, that leaks the public key from the ciphertext, but scheme B is completely key private, then the hybrid will also leak A's public key. And so that's sufficient to say that it's broken for key privacy. And so when the proof that we referenced for key privacy of MLChem, it assumed hardness of this. This is modular learning with errors. It's the sort of underlying problem that this lattice-based scheme depends on. And so part of the reason we're using a combiner is that we don't want to rely on that. I think there is a way around this, but it basically means that we can't use Xwing, and we can't use the analysis that's already been done on Xwing. The other issue here is that we currently have something called diversified addresses, which is really important for the combination of performance and privacy. So the idea is you can give out sort of different diversified addresses to different counterparties, but when you trial decrypt, you only need to do it with one key. And the parties can't tell that they've been given variants of the same address. So how do we extend this to MLChem? Well, it's not obvious how to do it at all, because it depends on elliptic curves being approved. I think there's a way to do it, and I've explained how to do it here, but I'm not going to have time in this talk to explain how that works. But I think there is a solution. We need to sort of prove that that's secure, because there are a lot of subtleties that can make these schemes insecure. So how about pooling systems? Let's say we've done encryption. So part of the issue here is that post-quantum proving systems require fairly large proofs. And the scheme, I think it's Plunky 2 that requires 50 kilobyte proofs. I'm not sure whether Plunky 3 reduced that slightly. But either way, so it's unrealistic to have a 50 kilobyte proof per transaction. So that would significantly impact scalability. And so we're less sure about the security of these schemes. I mentioned that Plunky 3 had a soundness issue. So we could try and use recursive proofs so that so you do have a proof per transaction, but then so you prove something about some group of transactions, and then use a single proof to show that you've done that. So that's what recursion is. So we could use that for the size problem, and then use a proof combiner as for the confidence problem. But there's a problem with that as well, which is that we basically don't know how to do combiners for recursive proving systems efficiently. So yeah, that's an issue. And it's particularly an issue because we might need to deploy this relatively soon. So we can't just wait for a proof system and not do anything before then. So here's what I suggest. We deploy recursion using Halo 2, which is not post-quantum. And that gives us some scalability improvement. And then when we have a recursive post-quantum scheme that is both efficient, sort of has practical proof sizes, and we're confident it's secure, we switch to using that. But we've already done a lot of the engineering involved with deploying recursion. So the changes to the protocol, so apart from the proof system itself, will already have been done. Okay, and there are potential candidates for this second scheme, but it's a really, really fast-moving field. Okay, so we do know how to do proof system combiners, but as I said, the problem is recursion. Okay, signature combiners. So Zcash uses signatures for spend authentication, and so so there's a non-essential use of them for balance checking non-malleability that we could get rid of. Okay, so you just basically include both signatures. That's one way of doing it, and that works. But it turns out that we might not actually need signatures. So we, as I said, we use them for spend authorization and binding, and that's to ensure balance. But we can just use a zero-knowledge proof for that. In a sense, zero-knowledge proofs are a generalization of signatures. And so, they're more powerful than signatures in some way. And we can just replace the signatures with proofs. Now, the difficulty with that is that we use signatures for sender authorization for a reason, and that's what has made the Keystone hardware wallet support practical, because Keystone only has to do signatures, it doesn't have to do proofs. So how can we sort of retain that advantage if we're replacing the signatures with proofs? Well, it turns out we only need a very small circuit that executes on that is proven on the hardware wallet, and is literally just one commitment. So whatever is necessary to compute the public key from the private key, which could just be a hash function. So that is a very small circuit. There is still some question about whether it will fit in a hardware wallet, but I think probably for something like Keystone, or maybe even some of the more recent treasures, I don't know about Ledger, it would probably be practical. Okay. And what we've effectively done here is construct a randomized signature scheme anyway, just from a proof system. So yeah, I just put this together quickly based on Sean's talk from yesterday, which I really liked, about the scalability of nullifier checking. And I think you can combine that scheme with everything I'm talking about here. But the scheme itself is not post-quantum because it uses elliptic curve scale multiplication. So an open question there about how we can make it post-quantum. Right. So size of addresses. This is one of the issues with switching to post-quantum encryption. Let's see, how am I doing for time? Okay, so you can see that LLCAM public keys are about 10 times, so even the combination of transparent, sapling, and orchard keys. So yeah, that might be a problem. I'll show you what that looks like. Yeah, transparent plus sapling plus orchard. So originally for the design of sapling, I was trying to get this on one line. Maybe I shouldn't have tried so hard to do that. And this is the same thing with orchard plus something post-quantum. Yeah, so that might not be practical. It's even worse when you look at it as a QR code. Okay. Yeah, this is some technical detail about whether we could actually compress the MLChem public key a little bit. I think it's not worth it because it would only be sort of a less than 20%. Okay, we could consider using other chems. As I said, Psych was broken, And most of these, if you look carefully, there are no improvement on MLChem, so there's really no point in even considering them because MLChem is standardized. The only exception to that is CSIC. And so that this is potentially controversial because I said that isogeny-based encryption, some of these schemes have been broken. But CSIC in particular hasn't been broken. And I was talking to an expert on quantum cryptography at a previous hacks conference, or was it Real World Crypto? And he seemed to think that it was potentially secure still, but we'll see. And it's a little bit slow. So what can we do to mitigate this problem? We could transfer nets over point-to-point connection. This has been discussed in previous sessions. So there are other advantages of using point-to-point communication, especially in terms of chain bandwidth. So it's probably worth considering anyway. But I think we would need mixnet because, as was also mentioned, things like Tor don't provide privacy against the global adversary. So NIM, there has been some work on using NIM with Zcash, and I think that's the approach to take there. But there are use cases that it doesn't support, like posting donation addresses on social media. The other thing that we could do is we could sort of use the blockchain to register addresses, and then you refer to those addresses. That also has difficulties because you need to send the transaction registering the address anonymously. So it doesn't really solve the problem of needing a separate anonymous communication mechanism. Okay. Also, you would have to, so if you want to use diversified addresses, you have to put each diversified version of them on the chain, and there might be sort of metadata timing correlations between those. Okay. So there's another thing that we can do, which was that the original zero cache protocol was designed to have this property called everlasting anonymity. I think it's a bad name actually, but the gist is that we still have the same privacy properties, excluding diversified addresses, in a post-quantum situation, provided that addresses are kept secret. And we maintain this property sort of throughout the development of Zcash. We made sure that all of the symmetric cryptography is using key sizes and sort of other crypto values that are large enough. And I don't need to go into detail here about Grover's algorithm, but it basically the conclusion is that it's much more difficult to build computers that run Grover's algorithm, which is what you would use to attack symmetric cryptography, than it is to attack public key cryptography. So I'm not particularly worried about any of the symmetric crypto in Zcash being vulnerable to quantum computers. So how do we take advantage of this property? So some protocols that are used in messages. So if you're trying to send your address to a counterparty. If you do it over one of these apps that have upgraded their protocol to specifically to address host and decryptolator attacks, then that's probably sufficient, at least for now. And I think they will sort of move to fully post-quantum protocols at some point. So those are Signal and Apple iMessage, and basically nothing else. Not even, as I'll go into in a couple of slides, other apps that use Signal protocol can't really be relied on. But that only works if you tell your counterparties to keep the addresses private. And so wallets at the moment are not really designed to keep addresses private. So it may be kind of slightly unrealistic to depend on this this property of the protocol, even though I think it's an important property. Your wallet backups will contain copies of your addresses. If the encryption that those backups are using, if they're either unencrypted or they're encrypted with an algorithm that is going to be broken by a quantum computer, then you don't have private addresses. And reply addresses can sort of weaken this property. So basically giving your counterparty your address, and if the counterparty is an adversary, then you give them your address. Okay. I think that's a duplicate slide. So no other messaging apps to pay attention to this property at all. A lot of messaging is not end-to-end encrypted at all. These systems, some of them claim end-to-end encryption, and they don't reliably have it at all. Here are a bunch of protocols that sort of rolled their own crypto, and none of it is resistant to host and decryptolator attacks. As I said, even the ones that are based on Signal protocol. And the session here, they previously used Signal and then they were moved to something worse for some reason. Facebook and WhatsApp do use Signal, but I can't find any information about when or whether they're deploying the HNDL resistant ones, and I wouldn't trust them anyway because they have terrible policies. Okay, so what's next? So Sean and I will try and find out whether that idea for scalable nullifiers can work in a post-quantum setting. There was the idea I had about how to make diversified addresses work with post-quantum key privacy. And this is an important question. How should we decide how to prioritize post-quantum stuff? Okay, so let's leave it. Actually, I will go through the calls to action. Yes, if you're an ecosystem dev, do all of this, but I think the most important one is to treat addresses as secrets and pay attention to the security of wallet files. It's not okay to assume that they're less in need for security because they only have addresses and not private keys. Cryptographers learn about the constraints of real-world protocols. Public key sizes and ciphertext sizes are a big deal. And I will see you in Sophia. And yeah, we need to take post-quantum security seriously. And in the meantime, we need to fight fascism, because otherwise all of the cryptography in the world is not going to help us. Okay, I'll answer some questions. So how much work is it in theory to implement any sort of quantum upgrades in Zcash? Years or months? Designing the cryptography is not years, but deploying it might be. In your opinion, what are you most concerned about as PQ crypto evolves moving into the next 5 years? I'm concerned about the possibility that everything may happen a lot faster than we think it might be. Because there was what seems to be a little bit of a breakthrough by Google, I think it was, in post-quantum error correction. Sorry, in quantum error correction. And if that pans out, then we could see cryptographically relevant quantum computers faster than was previously thought, although it's still consistent with Bernstein's estimates. And then, yeah, I'm worried that the time to deploy major upgrades is very long at the moment, and we need to shorten it. Okay, I think that's everything. Do we have any more questions? The need to keep addresses private suggests that address rotation should be a high priority for all wallets. I completely agree. Fortunately, we're working on address rotation as we speak for Zashi. Outbound communications is a common topic. Has there been any consideration of rolling that in-house? I think this question was answered in a previous session, and I agree with the answer given there, which was that I think it was who said that so we should try and use stuff that has already been developed and already has a community around it, partly because that, and this is my observation, that also increases the anonymity set. Anything else? I wrote a demo to encode an ordered address with X wings at MLChem and Palestras. It is actually a random address, but it's the right length. It's using the Python test vector encoding in Zcash test vectors. So I will publish the code. Yes. Anything else? Okay. I think that's everything. That was fun. See you all.
Next. Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David
Duchovny. Sometimes I think I know too much.
Are the chupacabras real?
Huh?
Have you touched an alien?
Oh, God.
Has an alien touched you?
Why is that line moving so fast?
They're paying using digital currency. Not only is it super secure, it's super fast, and you can buy just about anything.
Imagine what I could do with all that free time. I will save the whales. Behold, I've done it.
Mr. Duchovny? Mr. Duchovny?
Yeah.
Can I get your zip code?
Come on.
Next. Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David
Duchovny. Sometimes I think I know too much.
Are the chupacabras real?
Huh?
Have you touched an alien?
Oh, God.
Has an alien touched you?
Why is that line moving so fast?
They're paying using digital currency. Not only is it super secure, it's super fast, and you can buy just about anything.
Imagine what I could do with all that free time. I will save the whales. Behold, I've done it.
Mr. Duchovny? Mr. Duchovny?
Yeah.
Can I get your zip code?
Come on.
Next. Find everything okay?
Yeah, but blueberries are out of season. You should rotate them with something citrusy and equatorial, like a pomelo.
You sure do know a lot about horticulture, David Duchovny.
So the emergence of cryptocurrencies, I think, was a wake-up call to regulators. Regulators have been used to operating in a world where they've had a fair degree of control and oversight over financial networks and the transfer of money, whether it's within their jurisdiction or internationally. The emergence of a decentralized peer-to-peer mechanism for transferring value that bypasses all of those traditional financial networks, I think is deeply concerning to them. And they have, been working to understand it and to get comfortable with it and understand how they can ensure that, they can continue to have oversight and regulate this new economic activity. I think they just about gotten comfortable with Bitcoin, and then something like Zcash comes along, which has got, is portrayed in the media as being anonymous and secret, and they've had to then start up that process again of learning about it. But we talk to regulators, we talk to policymakers to help them understand this technology, to help them understand the implications that it has for policymaking, for law enforcement, for regulation, for, preventing money laundering and terrorist financing. And once they learn about it, they start to understand that it's not all that different from, say, something like cash. We already have mechanisms in place to prevent money laundering using cash. And when you have something like Zcash, which is effectively digital cash, a lot of those same principles still apply. This idea that it's anonymous isn't really true. If you are depositing funds into an exchange, then implicitly that exchange has to have already done their know your customer checks on you. So they know who you are. They know that it's you that's depositing those funds. And if they need to query where the source of funds are, then they can do so relatively straightforwardly. So a lot of the principles that already exist, and a lot of the techniques that already exist, are applicable to these new technologies and these new currencies like Zcash. And it's purely a matter of helping the regulators and the policymakers understand that fact. So if you take the New York Department of Financial Services as an example, they worked very hard to understand what Zcash is, what the implications are for regulatory and compliance issues. We helped them, we helped educate them and help them understand those issues. And the outcome was that they granted Gemini, permission to add Zcash to their exchange. And the reason they did that was because they had gained that understanding. They were comfortable. They understood that Gemini would still be able to fulfill its regulatory obligations, that the fact that it was Zcash instead of Bitcoin had no impact on that whatsoever. And the reason that they were so keen to put the effort into understanding it is because they recognize that they have a key role to play in helping New York maintain its position as a global financial center. And if they overregulate and shut out this new industry sector, this new type of finance, then it's simply going to go somewhere else. So around the world, there are regulations and legislation that recognize the importance of personal financial privacy. In the United States, you have the Gramm-Leach-Bliley Act. In the EU, you have the GDPR. It's a theme in today's world where you have issues like the Experian hack, concerns over how data is being shared on Facebook, that people are growing more and more aware that they need to protect their personal data. And financial data has a need for particular protection because it reveals how much you're getting paid, how much you pay in rent or mortgage, what magazines you subscribe to, what websites you subscribe to, where you shop, what your hobbies are. There's a huge amount of information that can be gleaned if you can get hold of someone's credit card statements or bank statements. Now, when cryptocurrency go mainstream, if cryptocurrencies don't have technology in place to protect their users' privacy, then all of that information is going to be exposed to the world. So it seems strange that regulators would try to discourage the use of cryptocurrencies that include such privacy-protecting technologies and encourage ones which are going to expose users and consumers' information to the world at large. I think there is an argument for saying that actually, if you're going to offer cryptocurrency-based services to users, you at least need to make them aware of the privacy risks that they're incurring if they're not using privacy-protecting currencies. And secondly, to encourage exchanges and payment processors and so on to support currencies like Zcash that protect users' privacy.
I'm Chris Nuttycombe. The talk that I'm going to give today is about the zcash-devtool. The zcash-devtool is a platform for hacking on Zcash. My goal here is to show you just how easy it is to start working with the dev tool and a few things about what you can do with it. So to get started, this demo is going to be entirely live coding, and I'm going to start off by the way that a new user or a new developer using the dev tool would start off, which is just by cloning the Git repository and building it and running the help. So here we go. All right, get a clone of it. And in here, I'm going to just use cargo run to build and run the application. It's going to take a little bit to build all the dependencies, and so I'm going to give you then a bit more of an introduction while that's happening. All right, so what is zcash-devtool? Zcash-devtool is a command line application, and it's intended to be sort of the Swiss Army knife for the Zcash ecosystem. It contains in it tools for inspecting Zcash stuff, so Zcash addresses, Zcash transactions, PCZTs. It contains an embedded light client wallet that's built on the Libras Zcash stack, so using Zcash client backend and Zcash client SQLite. And we use it as, in development continuously to test out and prototype our new tooling. It's very useful in that you can hook it up to local dependencies. So if you're working on something in Zcash client backend and you want to test a wallet that's using that new functionality, you just provide you just use a local patch directive to refer to that dependency, and then you can immediately test the functionality that you're working on. So the first thing that I'm going to walk through once we're done building here is we're just going to start by looking at the help documentation. And then we will go through some uses of Zcash inspect. And then we're going to start working with the wallet. And in that process, we'll find some deficiencies in the current wallet functionality that's implemented. And we're just going to fix those as we go along. So hopefully you'll get a sense of how to get in and make changes yourself. So I see right now a question, the different roles that zcash-devtool and Zale play for developers looking to build on Zcash. So Zale is intended to be a robust wallet connected to a full node that provides functionality that's, say, suitable for exchanges, and that recapitulates the existing Zcash-D wallet APIs, RPC APIs, so that integration is easy for those sorts of partners. Zcash-devtool is actually very different. Zcash-devtool is it is a stateless tool, so each command that you run has some effect, but then it's done. And that's really useful you don't have to poke at a running system. You can sort of single step the operations of the wallet in order to really narrow down what you're testing. You don't have to worry about a system that's maintaining state and that is running all the time. You can just do a single thing. The other thing that's different between Zcash-devtool and Zale is that Zcash-devtool is really designed in this command-based fashion that makes it really easy to add new functionality. Whereas with Zale, since it's going to be a big running process, getting new functionality into that wallet may involve just more complexity. There's locking that has to be done and so forth. with the zcash-devtool stateless approach, you just write one command that does one thing, and you run it, and it does what it needs to do. Okay, so the first thing that we're going to use, that we're going to look at here is we just printed out the help, and we can see what commands are available to us. So the first one I want to demonstrate is just the inspect command. And the inspect command is kind of interesting because you can basically give to inspect anything Zcash, or at least that's the intent. So here I've given it a testnet unified address, and Zcash inspect gives me back some information about that testnet unified address. It gives me the network that it's on. It tells me what the various parts of it are. And if I were to look at just one of these parts, there, okay, it says, sure, this is a Zcash address. It's a valid testnet sapling address. I could throw other things at Zcash inspect. So for example, instead of inspecting a sapling address, I can inspect, oops, I need to fix my paste buffer here. There's a full Zcash transaction, and it will go through and it will tell me some things about that transaction. It'll tell me that it has sapling spends and orchard actions in it. It's in the process, it validates it. So if you ever have a Zcash transaction that that you're trying to broadcast to the chain and that's getting rejected from the chain, if there are any problems, Zcash inspect will tell me what the problems there are, and it has a relatively nice error display. The happy path here is kind of the simple case. All right, so that's an overview of Zcash inspect. Just throw whatever you want at it. You can throw PCZT serialized data at it. You can throw, and if there are other types of content that you think that need inspection functionality, it's relatively straightforward to add new parsers to Zcash inspect. And the way that it works is we just try out parsing with each different kind of parser that we have. And when we find one that works, we then execute all of the logic to show what you've got. All right, so the next thing that we're going to do is we are going to set up a wallet. So first, let's look at what commands we have available for the wallet. So there's a variety of things that we can, and the first thing we're going to do is just initialize a new wallet. To see how that works, we're just going to call wallet init and pass it the help flag. And now we see the different options that are available to us to actually set up our new wallet. So what I'm going to do is I'm going to set up a new wallet, give it a name. There's my ZconVI test. And I'm going to, I need to give it a directory to work in. And I'm going to let it specify its own passphrase and figure out its own birthday. I am going to pass an identity file. I'm going to just add in that dev wallet directory. You'll note that I'm setting up the dev wallet directory outside of the Git root so that I don't accidentally commit anything from my development wallet to Git as I'm working on it. So in here, So I'm just going to call that key.txt. This is going to be the default for the network is testnet. So I can set that anyway. And then for the server that I'm going to connect to, I'm going to connect to Zecrox. All right, so given that, it's going to set up a Tor connection so that it can pull the light client information over Tor. And now it's done. So if I look back at that dev wallet directory, I can see that I now have my key.txt file that I specified, a couple of SQLite databases, a blocks directory, and a Tor directory. And so now I have a wallet that's ready to run. So next thing I'm going to do, now that I've initialized, is let's just look at the balance. So, oh, no balance summary. I don't have enough information yet. That means that I need to sync the wallet. So, all right, there's sync done. And now I should be able to check the wallet. Sapling spendable 0, orchard spendable 0, unshielded spendable 0. But we're in a good place. We have now, you can see that it's displayed for me the default address for that wallet. And so the next thing that I need to do is I need to fund the wallet with some Zec, with some testnet Zec. And so to do that, I'm going to use the list addresses command. All right, so there's the default address for the wallet, and I'm a little bit annoyed. I've got this default address here, and I could copy paste it to Signal and send it to myself to my phone, but I actually, I have a testnet wallet on my phone, a testnet Zashi, and I just want to be able to scan a QR code. So I'm going to just go in and hack that in. I'm going to go in and work on the list addresses command and add the ability to display a QR code containing that address. So let's go do it. So I go and I find the thing that says list addresses, and all right, here's where my address is being generated. I'm pulling the default address from the account's UIVK and then encoding it. I know that I'm going to need to reuse that encoding, so I'm going to just do this. Oops. And I want to render this as a QR code. Now, I happen to know that elsewhere in this project, we already have QR code rendering. So I'm just going to steal some of that code and hack it in. And I think this is all I need. All right, so I'm going to generate a QR code with that UA string. And I need to make a couple of imports here. And then I just need to print out that, that QR code. All right, that's basically the change. That's it. We've just added the ability to take that string that we encoded for our unified address and, using a standard Rust library, spit it out to the screen. So let's see if it works. So it's going to have to rebuild because I changed a few things here. I think my IDE was helpful enough to keep me from making any silly errors. The computer's a little bit loaded right now because it's also running Zoom and running a testnet node in the background so that I can make sure that there's sufficient mining power. Oh, but there's our QR code. So I'm going to scan that in my testnet Zashi, and I'm going to send that transaction, and then that will get mined in a few minutes, and we will come back and take a look at it in a bit. All right, so that's we're now to the point where we have a funded wallet. We can take a look. So in order to find that transaction, once it gets mined, we'll have to sync again. And we can try it right now, just in case. All right, well, there have been some blocks added. So if we have a balance, nope, hasn't arrived yet. So that's all right. We'll go off and do something else. All right, so the next thing that I wanted to do, so we've just gone in and we've edited an existing command to add some functionality so that it now displays this QR code so I can be lazy and use my Zashi wallet to fund my my test address here. But a really common thing that I want to be able to do is to refer to a local dependency to do some development. So I have libra-zcash checked out here, and I have it checked out on a branch. And that branch has some new functionality on it that I intend to use. The functionality that's on this branch that I'm really excited to test out is address rotation. So we've added more robust address rotation that takes transparent gap limits into account when generating addresses. And so I want to try that out in our zcash-devtool. So the first thing I need to do in order to do that is I'm going to need to add a patch directive to the cargo toml to point to my local development directory. So I'm going to do that here. And I have a set of patches that I routinely use, and I'm just going to paste those in now. Instead of these, I'm just going to paste these. So I'm replacing all of these pinned revision patches with paths to my my local checkout of libra-zcash. And let's rebuild just to make sure that everything is still working with our existing functionality, but building with that new branch. Okay, while this is happening, I see a question, can I connect zcash-devtool to a local Zebra node with LightWallet D or Zino? Absolutely. In order to do that, you're going to need to hack on zcash-devtool a little bit. So we can go and look at that in just a moment here. Let's see. Let's just, while that's building in another pane, we can look at it here. So if we look at source-remote.rs, you can find all of the servers that we currently have hard-coded. And there is, you can also just provide a hostname :port when specifying your LightWallet node when you specify the server. All right, that built fine, still no balance. So the next thing we're going to do is we're going to add a new command. Oh, are there things that the dev tool should not be used for? This is a dev tool. Don't commit a significant amount of funds to it. We can't stop you from doing that, but it's generally not wise. This tool may be broken at any given time with respect to its, if it's being used to test out new functionality and there are bugs in that new functionality that haven't been released yet. The DevTool repository frequently points at patch revisions of our libra-zcash crates, and so you can't rely on it to be a safe place for storing funds. It is intended for development. All right. So I'm going to go in and I want to add a command to add address rotation so that we can generate a new address. So I'm going to start from where we just were, the list addresses command. And I'm going to look at the directory it's in, and I'm just going to add a new command, a new Rust module here. So genadder.rs says it's not included anywhere in the module tree, so I'll have to fix that. Maybe I'll go and fix that first. And I'm just going to put it here. Okay, that's fixed now. So the next thing I'm going to do is the classic, what do you do when you're hacking on a new system? You copy paste. Copied my genadder command into here, and now we're going to start editing. All right, so for a lot of purposes, this is going to be kind of the same. We still want an account ID to be something that you can specify on the command line, so I'm going to keep all of that functionality. But instead of getting the default address from the UIVK, I'm going to use a function on the wallet write trait, which is implemented for the wallet database, to generate a new address. So this is the newly added function that has just been added to LibreZcash. So I'm going to say db data. Oh, and this is not yet giving me. I'm going to just help my IDE out a little bit here. I know I just added that to the wallet write trait, so all right, apparently it's taking a little bit for my IDE to catch up, so I'm just gonna, well, let's go back and take a look at. Oh, it's because I'd forgotten what I called it. And I need to look at the arguments here. I need an account ID and a unified address request. So I have an account ID, and I need a unified address request. And I'm just going to ask for an address with all available keys. And this this method, I know if I look back again at the type, it returns an option of tuple of unified address and diversifier index. And so I'm just going to, I know that there are keys available here. For right now, since I'm just hacking, I'm just going to unwrap this because I know that I just used a valid account ID. All right, so, and this is not default address, this is just the address. Everything else here, I think it's going to stay the same. So let's try and compile it. I should have done cargo check with all features. All right. So this is the command that I've just created, but I just remembered I forgot to do something in the process. When I went in to add the module to the wallet file, I didn't actually add a command. So let's do that. Let's just add a command. All right, and so now, once I've done that, okay, get next available. Oh, there's a problem with my get next available address. And that's just because I didn't need this when I previously initialized my wallet database, but I need a clock because one of the things that our new address generation functionality depends upon is for shielded only addresses, it will use timestamp based address generation to basically make it so that you don't have to do as careful of bookkeeping of diversifier indexes. That's only used for shielded only addresses because if a transparent address included such a receiver, then you would have gap limit violations. All right. So there's one more thing that I need to do. I'm gonna build it again. So I've added this command, but I need to actually add the command to main. So right here, it's complaining that I haven't added this. So what I have to do is change that little bit. And now when we run this, we should get a new command in the help. The CLI framework that this is built around is called CLAP, and as you can see, it's pretty seamless to create a new command line option or a new command line mode to allow you to build out new functionality. So there's a question in the chat right now. How is this tool designed in order to add new functionality like ZSAs, new memos, etc., being becoming in the next Zcash network upgrade? All right, so there's our generate address command. Let's try it out. Oh, I forgot to. And there we go. And if I scroll up a little bit, you test 1QLF. And now if I call it again, you test 1Q38. So we are successfully generating successive addresses. And we've just added, new and useful functionality to zcash-devtool. Now it probably needs to be cleaned up a little bit. But that's the foundation, is that you can readily go in, add commands, access your local branches that you're building on. So the question in the chat is, how is this tool designed in order to add new functionality like ZSAs, new memos, etc., that may be coming in the next Zcash network upgrade? The answer to that is that the core functionality will be going into Zcash primitives, Zcash client backend. ZSAs will be going into the orchard crate. Each part of the stack, as you build it up, you'll be building it with unit tests and so forth. But then when you want to actually, make the rubber meet the road, adding it to zcash-devtool ends up being a very quick and easy way to start playing around with that functionality. And if you decide, okay, well, we're going to now change the dev tool to connect to Kedit's testnet with ZSAs running, well, then you're running in an environment where modulo feature flagging and whatnot, you can start interacting with the ZSAs on an actual live testnet chain. All right. I think that that we're essentially at time now. So I'll wait around for a few more questions, but otherwise that's it. One of the things that I'll be posting in the next, well, as soon as I get the PR merged, is this. So this walkthrough markdown file goes through a bunch of the stuff that we just did in terms of setting up a wallet, and it also how to, we didn't ever go back and look for our payment. We should do that real quickly. So sync the wallet, check the balance, and there we are. I sent 1.3579 Zec of Orchard from my Zashi wallet. Okay, is the intention to use the same or similar wallet functionality in DevTool and ZLA? If so, a common crate be created? One tool depends on the other, or how will that work? In general, the way that I see this working is that functionality will be prototyped in the DevTool, and if there's functionality that makes sense to pull out, then we will probably pull that up into Zcash client backend or Zcash client SQLite as appropriate. We probably will not share too much code at like the CLI level because they are intended for separate modalities of use. But prototyping in the dev tool, it's very often that we can sort of pull a lot of functionality more or less directly across by copying and pasting and then making the pieces work in terms of the long-running ZLA process. All right, so I was just walking through. The other thing that we could do here, but we're out of time, is that there's in the walkthrough, there's a whole section on demoing PCZT support. So we can generate a PCZT using the dev tool, and we can use an import to a second dev tool wallet of a wallet's UFVK, so we can kind of simulate the interaction between an online device that just has a viewing key and an offline device that has a spending key. And working in this fashion was extremely helpful when we were developing the Keystone functionality, but it would also be hopefully extremely valuable to folks who are wanting to, say, update ledger integration or something like that. Does the DevTool work with a reg test node? I haven't tried using it with a reg test node, but I don't see any reason why it wouldn't. Yeah, it would just be a matter of pointing it at localhost. And the one thing that you would probably need to do is modify the dev tool, and please PR your changes upstream to be able to, for example, take network upgrade activation heights from a configuration file. So that's one respect in which the dev tool is not currently set up to work with regtest. All right. We have no more questions, so thank you all, and enjoy the remainder of your Zcon.